I'll take a moment here to introduce Analytics Sleep. We are a team of three people with over 30 years of experience in the world of analytics. During our tenure, we've worked across multiple domains like banking, pharma industries, telecom carriers, and we've come across and used a number of tools like SAS, MS Excel, Python, R, Tableau, to name a few. While designing the course, we've kept in mind to show you the practical application of these tools so that you can instantaneously start using them. Now, with the introductions done, I will move on to the course content. We have split the course into 10 modules. I will show you how the different modules look like. In the first module, we will be discussing some of the basics of Excel, like what are cells, what are columns, what are rows, what is a worksheet. We will then move on to discuss a toolbar. Now, for your easy reference, we've provided an ebook following each of these videos, which basically lists down whatever we have covered in that session. At the end, we've provided some exercises for you as well. In the second module, we will discuss some basic worksheet operations like how to format, how to switch from one window to another, among other things. And then we will move on to discussing cells and ranges and lastly cover tables in this module. Again, as I mentioned earlier also, we've got following each session over here, we've got ebooks and we've got their corresponding exercises. In the third module, we will discuss formats in detail and then we will discuss what is conditional formatting and also go through the different kinds of conditional formatting. We've got some really good exercises based on conditional formatting over here. Moving on, in the fourth module, we've got one of the backbones of MS Excel, formulas. Now the video over here, this will talk about some of the basics of formulas and then we've created some material for you. This particular Excel file consists of 50 plus functions. And for each of these functions, we've given a description of how the formulas work, what are the syntaxes for a formula, what are the different types of parameters which need to be passed. And then we've got some examples and exercises for you to work upon. My suggestion would be not to skip this chapter and do all the exercises before moving ahead. In the fifth module, we've got data protection and data validation. Now these are used in Excel to protect the data or the sanctity of the data, and again we have exercises built around them. The sixth module covers different kinds of charts. We've broken down the entire module into different sections based on different charts, and we've got exercises for you as well. Time and again during this module, we will ask you to pause the video in between and analyze the trends. This is all to give you a flavor of how charts are used in analytics. In the seventh module, we cover pivots. Again, this is one of the most important functionalities in Excel as a pivot table allows you to summarize data. We have a couple of case studies for you to go through as well based on real world examples. In the 8th and the ninth module, we cover some of the data analysis aspects of Excel. So in the 8th module, we are covering what if analysis, goal seeking, and then solver. Whereas in the ninth module, we are covering how to calculate descriptive statistics, ranks, percentiles, ANOVA. We are covering some of the statistical tests which are there, all using the data analysis functionality of Excel. Then we move on to the 10th module, which is VBA. From covering some of the basic building blocks of VBA, which is recording a macro, writing a simple macro, to creating your own custom functions using VBA, and then using events and form controls to create a user form. We've covered it all over here. At the end, we've got exercises based on all of these different topics which we are covering. Wishing you the very best and hope you excel at Excel. Bye for now. Thanks. Welcome back. As the name suggests, we would be discussing some of the basics of Excel file in this particular session. Following are the topics which we would be discussing: what is a workbook or a worksheet, how to create a workbook, what are cells, columns, rows, and what values can be entered in a cell. Now, the answer to the first question is very simple. An Excel file is called a workbook. Now, let's get started with creating one. Go to the Start menu and search for an Excel icon. For me, it is not present here, so I'll just scroll through the various programs I've got on my system. I've got the Excel 2007 version over here, but I would be using the 2016 version. This is the Excel 2016 icon. So I'll just click on it to open it. At the moment, I'll just select blank workbook. This is how an Excel file looks like. If you have an older version of Excel, that is 2003, 2007 or 2010, you may have noticed that as soon as you opened the file, you had 3 sheets over here. So I can add more sheets to my file in the 2016 version by just clicking on the plus. In the older versions, it's the default setting. So not much of a difference as such. Now, an important thing to note over here is that these tabs are independent of each other. So you can do anything in sheet 1 without impacting your work in sheet 2 or sheet 3 and so on. Now let's talk about the naming conventions of these sheets. Supposedly I want to rename this particular tab or worksheet as it is called from sheet 1 to something else. I'll go to sheet 1, I'll do a right click of my mouse and this menu will pop up. I click on rename and now I can enter whatever I want to. Another thing which you need to keep in mind is in one Excel file, no two tabs or worksheets can have the same name. So if I want to keep the name of my second tab also as my work, Excel will give me an error. Let's see. Excel throws an error that the name is already taken, so try a different one. So in order to differentiate it from the first name, let's say I just add a numeric 1. Now because it is different, Excel is okay with that. There are some special characters also which you cannot use while renaming a tab or a sheet. In the document following this video, I've given a list of all those special characters, some of them being a question mark or a star or a slash. Now you may have noticed these boxes. These boxes are called cells. In an Excel file, you've got millions of cells. In a cell, you can input 3 different types of values. You can enter a text, you can enter a number, or you can enter a formula. Let's say for a text, I've got someone's name, Gary. For a number, let's say I've got his age, 30. For showing how you can enter a formula in a cell, I'll give you an example. I've got 5 employees, A, B, C, D, F. I've got their salary, $100, $200, 100 again, 50, 300. Now let me just convert it into dollars. We will be going through the formats in detail in the relevant module. Now let's suppose I want to find out the average income being earned by these 5 individuals. So for that I will use a function average. The way to call a formula in an Excel file is by first typing equal to and then the name of the formula, bracket open. Over here I want to find out the average of these 5 cells, bracket close, and I've got $150. So these are the 3 different values which you can enter in an Excel file. One thing you may have noticed that whenever I'm moving my cells from one location to another, this particular area keeps on changing. So right now it is J10. Now it changes to H5. Now it changes to M13, J12. What this area name box basically gives me is the location of the cell or the address of the cell. Right now it is telling me that the cursor is on column J, row 12. If I move on to column H, row 7, the address changes over here. In Excel, the columns are vertical and they are named from A. As I keep on scrolling down, they keep on increasing A, B, C, D, and so on. After Z, they go to A, B, A, C, A, D. If I go to the very end, it stretches all the way to XFD. In total, you've got more than 16,000 columns in an Excel file. All the rows are horizontal and they are sequentially ordered 1, 2, 3, 4, 5, 6. As I keep on scrolling down, the numbers keep on increasing. And if I go to the very end, this is slightly over 1 million. So basically, you can have almost 1 million observations in your Excel file, which is a lot of data. Now, apart from the three different types of values which we can enter in an Excel file, we can also have charts, graphs, we can also import pictures in an Excel file. One final point on workbook or Excel files, you can open multiple Excel files together and can switch from one file to another, either using your mouse or there's a shortcut on the keyboard by pressing the Control key and the Tab key. Now with the introduction of workbooks and worksheets done, the next video will explain the top section of an Excel file. This top section is called a toolbar. Hi, welcome back. In the last topic, we had answered some basic questions like what is a workbook, how a workbook can be created, what are worksheets, the nomenclature around worksheets, and then we had also discussed what are cells and the kind of values which can be entered in a cell. Now, in this particular session, we will be discussing about a toolbar. The topmost section of an Excel file is called a toolbar. A toolbar has different groups. It has home group, it has insert, page layout, formulas, data, review, and view. Now what Microsoft has done is it has bundled up similar commands together in a group. So for example, in the home group, we've got all the commands related to alignment. We've got all the commands related to font. Let's take example of the formulas group. In the formulas group, we've got all the different types of formulas which are there in an Excel file. We've got the logical formulas, we've got the financial formulas, we've got text, date and time, we've got statistical formulas as well. Apart from the formulas, we've got some formula auditing commands as well. Now what I'll do, I'll walk you through these groups one by one and we'll discuss some of the commands which are used on a daily basis. Over here, I've got a sample of 9 students. I've got their sex, age, and weight. I've also calculated their average age, which comes around to be 12. So the way it has been calculated is we've used the function average and we've selected these cells. Now for starters, let's say I want to change the appearance of my column names. Let's say I want to change the cell colors. So for that, I'll go to fill color. There's a drop down over here and you can select any color you want. Let's say I select orange and the default font color is black, but you can select whatever you want to. Let's say I select green. Right now for this particular data, the font type is of Calibri. Let's change it to, and you can notice the difference. Over here it is Calibri, whereas over here it is Expert Sans Regular. So the way they are appearing is different. Let's make it consistent. So let's change this also to Expert Sans Regular. Now they are same. Excel gives you a lot of options. There are a lot of different font types over here. You can select whatever you are comfortable with or whatever you like. At the same point of time, you can also change the font size. So right now for this particular data set, it is 14. Let's keep it to 12. Now in this particular data set, all the values have been center aligned, but by default, all the character values are left aligned, whereas all the numeric values, they are right aligned. But it's always better to have them center aligned. It makes it more representable and easier to read. So using these buttons, you can either left align them, you can center align them, you can right align them. Now let's create a table. So clicking on borders, it gives you various options of the kind of table you want. Right now I want to have borders for all the cells and the overall data set. So clicking on all borders and selecting this option, I've got borders for all my cells over here. Let's use some of the other font options as well. Bold just bolds the text which you are selecting. Italic you can also underline. Now let's use the cut, copy and paste options. Supposedly I want to cut this information from row 12 and paste it onto row 11. So I select them, I go to cut. There's a shortcut as well, Control plus X. Click on it, go to row 11 and then click on paste. This is how you use the cut and paste option. Now, in order to understand how a copy and paste works, supposedly now I want to move this data from row 11 to row 12, but at the same time, I don't want to remove it from row 11 as well. So I go to row 11, I select the cells and then I go to copy. I go to row 12 and I click on paste. Now, as soon as you did this, you will get a smart tag. And this only comes when you are doing a copy and paste option. When you click on it, it gives you different options. Paste is what we have done. Now formulas. If I do a formula, let's see how this cell will change. Okay. Now supposedly I just select on formulas. It will just keep the formula, but all the formattings and everything will be gone. If I select formulas and number formatting, it will keep the formulas. It has the formula over here similar to this, just that it is not taking the other formatting, which is cell formatting. The number formatting is still there. It is appearing as 12 over here. It is appearing as 12 over here as well. Keep source formatting. So the format will be exactly the same from where we have copied the information. By selecting no borders, the formatting would be the same, just that the borders would be gone now. So over here we had borders, over here we won't be having those borders. Keep source column widths the same. So over here, because we are copying and pasting them in the same column, so it will not have much impact. Going to values. If I click on values, all the formatting is done. The formula is also done. So over here we had formulas, over here the formula is done. It's gone. Values and number formatting. So this is similar to formulas and number formatting. Just that over here we won't be copying the formula, only the value would get copied. So it will show as 12, which is the same number format as over here, just that the formula is gone now. Value and source formatting. The value would be there, all the formatting from the source would be there, just that the formula won't be there. There are other options also which we would not be discussing right now because they are not used that much. Now let's say I want to delete this particular row as I don't need it anymore. I select the entire row. I go to delete and I click on delete sheet rows. It deletes the row. Now let's suppose I want to delete weight column D. I will select column D and I will then just select a delete sheet column. It will delete column D. But because I would be using it later on, so let's just undo this operation, which is a shortcut Control plus Z. Similarly, we can use the insert commands also over here. Supposedly I want to insert a column before column B. So one option is to do a right click and click on insert. This is something which we'll go through in the next session. But over here using the home group, we'll select the column. We'll click on insert, insert sheet columns. This inserts a column. Let's undo it. Let's say I want to apply a filter over here. So I go to sort and filter. I click on filter. A filter gets created. I've got 4 different ages over here. I've got 11, 12, 13 and 14. Let's say I just want all the students who have an age of 11. So I click on age. I untick this and I just select 11. So now I've just got 2 cases over here for the students who've got their age as 11. And this is how, by clicking on clear filter from age, I will remove that filter. Let's say I want to look only at the female students. Then I untick the male ones. I've got all the female ones. And let's highlight them with any particular color. Let's say with blue. And now again I can remove the filter. There are other options also in the home group. Let's look at the sort and filter. So we've used filter. Let's say I want to sort this data. So I've got the custom sort. I've clicked on it. I want to sort them on the basis of their sex. I click on sex and I want to sort them basis the values in this particular column. And order A to Z would mean that F would come before M. So all the females would come before the males. Now let's say I want to add another dimension to it. So I go to sort and filter. I click on custom sort. The data is already being sorted by the sex. Let's click on add level. Now let's sort them on the basis of their age as well. So within males or within females right now, you can see in the female group got 11, 12, 11, 13. By adding a new level of age, it will sort the female group as well with respect to their age. So we'll have 11, 11, 12 and 13. Similarly for the male ones, we'll have all the ones which have 12 first, 13 and then 14. Let's move on to the insert group now. Pivot table. So you can insert a pivot table in an Excel file by going to the data set for which you want to create that pivot table, clicking on pivot table. Over here, the first section talks about the range. Over here, we are talking about column A1, cell A1 till cell D10. We want all the values. So we've got A1 over here and D10 over here. Then Excel asks us whether we want to have the pivot in the same worksheet, which would be the existing worksheet, or a new worksheet. Let's click on new worksheet and then OK. So pivot table gets created. Table option. Now we would be going through the benefits of a table in the next module, but in Excel it's always beneficial to let Excel know that this particular data set is a table. It helps in speeding up your work basically. In the insert group, you've got options like inserting pictures. You can also insert some inbuilt shapes, like let's say I want to insert a rectangle. You can change the color. Right now the default color is blue, but you can change it from here. Let's say you want to keep it blue gray, and let's say you want to add some text to it. So do a right click and click on edit text. Now in order to change the font, we go to the home group again. Let's say I want to increase the font to 16. I want to align it, do a middle align and then a center align. So there are lots of different shapes which you can insert in an Excel file. At times they help in creating a flowchart diagram also. Then you can also input charts as well. All the charts are over here. So just a simple example of a chart. Let's say I select sex and age over here and I want to insert a chart, a 2D column. What this chart tells me is that I've got 4 female data points over here with their ages 11, 11, 12 and 13. Similarly, I've got 5 data points over here with their ages over the y-axis. Let's do a control Z right now because I don't want the chart right now. Similarly, you can also input other objects or other Excel files using the object option over here. So basically you can import other Excel files or PowerPoint presentations within an Excel file. Moving on to the next group, which is page layout. This is mostly used for uh, changing the orientation from portrait to landscape, and it's more related to a page setup for printing purposes. Similar to your desktop, you can also change the background of your Excel file. Moving on to the next group, which is the formulas group. As I discussed about this earlier, it consists of all the different formulas. It consists of some commands used for auditing a formula. We will be discussing formulas in detail later in the course. Moving on to data. This particular group is used when we want to import data from other sources. So we can import data in an Excel file, from a text file, from an MS Access database. Then there are some options like filters and sorts, which are similar to what we had come across in the first section, that is the home group. There are some options of it: what if analysis, forecast sheet, data validation, which we would be covering in the advanced Excel module. Now let's look at remove duplicates. Let's make some changes to this data set. Let's say I've got the same information which I had over here appearing over here also. Now, this is just an example of 9 odd students, but what if I've got 10,000 records? It would be very difficult for me to remove the duplicate values by just looking at the data. So right now I know, okay, Alfred is appearing over here, Alfred is appearing over here also. But if I click on remove duplicate, it will take care of this particular row which is being repeated twice. So I select the entire data set. I click on remove duplicates. It will ask me on which all columns do I need to remove the duplicate. So I want to remove the duplicate basis all these columns. When I click on OK, it gives me a prompt: one duplicate value found and removed, 9 unique values remain. So this is how remove duplicates can be used. Moving on to the next section, which is a review section. This is used for proofreading. Basically, it can check the spellings in your Excel file. This is also used to protect your worksheet by locking some of the cells so that no one else can edit them. Or it can also be used to protect your entire Excel file. Last is the view group. The view group is basically used to change the way you are viewing the file. So right now, if I click on grid lines, all the cell borders appear now. But if I again untick it, the cell borders are gone. Similarly, if I untick formula bars, this formula bar goes off. If I click on headings, all my column names and row numbers, they are gone. Moving on to the zoom option. Right now the zoom is set at 100%. You can change the zoom from plus or minus over here also, but let's use the zoom command over here. Let's say I want to do it at an 80%. So it just shrinks the Excel file a bit. We will be discussing the next session around arrange all and switch windows. Last, I would want to discuss the file group over here. If you don't have the 2016 version but are working on an older version, you will see a Windows icon present over here next to home rather than a file group. But the basic functionality of both of them are the same. Clicking on file, you can open new Excel files from here. You can open another Excel file without going to a desktop or a folder in which you've saved that file. You can save an Excel file. Shortcut to this is Control plus S. If it's a new file which you have never saved before, then you can save it as whatever you want. You can give a command to print something, which you can also do it from the layout. And then you can also close the file. But for closing the file, rather than going to the file command again and again, you can also close it from here. Hi, welcome to the second module of Fundamentals of MS Excel. In this particular module, we'll have 3 sessions. The first one will concentrate on worksheet operations, like working with multiple workbooks, moving, copying worksheets from one file to another, inserting, deleting rows, clearing contents, hiding, unhiding columns and tabs. In the second session, we'll discuss cells and ranges. We'll introduce ranges, and we'll also discuss a go-to functionality which can be used to identify specific cells in an Excel file. The third session of this module will focus on tables and the benefits of tables with respect to an ordinary data set. Now, when you are working on Excel, it's not always necessary that all of your data will be stored in one Excel file. So you might have to open 2 or 3 or maybe more Excel files. Over here, I'll discuss some of the easiest ways by which you can move from one Excel file to another. Now, the first way is, if you're using a mouse, go to the toolbar and look at the different Excel files which are open, and then select the file which you want. So let's say I want to select all courses. Now the second way is, if you're not using your mouse, then you can use your keyboard and press on control key and then the tab key, and you can alternate across the various files you have opened. The third option is that you go to the view group and over here go to switch windows. You can see all the different Excel files which are open, and you can select module 1 toolbars, then another file opens. What if I select book 2? Another file opens. What if I select all courses 1? My first file gets open now. Now if you want to close a file, you can either go to the file group and then click on close, or you can just press the cross button over here. Now if the file is not saved on a system, then the Excel will always prompt you to save or don't save, depending upon whether you need it or not. You can click on save. Because I don't need this file right now, I just click on don't save. Now working with multiple workbooks at the same point of time is fine, and we've just discussed 3 ways by which you can move from one Excel file to another. But what if I want to look at all these workbooks at the same point of time on my screen? For that, I will go to view group and I will click on arrange all. If I click on tiled, it will give me all the Excel files which are open, and it will divide them into different tiles. To escape from this view, just you'll have to go to each of these files one by one and click on maximize next to the cross button over here. There are other options also. Let's look at one more option. Let's look at the vertical option. It divides the screen and puts them all vertical. Now let's say I've got this graph over here based on the employees data, and this is in the file all courses, and I want to move it to the file module 1 toolbar which has that data. So what I'll do is I'll go to all courses, I'll go to the sheet which consists this graph, I'll do a right click and I'll click on move. And over here I'll get an option to which book. Do I want to move it to module 1, which consists of the employee data? Do I want to move it to the third Excel file which is currently open, or do I want to move it to a completely new Excel file? Let's say I click on module 1 toolbar. And let's say I want to keep a copy of this particular tab in this file also. So I'll click on create a copy. As you can see, the tab has moved to the file which consists of the employee data. And you can still see that the sheet which consists of the chart is still there in all courses 1. If while moving the tab, if I hadn't clicked on create a copy, then the tab would not have been in the all courses 1 file. Now, doing a right click, we had discussed some of the options like insert, delete, rename in the first module. Now let's look at hide and unhide. So as the name suggests, hide, if I click on hide, it will hide this particular tab. Similarly, if I click on unhide, it will give me the list of all the tabs which I have hidden in this particular file. And clicking on say sheet 2, it will open the tab which I had hidden. Now in the previous module, we had also discussed about inserting and deleting columns or rows using the delete and insert commands on the home group. You can do the same functionalities using your mouse also. So supposedly I want to insert a column before B. So I select this column B, I do a right click of my mouse and I click on insert. It will insert a column before B. And if I want to delete this column, I click on the column, I select that column, do a right click and then click on delete. Similarly, I can insert a row. Let's say I want to insert a row before employee D. I select the entire row, do a right click, click on insert, and a row gets inserted. I can now delete this also by just selecting the entire row and clicking on delete. If I do a right click of my mouse over the rows or columns, I get the following menu. We've already looked at the cut, copy, paste options and insert and delete we've just discussed. If I do a clear content, it will not delete the column or the row, but it will just clear the contents. If I do a undo or a control Z just to show it again, So right now I've got in row 8 G and $1,200 by selecting this row, doing a right click, clear contents. The contents get deleted. The row does not get deleted. If the row would have got deleted, H, I, J, K, L, all they would have shifted one row above. So let's do a control Z again. Now let's do a right click and look at the other options. Row height. Right now it is 15. Let's see what happens if we change it to 10. The row height reduces. And what if it is kept at 100? It increases. So you can play around with the row height. Similarly, you can play around with the column width as well. Currently the width is 8.43. Let's say if I want to increase it to 12, it just broadens a bit. Again, let's do a right click. Hide and unhide options are very similar to what we had just looked at for the tabs. So let's say I want to hide the information for these three employees. I select these rows, I do a right click and select hide. So I can see over here that there is a gap after the fifth row and before the ninth row. If I want to unhide them, I select row 5 and 9, do a right click and unhide. Similarly, I can do the same operation on a column as well. Hide, hide it, and if I want to unhide it, then I unhide it. Now, when we'll move on to the next video, we'll discuss about cells and ranges. I've also given some exercises for you to practice so that you get more comfortable with this. Thank you. Hi, welcome back. Now in this session, we'll discuss what are ranges. And the second thing is we'll discuss a command go to special, which is in the home group. This particular command is used to identify specific cells. So if your cells have formula and you want to identify all such cells in an Excel file, then you can use go to special. If it has some comments inserted and you want to identify all the cells which have comments inserted, then you can use this. So, right, first of all, what is a range? A range is basically a group of cells. So this can be a range. Even this can be a range. This entire thing can be a range. When all the cells are together, it's called as a contiguous range. But when the cells are not together, then it's called as a non-contiguous range. So if I've got this cell, I've got this cell, I've got this, and this. If this is my data, then this is a non-contiguous range. But if all of my cells are together, it's a contiguous range. Now, usually when we want to move data from one cell to another, we do a cut and paste. So if I want to move data from G2 to I2, I will go to G2, I will do a cut, I will go to I2 and I will do a paste. Let's do an Control Z now. But what if I don't want to do a cut? I can similarly go to this particular cell, and right now you can see that there are arrows, black arrows, which you can see. Select the cell by just doing a left click and then drag it over to I2. This is how also you can move your cells. Similarly, you can move an entire range also. Let's do a undo again. Let's say I want to move this group of cells from here to here. So I'll just select the entire thing. I'll go over it at the corner of it so that the black arrows appear. Do my left click and then just drag the entire thing with the left click pressed. And then just let go of the left click and you can see that you've been able to move your cells. Now, before we move on to the go to command, we'll discuss find options and we'll discuss the replace option. Now, supposedly I want to find a particular name. Uh, I've got around 50 employees over here and I want to search for one particular name. Let's go to find and select and I click on find. Let's say I want to search if there is any Ben in the list. So I write the name and I click on find next. So because there was no Ben in this list, Excel says we couldn't find what you were looking for. Let's click on OK. Let's look for some other name. Let's look for Nia. Find next. Excel immediately takes me to cell A6 where Nia is present. Let's look at options. Now over here, what Excel is telling me is that where do I want to find Nia? Do I want to find Nia in this particular Excel file only, in this particular tab only? If I select the entire workbook, Excel will look for Nia in the entire workbook. Let's see if we've got Nia. We've got one more Nia over here in the email address. We've got Nia in another data set. So we've got 3 or 4 different tabs where Nia is present. But if I just select worksheet, Excel will only give me these addresses. Excel will not take the cursor to other data sets where Nia is present. Okay. Now supposedly while entering data, I mistakenly entered Ken instead of Ben. So what I can do is, first of all, I need to find out if there is any Ken. Yes. So Ken is here. Luckily, we've got just 2 instances where Ken is appearing. But what if we had used dataset and Ken was appearing say 50 times? You will not go to each of these cells manually and change Ken to Ben. So for that, again, we go to find and select. We click on replace. Now over here, I want to replace Ken with Ben, but only in this worksheet. I don't want it to be done in the entire workbook. And I click on find next. So yeah, right now it is giving me 2 appearances. Let's use replace all. Excel gives me a prompt, all done. We made 2 replacements. And I just do a close. So this is how you can use the find and replace commands. Now let's look at the go to special. At times you would want to identify all the cells, say which have comments in them. So rather than going through the whole data set on your own, you would go to special and click on comments and then just do an OK. So what Excel will automatically do is Excel will automatically highlight all the cells which have a comment present in them. Let's look at other functionalities. So if I want to find out constants, by constants I mean values which do not change, which are not formula based. So Excel basically highlights the entire dataset because this is a constant apart from 2 which are formula driven. Let's look at the other options. Let's say I want to identify the cells which have formulas in them now. Now Excel is highlighting only those 2 cells which have a formula in them. So these were some of the uses of the go to command. In a way, it helps you in quickly identifying whether there are formulas, and if there are formulas, then which all cells have those formulas rather than searching them manually. So when we move on to the next video, we'll discuss what are tables, and we'll also discuss the advantages of a table over a dataset. Thank you. Hi, welcome back. Now in this particular session, we'll discuss what is a table and what are the advantages of declaring a dataset a table over a normal data set. A table in simple terms is a group of data. So over here, it's a list of employees with their salaries and other details in front of them. It may also be a list of items in the stock at a supermarket and their quantities and prices mentioned. Now for letting Excel know that your data set is a table, all you need to do is you need to go to that data set and you need to click on table. Now before I do that, let me just make a copy of this data so that we can compare it with the normal data set, whatever we are doing over here. Okay, right. So I've got a list of 50 employees. I've got their names, surnames, their IDs, gender, email address, and salary. Now I want to declare the first dataset as table. So I go to insert, I click on table. It gives me a prompt, where is the data for your table? And right now the range which it has identified is of this. So it is from A1, B1, and I'm selecting it, and I go all the way down till row 51. And because my first row has column names, so that is why this will remain as a checked box. My table has headers. So then I click on OK. Now as I scroll up, immediately the first thing which you will notice is that the format of the tables has changed, and Excel has automatically given filters over here. Now let's look at the first benefit. What you may have noticed over here is that we had the home, insert, page layout, formulas, data, review and view groups, but the design group is new. This was not there in the earlier examples which we have done, because this is a conceptual tab which gets created whenever we use a tab or a pivot. So when I go on design, it gives me a ready-made table style. So there are different designs which I can use. You can see the colors changing as you move from one design to another. Let's say I want to select this design. So this is one of the benefits, that you don't need to format your dataset on your own. Over here in the normal dataset, there is no such design tab available. So I'll have to format the dataset on my own. Now let's say if I want to populate a formula, this is the annual salary. I want to divide it by the number of months per month. And as you clicked on per month, so basically you added an additional column. So it is very simple for you to change the table structure. Now, as you write a formula, all you need to do is, for calling a formula, you need to write equal to, you've got the salary over here, and you need to divide it by the number of months. As you can see, it automatically gets populated. But whereas in a normal data set, when you try and doing that, let's start off with adding an additional column. There is no change to the data structure as such. So is equal to this divided by 12. So one thing is that there is no automatic population of the entire data set over here. So you will have to manually copy and paste this formula for all of the 50 observations. So you'll have to do a control C, go all the way down, and then select all the way up, and then paste. Whereas over here it got automatically populated. So this is another advantage of having a table as compared to a data set. Okay, now let's go to the very end of this table, and we click on total row. A new row gets added. Over here, this is right now giving me the sum of all the per month salaries. But what if I want to calculate the average? So basically this tells me the average salary across these 50 employees. At the same point of time, let's look at the overall salary, and let's look at the average yearly salary. So this is 4581. So basically Excel is automatically giving you that option of calculating multiple variables. Over here, if I need to do that in a normal data set, I'll have to write the function on my own. So I'll have to call the average function, and then I'll have to select the entire data set. Though the results would be the same, but just that over here Excel is giving you that option. You can calculate other things also. You can count the number of observations. You can identify the maximum salary, minimum salary, standard deviation, variation, and you can call other functions as well. Now, as you have scrolled down, one thing you may not have noticed is that the column names over here, which were supposed to be A, B, C, D, E, F, G, they have now changed to the column headers which were there. So employee first name, surname, employee ID, gender. Whereas over here, that is not the case. When you click on first column, just notice the difference over here. So you don't need to highlight things on your own. Last column, then you can do a remove duplicate from here in the design tab itself. Now, after this particular video, you'll have some exercises and documents to go through. Please do go through them and please feel free to reach out to us. Thanks. Hi, in this session, we'll discuss formats. Now, formats are different options which are applied to cells or values within those cells, and they just change the appearance of either those cells or those values. Now, in one of the previous sessions, we had used some of these formatting options using the home toolbar. In this session, we'll look at some more options using the home toolbar, and at the same point of time, we'll also look at different ways by which formatting options can be used. So one is definitely the home toolbar. Now let's say I've got some values over here. So this is in a number format and this is in a currency format. Let's say I want to highlight this cell with some color. So I'll go over here and I can select any color I want. Let's say I select this. Let's say now I want to change the font color as well. So let's select yellow. Similarly, I can change the font type as well. So over here right now it's Calibri. What if I select Algerian? You can see the change over here and you can also compare it with this. Let me just zoom it a bit so it becomes more easier for you to compare the two fonts. So this is Algerian and this is Calibri. Similarly, let's I want to change the font size. Let's make it even bigger. Let's keep it to 16. So this is 16. This is still 11. Let's change this all to 16. So you can see the difference. Now let's zoom out. Okay, now we had also looked at some of these alignment options. This is for left align, this is for center align, this is for right align, this is for top align, middle align, and bottom align. Now without looking at some examples, it won't make much sense. So let's select these cells. Using this option merge and center, I can merge all these cells together. So let's merge all of them together and then let's have a table around these cells. So now I've got this one big cell which is a combination of different cells, and you can see that the name box over here just shows K13, which was the first cell of this selection. Now let's type anything over here. So right now this is center align and this is bottom align. Let's see if I change it to middle align, how it changes the appearance over here. Similarly, if I do it a top align, align left, center align we already saw, and then right align. So these are the different options by which you can change the alignments. Similarly, let's see what this does. So this just puts all the text as vertical rather than horizontal. Similarly, let's look at angle counterclockwise. Excel is good. Angle clockwise. Let's look at rotate text up and rotate text down. Now wrap text. Supposedly I've got a lot of text in one cell itself. So right now, because there is no particular value in this cell, whatever we have written in this is sort of overflowing over to this cell. But if we have anything over here, so now we are not able to read properly what is written over here. So let's say when I click on wrap text, so everything I can see now in one cell itself. Then I can, using the alignment options, I can change the alignment over here to make it more readable. Now I've got this number over here 2345 and I want to change it to a currency format. So I'll go over here, I'll click on the drop down And I've got these different options which I can use. Let's select the currency one. So it automatically puts a dollar sign and adds two decimals at the back of it. If I want to have a pound sign instead of a dollar sign, I'll go over here and I'll select pound English. Similarly, you can look at more accounting formats by clicking on accounting, or you can click on currency also, and then you can go through all these different formats. Now, decimal places, this increases decimals and this reduces decimals. Now, let's say I want to get rid of the decimals over here. So this helps me in getting rid of the decimals. Conditional formatting is something which we will be going in depth in the next session. Now, this is one of the ways by which we can do a lot of formatting using the home group. Similarly, there are other ways also by which the same formatting can be done. But before jumping onto those options, let me just give an example of Format Painter again. I've got this format over here, and let's say I want to copy the same format of this cell to this cell. So I'll go to this cell, I'll click on Format Painter, and I'll go to this cell and then do a click again. So now the format gets copied automatically. Now let's say I've got this value also, and I want to again replicate the same format over here to these cells. I'll go over here again. Now I'll have to click twice. Let's say I've got two more values over here. Now if I just click on Format Painter once, right after clicking on this cell, when I'll go on this cell, the Format Painter option is already gone. So to make it sort of everlasting, you need to click on it twice. And in order to escape from it, or in order to remove Format Painter, you just need to click on Escape button. Now let's look at the other two options of formatting cells. So one is when you select a bunch of cells or even one cell and you do a right click, you have these options over here, this small toolbar. This is also very similar to the toolbar which you see in the home group. It has got options of bold, italic, center alignment, or fill color, font color. You've got the font type, sizes over here. Similarly, you can increase font, decrease font size, change the number formats and everything, similar to the home group. So we won't be going into these options because these are very much similar to what we've just gone through. Now, when you do a right click also, you get this particular drop down as well. When you click on format cells, a format cells dialog box gets opened. I've got 1, 2, 3, 4 over here, and I do a right click, format cells, number, it's already number. So let's put a comma. So as you can see, it adds a decimal point and it also adds a comma after the 1000. Let's again do a right click, format cells. Let's change it to some other currency. Indian currency. So this adds the Indian currency symbol R. Then again, let's do a right click. Let's look at some other options as well. So I've got the accounting, which is very much similar to the currency over here, what we've studied. Let's change it back to dollars. Now let's look at some other formats as well. Let's say I want to change the format over here. So I do a right click, format cells. And for date, let me select this. So now my date starts appearing like 10th Jan 16. Now let's look at the different options in the format cells dialog box. Let's click on alignment, and we're going to change the alignment for this particular cell only. Right now it's horizontal. Let's say if I want to do a left, because it's just one cell, the difference won't be visible that much over here as what we observed over here. But again, the alignment options are very similar to what we saw over here. Using this particular orientation box over here, we can change the orientation. Let's see. Now let me just do a control Z. Okay. Now let me just type some more data. Let's do a right click, format cells. Font, again, this is very much similar to what we saw over here. You can change the font type. You can select whether it needs to be regular or italic or bold italic. Then you can select the size over here as well. You can also select which color font you want, whether you want it to be, let's say, let's color it. So now you've colored your value over here. Let's do a right click, format cells. Now let's look at these options, strike through. So you can look at in the preview, as you can see, it sort of adds a line over here. Let's remove strike through. Superscript. Now where would superscript be useful? Now for this ST, I can use the superscript option. I select ST, go on format cells. I click on superscript. Okay. So now as you can see, ST is appearing after 1. So this is one way to use superscript. Let's look at subscript. So let me just select May over here, format cells, subscript. So it reduces the size of May now. Let's look at some more options. Let me type some more data over here. Do a right click, format cells, border. Border, as we saw from the font group over here also, you have got different options. You can select outline, and because this is just one cell, so that's why inside option is not available. But let's select a group of cells. Scroll down a bit, do a right click, and now using this, we'll have border for all the cells within the table. Clicking on OK. So you can see that for all the cells, you've got a border now. Let's look at the other options. What does this line do? So this will thicken the border, and if I want to color it, I'll have to apply it over here. Now I've got a table which has colored borders. Let's look at other options now. Format cells. Similarly, you can clear the table structure also by just selecting none and then click on OK. So all your table structure goes from here. Now let's do a format cells again. Fill. Now this again is to do with highlighting the cells. So if I use this and click on OK, so it just colors everything over here in the selected cells. Pattern color. is, let's take this pattern style. We've got different patterns over here which you can select. Let's select something which is more visible. So you can see how it changed over here. Let's click on OK. So these are the different formatting options which can be used to beautify your work. They won't make any changes to the values as such, but they are often used to highlight certain things. Now there is one final option which is there when you click on format cells and you go to protection. Now this is something which we will be looking at in the data protection module. And with the formats now done, the next session we'll talk about conditional formatting. As always, any questions, just drop us an email and we'll get back to you. Thank you. Hi, in this session, we'll discuss conditional formatting. Now, as the name suggests, this is formatting on the basis of certain conditions. In the previous session, we had looked at formatting, that is highlighting cells or changing the formats. Now over here, we will learn how to format cells on the basis of some conditions. So now let's take an example over here to help you understand the concept of conditional formatting. I've got these 10 numbers over here, and let's say I want to highlight all the cells which have a value of greater than 9,000. Now, one way is that I scroll through each and every value and keep on coloring the cells which have a greater than 9,000 value. So let's start with that. So this is greater than 9,000. Then let's just use the format painter. This is also greater than 9,000. This one, this one, this one, and this one. Now with 10 numbers, it doesn't take that much of time. Let's say I've got over here 50 numbers. So for 50 numbers, it would take me slightly more time. Over here, conditional formatting comes in handy. So let's select all these numbers. Let's go to conditional formatting, clicking on highlight cells rules. Now I want to highlight all those cell values or all those cells which have a greater than 9,000 value. Greater than 9,000. I've got these different options over here. Custom format, and let's say I want to fill them with yellow. Now as you can see, using conditional formatting, I didn't need to scroll through each and every value, and Excel automatically highlighted all those values which were greater than 9,000. So this is where conditional formatting comes in handy. Now conditional formatting is also useful in analytics because at times it helps us seeing trends which otherwise, if just looking at the numbers, we won't be able to recognize. So now let's go through the different rules in conditional formatting so that you've got a better grasp of conditional formatting by the time this session ends. Over here, I've got a 12-month data for 5 years. This is the electricity bill of a particular household, and these are the bills in dollars. Now, let's go to conditional formatting. For highlight cells rules, you've got different rules over here: greater than, less than, between, equal to, text that contains a date occurring, or duplicate values. So greater than we looked at in the previous example, but let's look at over here again. So let's select these bunch of cells, and let's say I want to highlight all those cells where the value is greater than 110. Greater than. So now very easily I can see all those months where the value is greater than 110. Similarly, if I want to replicate the same format over here for 2013, all I need to do is select these group of cells, go to format painter, and the conditional formatting gets copied. Now let's remove the conditional formatting from these rules. So we'll go to conditional formatting again, clear rules from selected cells, because over here we've just selected some cells, but since the sheet does not consist of any other conditional formatting, we can right now use clear rules from entire sheet also. So now the conditional formatting gets cleared. let's look at the second rule, which is less than. Let's say I'm interested in all those months where the bill was less than $90. So right now we just have conditional formatting in this one particular cell because that is the only cell which was selected, but we can copy using the format painter. So now Excel has highlighted 4 months where the bill was less than $90. Let's again clear this. Let's look at the third rule between, let's say I'm interested in 93 and 118. Click on OK. Excel automatically highlights them. Let me clear them first. So for that, I'll have to select these cells again. Clear rules. Let's look at the next rule. I'll select these cells again. Equal to, let's say 100. No, because there isn't any cell which has a value of 100. But what if we do 100 over here? Then this cell gets highlighted. Let's just do an undo. And now let's remove the conditional formatting from these cells. Let's look at the next rule. So the next rule talks about text that contains. So let's say I've got some text over here. And let's say I want to highlight all those cells which have A and B in them. Basically A, B in them. So text that contains. So it has highlighted those two cells where AB is there. But what if we have ADB? Let's see if this works. No, it does not, because AB needs to be together. So let's clear this formatting now and clear rules from selected cells. Now let's look at the next rule, which is a date occurring. Okay. So let's say I've got a bunch of dates over here. Okay. Now let's go to conditional formatting. A date occurring. So for yesterday, we've already got 29th May. Similarly, you've got these different options over here. Tomorrow, in the last 7 days, last week, this week. In the last month, if I do, I'll have 30th April. Let's look at the last option. So let's just select all of them together. Conditional formatting, highlight cell rules, duplicate values. If there is any duplicate value, it will highlight that cell with red color. And if they are all unique, it will highlight them all with red. So let's look at the duplicate value also. Conditional formatting, duplicate value. Again, it's highlighting both of them. But what if I just want to look at the unique ones? It's just highlighting those where the values are not getting repeated. Let's cancel. Now we move on to the other set of rules. These are the top bottom rules. Over here, the first rule is top 10 items, but again, you can change it. Let's say for this particular year, I want to highlight the top 2 months or those 2 months where the bill was the maximum. Instead of 10, I'll have 2. Again, I can change the format over here. So as you can see, if I click on OK, it will highlight this and this. Let's cancel it. Top 10%. So right now, I've got 12 months over here. 10% is around 1.2. So that's why it will just highlight 1. If I do it to 20, so now it will highlight 2. Let's look at the other one. Bottom 10, just similar to what we had for the top ones, this will look at the bottom ones. Let's say I just want to highlight the lowest one. Let's do a cancel. Similarly, bottom 10%. Again, it will just highlight one over here because as I said, for 12, 10% is 1.2 and I've got $80.22 in July. Now again cancel it. Let's look at all those cells which are above average. Average is basically the sum divided by the number of observations. So over here the sum is $1262.79, and because you've got 12 observations over here, the mean comes out to be around 105.23. So all the values which are above $105 will get highlighted. Let's clear this. Below average will again highlight all those cells which are below average. So using red text, it just changes the font color. It does not highlight the cells. So now let's move on to the other bit, which is data bars. So let's select all of them and I'll sort of zoom in a bit so that it's more easier for you to look at. Now with data bars, what we'll have for each of these selected cells, we'll have bars which will be visible in these cells. And if the value in the cell is larger, the bar will be large. If the value in the cell is small, the bar will be of smaller size. So over here, 131 is the maximum value. So that's why it has the largest bar. If I look at 80.22, that's the minimum value. So that's why its bar is the smallest. So again over here, we've got different types of colors which you can put in. So I can have green color. This is the red data bar, purple data bar, light blue data bar. This is orange data bar. Similarly, these are solid fills, just that the appearance of the bar changes. So over here it's blue data bar in solid fill and this is the gradient fill. Now let's clear the rule again. Now let's look at other options. Color scales. Over here the bars will not be there, but just that all the cells will be colored. So now if I select this rule, this says green, yellow, red color, apply a color gradient to a range of cells. The color indicates where each cell value falls within that range. So let's select this. So as you can see, the most green is the maximum value, which is 131.10. The lowest is 80.22, and as you can see, that's the most red. And as you keep on increasing the values, the numbers will keep on changing. Let's apply a filter over here so that you can actually see that change. So from here, the most red, it keeps on changing to amber, then it slowly changes to yellow, again yellow, then it starts turning to green. And in February we had the maximum number, so that's why it's sort of the most green number. Now let's just do a control Z and let's remove the filter and let's look at the other color scales. So the red, yellow, green is completely opposite of what we just looked at in the green, yellow, red. So over here the highest value will have the red color and the lowest value will have the green color. Then you've got different colors, green, white, red. Basically the whole idea is to have different colors for each cell so that you can see if there is any particular trend or not. So for example, this is just 1 year data. Let me just copy the same format across these years. So as it's very much visible over here, February is the month where you've got the maximum bill, and July is it's the most red over here, so it has the lowest values. So which sort of makes sense because in January and February the electricity bills are sort of high because of winters, whereas June, July, August, the electricity bills are on the lower side. Now let's clear the formatting and let's look at icon sets. Now these are the different icons which can be used instead of colors also. So let me select these cells and icon sets. Okay, so now what this tells me is that in the months of Jan, Feb, March, and December, my bill was high, whereas in the months of May, June, July, August, September, the bills were on the lower side, whereas around April, October, November, it was more on the average side. Let's clear this. Similarly, you've got different icons over here which can be used in the same way. So these are arrows, these are triangles, these are 4 arrows over here, these are 5. Similarly, you can have shapes, and then you've got indicators, then you've got ratings. So you can use all of these different icons and make your data visually more appealing. Whereas if I just go through all of these data sets one by one, it will take me time to get to the fact that in February the bills are higher, on in January the bills are high, in March the bills are high, whereas around June, July, August the bills are on the lower side. Now let's look at other options which are whenever we clicked on color scales or data bars or top bottom rules or highlight cell rules, we always came across more rules. Now format only cells that contain, this is something which we had looked at the very beginning, that this is based on cell value greater than, less than, or between, or less than, equal to, etc. Format all cells based on their values. Now let's look at this and we'll apply it over here. So let's select these cells, conditional formatting, more rules, format all cells based on their values. So over here, the lowest would be colored with amber. Let's say I want to change this to red. So this will give me a two color combination or two color scale. And this is very much similar to what we had looked at when we were looking at color scales. These are three color based. Over here, this is just two color based. So let me again, what if I change it to three color scales? I'll have the same red, yellow and green combination what we had seen earlier. Similarly, I can introduce data bars also from here, and over here also I can have the options of which colors I want, whether I want a border or not. Now let's look at icon sets. Again, this is something what we had looked at. So you can change your icons, and when you click on OK, so you'll have your icons present over here. Let's just remove conditional formatting from here, and now let's go to new rule. Okay, so format all cells based on their value. This is something which we had just looked at when we look at format only cells that contain. So again, this has options like between, not between, equal to, not equal to. So this is something again which we had looked at the very beginning. So if I want to select equal to 121.15, select on format, color blue. Okay, and if I want to paste it to the other cells, because there's just one value which is 121.15, this is the only one which is colored, but if I change this value also, then it will also get colored. Let me do a control Z, and now let me just remove the conditional formatting. Now format only top or bottom rank values. Again, this is something what we had looked at previously. Format only values that are above or below average. Again, we have looked at this. And format only unique or duplicate values. Again, this is something what we have looked at earlier. Now let's go back to this format all cells based on their values, right? Now let's say I've got these cells over here. When I click on more rules, I go to this format all cells based on their values. Right now, this is a two color scale. So over here, what it is showing is that the minimum value will be colored with this color, the maximum value will be colored with this color. So as you can see, the maximum value is colored with yellow, whereas the minimum with amber. Now let's select these cells. Again, go to more rules and let's select a three color scale over here. So now this is based on percentile. So the lowest value will be covered with red. The value which is around the 50th percentile will be colored with yellow, and the maximum value will be colored with green. So percentile is a statistics term, and the 50th percentile over here implies that the value which will be there on the 50th percentile, or the score, 50% of the observations will be less than this value. So let's see how this percentile works. So let me just use the percentile function first to calculate the percentile for this particular set of cells. Now because I want to look at the 50th percentile, so I will write 0.50 and press enter. Now over here what it is telling me is that this value, the 50th percentile value, is $106.01. So in this particular data set, 50% of the observations, that is 6 observations because it's 12 in total, will be less than this value. So let's count them: 1, 2, 3, 4, 5 and 6. So when we talk about in more rules over here, let's just look at it. So when we say that the value will be yellow for 50th percentile, what it says is that the colors will start changing, and towards the 50th percentile value the colors will be yellow, and then from yellow onwards they'll change to green. So let's do OK. And as you can see, towards the 50th percentile, which was somewhere around $106, the value is almost yellow. Clear the formatting from here. Let's look at more options now. More rules. Now data bar is something which we had looked at earlier also. What if I click on show bar only? So it removes the values, and now it's very much evident. If you look at this particular trend, it shows that the numbers were peak in February and then they reduced. There was a dip towards July, and then the numbers again started increasing. Just look at this curve. Okay, let's clear the formatting. Now again we'll go to more rules. Again we can do solid or gradient fill, which we have already seen. Negative values and axis. Let's see what happens if one of the values was negative over here and we do the data bars. Now as you can see, for the negative values it's a red color and it goes the other way, whereas for the positive values the data bar is in this way. Again, let's clear the conditional formatting, and let me just remove the minus sign. You can also change the negative values and axis. So you've got these options over here, which you can explore. You can change the color, or you can change the axis settings also. So usually it takes automatic, which is display at variable position based on negative values. You can select cell midpoint also. Now let's do cancel, and let's look at icon sets. So let's select three arrows. Okay, now over here, if I select OK, so right now it is showing me green arrows for these 4 months, uh, red for these five, and then yellow for these three. So it's interesting to know how Excel determines this. Let me just select these cells first. Conditional formatting, more rules, icon sets. Okay, so over here, what Excel gives a formula is that when value is greater than or equal to 67, it's selecting it as a percent, then it should be green. When value is less than 67 and greater than or equal to 33%, then it should be yellow, and otherwise it should be red. Let me just select the arrows also, because it's the same formula for these also. So you can play around and you can change these values also. Let's say if I do this 50 and I do this to 40, let's see what impact happens. So now for the yellow part, because I've reduced the range further, so now I just have got one cell which has a yellow color, and the cells which were having green colors have increased by 2. But what sort of percentage is Excel calculating over here? Because clearly this is not 67% of the total or anything like that. So the way Excel calculates this particular range or this particular number is, so what it does is, first of all, let me calculate the maximum of these, and then let me calculate the minimum of these. So let me now calculate the 67% and the 33% which Excel is talking about. So this will be right. So, and let me clear formatting from here, and let me again apply more rules, icon sets. So I've got 67 and 33 over here. So anything above 67% is green arrow, anything between 33 and 67 is yellow, and anything less than 33% is red. Let's click on OK. Okay, so now my 67% is 114.31. So any value greater than 114.31 will be green. Any value between 114 and 97 will be yellow, and any value less than 97 will be red. So how Excel calculates this is, it takes the minimum value of all these, it adds to it this. So what it does is, it first of all calculates the maximum of these numbers, then calculates the minimum of these numbers, takes a difference and calculates the percentage. Over here it's 67 and over here it's 33, and then adds the minimum to this product. So this is how Excel calculates this percentage over here. You've got these different options over here. You've got number, percent, formula, percentile. Let's use number. So I'll change the type to number first. Let's say for a green, I'll have any value over 100 as green. For yellow, any value between 90 and 100. And any value less than 90 will automatically be put as red. When I click on OK, as you can see, all the values greater than 100 have been given a green arrow. Any value between 90 and 100 a yellow, and then any value less than 90 has been given a red arrow. Conditional formatting also allows us to use formulas. So let's say I want to highlight all those numbers which are greater than 100 using a formula. So I've selected these cells already. All I need to do is I need to write the formula for if condition. I'll do an F4 twice so that I am able to remove that dollar sign. Greater than 100. If true, then do formatting. If false, then don't do. Let's choose a format type. Let's fill it with blue. Now let's say I click on OK. Okay. So it has copied the formula automatically to all these different cells, and wherever the value is greater than 100, it has colored them with blue. Now let's use another formula over here. First, let me clear the conditional formatting from here. Now let's say I want to color those months where the sum of bills over the entire 5 years has been more than $500. So I select all these cells. I go to conditional formatting, more rules, use a formula is equal to sum for these cells. Do an F4 is greater than 500. Let's color them with this particular color. Let's change the pattern also. This is visible. And now click on OK. So as you can see, Excel has now colored all those months where the sum was greater than 500. So this is why conditional formatting is a really important tool in Excel. It allows you to format based on some conditions or the values within those cells. Thank you. Hi. So in this session, we'll discuss formulas, but before jumping onto them, we'll discuss some of the basics first, like how to enter a formula. Let's take an example. Suppose I've got six numbers over here and I want to calculate the sum of these numbers. Now, in order to call or use a function, the first step is to use an equal to operator. This is then followed by the function name. In this case, it's sum, then brackets open, and then I specify the location of these cells which I want to sum, brackets close and enter 73. There is another way by which I can pass on these cells separately. So let's say I've got a number over here and I want to pass all of them separately. I use sum, brackets open. Now because I'm passing all of them separately, I will separate them by a comma. And the last one, brackets close, enter. Now there is another way by which you can call or use a function, and that is through the insert function or fx option. When you click on fx, a prompt like this appears. By default, this option is most recently used, and because I just used some function, so that is why I can see the sum function on the top. But because some function is related to maths, I select maths and trigonometry, and then I'll scroll down all the way down to S. I've got some over here. When I click on it, it gives me a brief description also that it adds all the numbers in a range of cells. When I click on OK, a prompt like this appears, and now I will be passing values of all these cells one by one. So these are the cell locations, and I can also pass them by selecting them together. Let's select the last one also. And when I click on OK, it gives me number 82. One thing you may have noticed over here is that this number is showing 82 over here, but in the formula bar, I can see the actual formula that I selected I4, I5, I6. Then I selected I7 to I9 together, and then I selected I11 separately. Over here, if I scroll down to the second formula which we had used, I had selected all of these cells separately. And if I select the first formula which we had used, it shows that I had selected all of them together. So formula bar is pretty useful when you want to see which cells consist of formula or not. Because if I go to I4, it just consists of a value 1. So that is why it's not showing any formula. But over here, it is showing a formula. Now, at times when you're working with formulas, you want to edit a formula, you want to add or delete a parameter. So the best way is you go to the cell which you want to edit. Either you click on F2 or you click on the formula bar. So Excel will then show you which all cells are being considered, and then you can accordingly alter your formula. Now, because we had selected all these cells together, their border has been colored with one color blue. In this case, if I click on F2 or if I enter the edit mode, because we had selected these cells individually, Excel has given them individual colors, has given them separate colors basically. Now, because we had selected three cells together, they've got the same color over here. Just helps in visualizing and editing at times. Now let's move on to another interesting topic, which is called locking the cells. Now supposedly I've got this formula over here 73. Whenever I change the values over here, Excel will automatically update the formula values. So let's say I want to copy this value to somewhere else, supposedly over here, but I want the formula to be also intact so that when I make changes over here, the value also gets updated. But what we can see over here is that when we copied and pasted it somewhere else, the range automatically changed. So initially the range was in column and our formula was in column J. Now that our formula is in column N, the range has shifted to column M. In order to ensure that this particular formula or column N keeps on getting updated whenever this range changes, one way is that we drag the range back to column I, press enter. Or the other way and the most efficient way is to lock down these values or lock down these cells. So when I'm writing this formula, all I need to do is I need to press an F4. What this does is when a dollar sign appears next to my row number and column name, what it shows is that the cells have been locked. So now if I remove this and if I copy and paste this formula over here, now the value is intact. This is called locking of the cells. Now over here, what we did, we locked the entire cell together. Let's take another example. Suppose I've got some data over here and I want to calculate the sum of these columns. So I want to calculate the sum of this, I want to calculate the sum of this and sum of this. So what I'll do, I'll write sum and then I'll select this. Now the best way is that I just copy and paste them. So as you can see, entering into the edit mode, that Excel changes the ranges automatically. Now what if I want to paste this value over here now? As you can see, the range has changed, right? Over here, we want to lock the row numbers. So the formula should be based on row 4 and 5. So how do we do that? When you are writing the formula, go to the formula bar, enter into the edit mode, press 1 F4. So when dollar starts appearing in front of the row number and the dollar is not appearing in front of the column number, that means you have locked the row number. So now if I copy it over here, I get 3. And if I copy it over here, I get 5 if I get copy, and so on. Now, what would have happened if, say, I had done an F4 over here, and so that I had a dollar sign in front of IE as well? When I would have pasted it over here, it would have worked fine. But when I would have pasted it over here, it would have not given me the correct values, because now we have locked the cells rather than just locking the row numbers. So this is something which you will come across as you get more comfortable with Excel, as you use formulas on a daily basis, and whenever you want to copy and paste formulas from one place to another. Let's look at some of the options now. So let's go to File and click on Options, select Formulas. Now the first option which I'll walk you through is Calculation Options. Now, what we had initially seen was that when we had changed the value of a particular cell, the value of the cell containing the formula automatically got updated. This is because by default, this particular option automatic is checked in. But if I do a manual, then let's do an OK. So now what will happen is, right now this particular cell is based on these two cells. Let's say I do a 5 over here, so the number is not updating automatically. So what you can do is, you can go to Formula toolbar, you in Calculations, click on Calculate Sheet, and then it will update the number. Let's go back to the options again. So by default, this is automatic, and that is the way it should be, unless and until you really don't want Excel to calculate the formula values automatically whenever the numbers change. So let's leave it to automatic. Another option which I'll discuss over here is formula autocomplete. What happens is, whenever you start entering a formula name after the equal to operator, Excel will give you options of the different formulas. So let's see how it works. So supposedly I want to calculate the average of all these numbers, right? So is equal to, as soon as I type A, Excel starts giving me all these different options. Let's continue to keep on typing. VE, I can see average over here using the down arrow button. And now clicking on tab, I select average. Now I can give the range of all these numbers, brackets close, enter. Now that we are in the formula bar, insert function is fx, what we just went through. Clicking on insert function again, these are the different types of functions which are here, or the different types of categories. It's same as what is mentioned over here in the function library. Now trace precedents, it shows arrows that indicate which cells affect the value of the currently selected cell. So I've got a formula over here. If I select trace precedents, it just selects the entire range and tells us that if we are going to change anything in this range, this value will get updated. I can remove arrows using this. Similarly, I've got trace dependents over here. Let's see what trace dependent will do. Supposedly I click on 5. Trace dependent tells me that this particular value is being used across all these functions. So basically, these functions are dependent on this particular value. Removing arrows to trace dependence. This particular cell J4 is being used in only two cells. One is over here and the other one over here. Let's remove arrows again. Show formulas. As you can see, it shows all the formulas which are there in the Excel file. Uncheck that. I will just come back to error checking in a while. calculation options, as I said, it should be automatic, but if they're not automatic and they are manual, then you can use this particular button, calculate sheet, for updating the formulas in this particular worksheet itself. And you can use calculate now using just F9 or this, or pressing on this particular button to update all the formulas in the entire Excel file. Now, error checking and evaluate formula, they come in handy whenever we are facing issues, whenever we are getting some errors in our formulas. Let's take a simple example. Supposedly I'm dividing 1 by 0. So it gives me an error. When I use error checking, Excel tells me that the formula or function used is being divided by 0 or empty cells. So it gives me an idea what type of an error can there be. When you click on help on this error, an Excel guide opens which gives you a brief idea of what different types of errors are. When I click on next, it will take me to the second error in an Excel file. So right now there isn't any other error. So let's just close it. Let's use another problem. 1 plus 1 divided by 0. If I click on evaluate formula, right now it is showing me 1 plus 1. And as soon as I click on evaluate, it shows 2. So the first step has worked fine, but the next step would be 2 divided by 0. And as I click on evaluate, it shows me error. So basically implying that there is some error when we are dividing 2 by 0. Now with these basics done, for you to have a better understanding of formulas, practicing them and using them is the only way for you to get comfortable with them. So for this, I've created an Excel file which has around 50 plus functions. And for all these functions, I've given a detailed description of their syntaxes. I've given a description of what these formulas actually do. For each of these formulas, I've given some examples, notes wherever I found applicable. And then I've also given you some exercises to do. What I would strongly recommend you is to go through all of these formulas, do all the exercises, and come back to me with any questions or any queries you have. Or if there is any particular formula which is not being covered by this particular list, then do let me know and I will help you out with that. Thanks. Hi, welcome back. Now the functions file which we have provided over here consists of somewhere around 50 plus functions, and we've tried to cover those functions which are used almost on a daily basis to manipulate data. Now what we've done, we've created some small videos wherein we look at some of these functions in detail so that you get more used to them and you can start using them in your work. Now the first function which we look at is if. Now, basically, if formula is used to check if a condition is true or not, and on the basis of that, it returns a value. Now, over here, we've provided the syntax for if function. So it is equal to, then we write the if function because we are calling it. Then we've got a parenthesis. Logical test is basically the condition which we want to check on the basis of which we want a particular value. So if the condition is true, then we will get value following the comma over here, and if the condition is false, then we'll get the second value. Now let's look at it how it works. So I've got an example over here. Now I've got 4 students, I've got their corresponding marks, and let's say I want to see if they've passed or failed over here. Now in the examples which we've provided over here in this particular Excel file, we've already used these formulas and then we've copied the syntax in the corresponding cells. But let's see how this works. So I'll remove this, and my passing marks are greater than equal to 40. So if the student scores more than 40, then he's passed, otherwise he's failed. So I'll use equal to. Now I'll call the if function. Now, as you can see that as you started writing, you got this automatic pop-up wherein Excel tells you all the different formulas which are starting with the if keyword. So because we want the if formula over here, now I've got if. I'll just click on my tab key and the parenthesis opens. Now the logical test over here is that the marks need to be greater than 40. So this particular cell consists of my marks greater than equal to 40. Now I'll put a comma because this is a syntax. Now because pass or fail is a text value, not a numeric value, so I'll have to use inverted commas, else fail. Now I'll close the parenthesis and I'll press enter. So now because this student had scored 90 marks, which is greater than 40, so that's why he has passed the exam. Now what you can do, you can either write the function for each of these cells manually, or you can also copy this function, select these cells and then just paste. So the formula automatically gets pasted and it will refer to these cells. So as you can see, it is referring to B23, B is this, and 23 is this. This one is referring to B24 and so on. Or you can do another thing. You go to the corner of this particular cell, and when you start seeing this black cross, just do a double click and the formula gets pasted automatically. So this is a function. I've got an exercise over here. So just go through it. And if you have any questions, then do let us know. Let's move on to logical AND. Now what AND function does is it basically returns a true or a false value. And it will return a true or a false value based on whether all the conditions which we have passed in the AND function, they are being met or not. So the syntax is equal to and then in the parentheses we are testing different conditions. Now in the if statement, if you remember, we were just checking one condition. In AND function we are checking multiple conditions, and if all of these conditions are met, then we'll get a true value. If even one of these conditions are not being met, then we'll get a false value. So let's look at this example over here. I've got the value in column 1 as 1, in 2 as 2, and I want to check if both of these values are greater than 0 or not. If they are greater than 0, then I will get a true value. If either of them is not greater than 0, then I will get a false value. Let's see how this works. So I'll call equal to and function is greater than 0, or I can even write it B19 is greater than 0, parenthesis closed, enter. That's about it. Now I can paste the formula over here. So as you can see, because in the first row over here, both of these are greater than 0, so we are getting true. But over here, one of the values is not greater than 0, and that is why we are getting false. I've given an example over here where we are using and if function together. So go through it, and then we've got an exercise based on both using and if. And this will give you a very good idea of how these functions can be used together. Next, we'll move on to a very important functionality of if function, which is basically called nested ifs. So now if you recall, if statement just checks one condition, and on the basis of that, if the condition is true or false, it will return a value. In nested if, we can check multiple conditions, and on the basis of that, we can then have a value. The syntax over here is equal to if, then we are checking the logical condition over here. If the condition is true, then we'll get a particular value. But if the condition is false, now instead of specifying a value over here, we are again calling an if function, which will have its own logical test, and it will have again its own value if it's true or if it's false. Now if we want to have more if functions involved over here, instead of passing a value over here, we can again call an if function. So this is again used quite a lot for data manipulation, or when you are trying to create some variables. Now let's look at the example over here. Now what we've got over here is table A has the score threshold. So if a student scores more than 70, then they'll have grade A. If they score somewhere between 41 to 70, they'll get a grade B. And if it's less than 40, then they'll get a grade C. And I've got four students over here, 90, 70, 20, 41. So now I've got three grades, A, B, and C. If we just had two grades, then probably we would have just used if statement. But because we've got three grades, we'll have to use multiple ifs. So let's see how we are doing it over here. So my E26 over here is this particular cell, which is 90, which is the marks for the first student. So how this formula looks is we are calling if formula, then parenthesis open. I'm checking whether my score over here, 90, is less than 41. If it is less than 41, then we'll get C. But if it is not less than 41, then I'm calling another if function. Now, what this if function again is doing is it is checking whether my score in cell E26 is less than 71. If it is less than 71, then it will give it a score B, else it will give it a score A. So this is how you can club multiple if statements together to check for multiple conditions. Now from Excel 2007 onwards, we can use 64 if conditions together. It does get a lot complicated as you keep on adding more if statements. But yeah, we can use 64 if conditions together, whereas Excel 2003 that just allowed us 7 conditions together. Now this is the last function which we'll cover in this video. In the next video, we'll discuss the text functions. Now OR function is again very similar to AND function. We are checking for multiple conditions over here, whether they are true or not, but it will return a true value even if one of the conditions is correct. So for AND, all of the conditions were supposed to be correct, and then only it would have given us a true value. But for OR, even if one of the conditions is being met, then it will return a true value. So for example, let's say I want to see if these values, if either of these values is greater than 0 or not. So let's see how this works. I'm calling my OR function and I'm checking whether A20 is greater than 0 or B20 is greater than 0. True. And then I'll just copy them. Now, in the first instance, because both of these values are greater than 0, we are getting a true value. In the second instance, one of the values is greater than 0, whereas the second one is not. But because one of them is greater than 0, we are getting a value true. In the third instance, because both of the values are not greater than 0, we are getting a false. I've given an example over here where we are using OR and if function together. And then the exercise which is following this, again, that uses both OR and if. So do go through them. Thank you. Hi, welcome back. Now, in this particular video, we'll cover some of the text functions, and these functions are used to manipulate data, uh, concatenate data, extract information from, say, a particular value. So we'll go through these examples as we go through these functions. Now, the first one which we'll cover over is the exact function. Now, this particular function checks whether two values are exactly same or not. And when I say exactly, it also checks whether they are in the same case or not. So it is case sensitive. So let's look at the syntax first. Is equal to exact and then text1 comma text2. So these are text1 and text2 are the values which we want to check whether they are same or not. So I've got these two cells over here. I've got Excel and Excel written in both of them. So it's giving it a true value, and that is because both of them are same. But when I compare Excel with Excel, where the latter part is in small case, you can see it's giving it as a false value because they are not correct. So this is how exact function is used. Let's move on to concatenate. Now, concatenate, as the name suggests, it's used to join several text strings into one. You can have, when I say text strings, it can be numbers, it can be texts, it can be dates. So you can just club them together. There are a couple of ways by which you can concatenate two or more columns. So one is by calling the function concatenate and then parenthesis string one, string two, and so on, whatever you want to concatenate together. Or instead of calling the concatenate function, you can use ampersand. So string one, ampersand, string two, ampersand, and so on. So let's say I've got these three columns over here, which consists of different data. So this is text, this is numeric, this is again text, and we just want to concatenate them together. So the first way is just use concatenate, pass the cell locations over here A20, comma B20, comma C20, and we'll get all of them clubbed together. The other way, as I said, is using ampersand. So A22 ampersand B22 ampersand C22. So that again gives the same result as using a concatenate function. Now you can also have spaces in between them. So for example, if I want my result or my output to have spaces between each of these strings, so I'll use the concatenate function. I'll pass on the first cell location, then followed by a comma. In my double inverted commas over here, I've got a space, then comma, then cell location again, comma, then again I'm passing a blank space, C24. So as you can see that all of these three strings, they have been concatenated together, but they've got a space between each of them. Similarly, just like you're passing on space, you can pass on semicolons or other special characters as well. So instead of a blank space over here, we've got a semicolon. So this is how concatenate function can be used. I've got an example over here, and so you've got three rows where you need to use the concatenate function and four where you need to use the ampersand function. So this gives you a good idea of how to use concatenate function. So let's say, for example, you've got name, you've got DOB, so Mark, Ted, Mark, date of birth is, let's say, January 18, then you've got Feb 18, then you've got March 18. Now, by the looks of it, if you just look at the name field, you'll say that there are two distinct records. But both of these marks are different people. One was born in January 18 and the other one was born in March 18. So if someone says you to identify unique records just on the basis of name, what you might end up doing is remove duplicates, and you're basically just removing mark getting repeated twice. So you might think of, as just two records. But let's say if you concatenate them together, and this is just a very vague example of how it can be used. Of course, you can do the remove duplicates thing on both sets of the columns. So now it gives you that there are three different records. So this is just one way how you can use concatenate function. But again, as I said, it's very vague example. Now let's move on to the next function, which is trim function. Now, as the name suggests, trim is used to trim something. And in the case of Excel, it is used to remove leading or trailing spaces or remove extra spaces between words. So let's look at the syntax first. It's very simple. You just call the trim function and then pass on the cell location. Uh, for which you want to remove the spaces. The first cell over here, this does not conserve any trailing spaces or anything like that. So it will give you the output just like it is. If you look at the second value over here, it consists of extra spaces in between. So calling the trim function, it removes those extra spaces. In the third example over here, we've got some leading spaces over here. So it just removes them. And in the fourth one, we've got some trailing spaces. So it removes them. So trim can be used when say you are doing a VLOOKUP, which we will cover later in the coming videos. So trim function can be used then, say you've got data from two different sources and one of them has, and you want to match both of them, say even if you're using an exact function and you want to match those, and now because this data is from different sources, one of them cuts off extra spaces, so you can then just use a trim function first and then use an exact function or a VLOOKUP function depending upon what you want. So I've got an exercise over here also, so just go through it and yeah, you'll get a better idea of how to use uh, trim and concatenate or ampersand together. Moving on to the substitute function. Now, as the definition states over here, it is used to replace a part of a text in a string with something else. Substitute function is also used to clean data, and this function is case sensitive. Let's look at the syntax. So first we are calling the substitute function. Then text is basically the cell location where you want to make changes. Old text is, say, the letter or the numbers which you want to change, and the new text is basically the values which you want now instead of the old ones, and the instance number is that particular instance of the old text which you want to replace with the new text. It is optional, but if you do not provide it, it will make changes to all the occurrences of old text with the new text. Now let's look at the examples below just to understand this better. I've got my string as hut and I want to make it as hub. So I want to remove this T. I want to replace it with B. So my function would be substitute. My cell location is A26. Then I'm substituting my old text, which is T, with B. So I'm getting as hub. Now let's look at the second one, which is Bumble, and I want to make it into Tumble. So I just want to remove the first B, not the second one, because then that will make it as Tumble, which I don't want. Now over here, then I'll have to specify the instance which I want to remove. So substitute, I want to remove B and that to the first instance of B, and I want it to be updated with a T. So this is my function. The next one is the car is in the driveway. Now let's say if I just want to remove the, so I'll just call substitute the, and over here I'm just replacing the by a blank space. The next one is the car is in the driveway. Now I want the result to be the car is in a driveway. So basically I want to remove the second instance or second occurrence of the in this particular phrase. So my substitute function would be substitute cell location the with an A, and I want to remove the second instance of the rather than the first one. The last one is the car is in the driveway. I want to remove the first the, so I'll just do a substitute A30 the. Now over here I have not specified any instance because as I said that this function is case sensitive, and over here this particular the has T as in capital, it's in uppercase, so that is why it is not doing any harm to the second occurrence of T. Again, I've got an exercise for you over here, so just go through it. The next one is text upper. As the name suggests, it converts the entire text string into uppercase. So I've got upper and then just passing on the cell location. So if I've got laptop over here, I want to change it to laptop with all capital letters. I'll just use upper and pass on the cell location. Similarly, if I've got Excel, I want to convert it into Excel with all caps, just use upper function. So that is all on the upper. Lower is opposite of upper. It will convert everything to lowercase. So I've got Excel over here using lower function. It will put everything to lowercase. Laptop with a capital L, we'll have everything lowercase. Length. Now length is used a lot with left and right functions, and it is used to extract data. So let's look at length first. So it gives the number of characters in a string, text or numeric value. It will also count the space and special characters. And as I said, it's used a lot for data manipulation or data extraction using the left and right functions. So I've got laptop over here. Now this has 6 characters. So if I call the function is equal to len and pass all the cell location, it will give me 6. Excel has 5 characters, but the reason I'm getting one extra is because I've got a trailing space over here. Superstore is closed, has 22 characters. 90, which is a numeric digit over here, has just 2 characters. Let's look at left. Now, this function returns the number of specified characters from the start of the string. So let's say I've got a string as my left would be from this way. So it's from this to this, and my right function would be the opposite side. So it would be from this side, right? Anyways, so the syntax is equal to left text, which is the cell location and number of characters. So let's look at laptop, and let's say I want the first 5 characters. So I don't want the last P basically. So I'll have is equal to left, my cell location, comma 5. So it is giving me the first 5 characters. Next one is Excel is wow, and I just want Excel is. So that's first 8 characters. Excel has 5, then a space 6, and then is 2. So that is 8 characters. So is equal to left cell location comma 8 will give me this. Let's say I've got a number over here 90 and I just want 9. So it is equal to left. Then I'm passing on the cell location comma 1. So this is how left function is used. There are 2 exercises over here. One just uses the normal left function and the other which uses left and length functions together, which is something I find really interesting for manipulating data. Let's say I've got data from a specific source, which consists of the name and then it consists of, say, the bank balance. And if I just want to extract the name, so I can use the left function. So as you can see, by using the left function, I can extract information from a specific phrase or a string. So as you start using length and left, right, mid functions more, you'll get more used to them. And these are very simple, straightforward applications of these functions. So then you can start making more complex functions out of them. Let's move on to the right function. Now, this particular function returns the number of specified characters from the end of the string. So as I said earlier, that left goes from A to H, whereas right goes from H to A. So it goes the other way. Now again, it's similar to left. It's used for data manipulation a lot, and the syntax is also very similar. Just that instead of left, we are using right over here. Let's say I've got my string as laptop and I just want top from it. So these are the first 3 characters from the end. So is equal to right A19 comma 3. Over here, let's look at 90 and I just want 0. So that's the first character from the end. So is equal to right A22 comma 1. Now over here, I'm using the length and the right function together. So what I'm basically doing over here is I'm using the right function. I'm passing on the cell location. I'm calculating the length of this particular value over here. And then I'm subtracting 16 from it. So again, I've given 2 exercises over here. One is just based on the right function itself, and the other one is based on right and length function together. So that is all what we'll have in this video. In the next one, we'll look at some of the date functions. Thank you. Hi, welcome back. Now, in this particular video, we'll cover some of the date and time functions. The first one is the date function. Now, let's suppose you've got your days, months, and years. They're all stored in different cells. Using the date function, you can pass on the cell locations of these different cells, and then Excel will return you a date. So the syntax is equal to date, then parenthesis, year, month, day, and let's say I've got this column which consists of years, this column which consists of month, and this column which consists of day. Now all I'm doing is equal to date. I'm passing on the year first, then I'm passing on the month, and then passing on the day. So that's about it on the date function. Date value. Now what this does is it converts a date which has been entered as text to date value, but in a number format. Excel basically stores dates in a number format. So the syntax is equal to date value and the date which had been passed on as text. So I've got these dates which have been passed on as text over here. So as you can see, there's an apostrophe over here, and that just makes it into a text. And what using the date value we are doing is we're just passing on the numeric value of this particular date. The next one is date today. As the name suggests, it returns today's date in a date format. If I write is equal to today, it will give me today's date, which is 27th of March. And say if I want to find out the date 5 days ago, so I will write is equal to today minus 5, which gives me the date 5 days before. So just like I've shown over here, you can use plus or minus with today to say give a date 30 days before or 30 days after, something like that. Now function. This function returns current date and time in Excel date and time format. So it's equal to now. So it tells me that right now the date is 27th of March and the time is 11:52. Similarly, I'm just doing a minus 5 and it tells me that it was 22nd of March 5 days before. Date, day, this function returns the day of the month, that is 1, 2, 3 till 31 in numeric format. So the syntax is equal to day serial number. So let's say using now function, I've got my today's date as 27th March. And if I use day function on that, it will give me 27. Similarly, this is the date 5 days ago. And if I use a day function, it will give me that day's date, which is 22nd. Month, as the name suggests, it returns the month. So over here, the date is 29th of March on 17, which is March, which is the third month. So that's why I'm getting the result as 3. Over here, it's 22nd of February. And because February is the second month, it's returning me a value of 2. Year, it will give you the year of the date which you are passing. Let's move on to minute now. Now this function returns the minutes between 0 and 59. So for this particular date and time, I've got 11:52. So the time is 52. Similarly for 10:15 a.m., the time is 15. 10:20 p.m., the time is 20. Hour, this returns the hour from 0 to 23. So if it's 11:59 p.m., which is the 23rd hour, it will return 23. For 10:15 a.m., this is the 10th hour, so it will return 10, and so on. Now in the next video, we'll cover a couple of lookup functions, which are VLOOKUP and HLOOKUP. Thank you. Hi. In this particular video, we look at two lookup functions. One is VLOOKUP, which is vertical lookup, and the other is HLOOKUP, which is horizontal lookup. Now VLOOKUP is used to search a particular value in a table and then return data corresponding to that particular value from another column. Now the syntax for VLOOKUP is equal to, we call up the VLOOKUP function. Now this is the value which we are looking for. This is the table array or the other table where we want to find this particular value, we will want a specific column. So that is what we are going to specify over here. And range lookup, so this is optional. It has two values. True is for approximate, and false, which is default value, for exact match of the value we are searching for in a table. This will be clearer with an example. Now in this table, this is my lookup table, and I've got gearbox, engine, steering, ignition, CY head. I've got three car manufacturers over here. Now in this particular table, I've got the maker and I've got the corresponding spare parts. And what I want is I want the cost. So for Mercedes ignition, I want the cost from this particular table. Now you can see that Mercedes ignition over here is 250, right? So using VLOOKUP, all I've done is I've used VLOOKUP. Now just let me scroll a bit up so that you can also see the syntax. Let me just hide this. Right. So now if you look at the VLOOKUP function, now B32 is ignition and this is my lookup value. So basically I'm looking for ignition. The next I look at is A25 to B29. So I'm looking at this particular table. Now in this particular table, I'm looking at ignition. And why I'm looking at this table? Because I want ignition cost for Mercedes. If I had wanted ignition cost for BMW, my table array would have been this. Now, because I'm looking at ignition cost for Mercedes, in my table A to B, which is A25 to B29, my costs are in the second column. So that is why my column index is 2. So in the case, if I wanted BMW ignition, the cost would have been in the third column. So in that case, my column index num would have been 3. But over here, because we are looking at Mercedes cost and the table is from A25 to B29, it just has 2 columns. And the last is false to get an exact match. Now let's look at another example. This is on BMW gearbox. Now BMW gearbox, my lookup value is gearbox, which is in my B33. And my table array would be this particular selection. Now over here, BMW values are in the third column. So that is why my column index num would be 3. And false again is for exact match. Let's look at one last example. Now this is for Audi engine 5200 pounds, right? Now Audi is in the fourth table. So this entire thing is going to be my table array over here. And my engine cost over here for Audi is 5200 pounds. So how I'm going about this is VLOOKUP B34, which is engine. And then I'm looking at my table array, which is this entire list of cells. And I'm passing on column index num as 4 because the fourth column in this particular table consists of the costs for Audi. And because I'm looking for Audi engine cost over here, that is why my column index num would be 4. And lastly, I'm passing as false because I want an exact match. Now this is another example. I've got table 1, which has cost of some of the items. Table 2, this is again the sales price of these items itself. Table 3 over here consists of these items and it consists of the units sold. Now for identifying the cost, what I will do is, because I want the pen cost and the cost is in this particular table, I will do a VLOOKUP. I'm going to search for pen, which is A54 cell. And then this is going to be my table array, which is from A47 to B50. Now, because the costs are in the second column, it would be comma 2 and then false for exact match. Similarly, the same thing is going to be for pencil cost, notepad, ink. Now for eraser, this is hash NA, and this is because the cost table or the sales price table do not consist of eraser. So that is why we are getting a hash NA over here. Similarly, for sales price, I will refer to table 2. Again, if you look at the formula, I'm looking for pen. in this particular table, which is my table array, it starts from D47 to E50. And basically, because my sales price are in the second column, my column num index is 2 and then false for exact match again. And then it's just doing some more data manipulation. So total profit is basically number of units sold into the difference between sales price and cost. So I've got some exercises over here for you. So if you go through them, you'll have a better understanding of VLOOKUP. Now let's move on to HLOOKUP. HLOOKUP is very similar to VLOOKUP, just that VLOOKUP over here looks at the vertical aspect, whereas the HLOOKUP would be looking at the horizontal aspect. Let's see how this works. So again, the syntax is going to be very similar. HLOOKUP, lookup value, table array, row index num. Now, because in VLOOKUP we were looking at the vertical aspect, we were looking at the column index num. But because in HLOOKUP we are looking at the horizontal aspect, we would be considering row index num. Then again, range lookup, this has two values, true or false, false for exact matches. Now I've got one table over here which consists of some commission for car type. Got car type as Mercedes, BMW, Audi, VW, Ferrari, and I've got the corresponding commission cost. Now this is the name of the employees who sold these cars, and for each and every car they sell, they'll get a commission. So now if I want to find out the commission which Ben earned for selling a Mercedes, I would use an HLOOKUP function. So I'm looking for Mercedes. This particular table is my table array. Now in this particular table, my commissions are in the second row. So that is why my row index would be 2 and then false is for an exact match. Let's look at Ken and BMW. Now value of BMW is in cell B35, which is my lookup value. Again, my table array is going to remain the same. It's going to start from B25 to F26, and the row which consists of the commission is in the second row of this particular table. So that is why comma 2 and then false for exact matches. Now, one thing which you may have noticed over here is this dollar sign. After the VBA module, we have a couple of videos which explain this dollar sign. This dollar sign is basically related to locking of a cell. And once you go through that video, it would be very clear for you. But as of now, whenever you are doing a VLOOKUP function, make sure that you've got these dollar signs. You'll get them by going to the range and pressing F4. So if I press F4 now, the dollar sign, one of the dollar signs removes. Now corresponding to the row number removed. Now the dollar sign altogether, the column and the row number have removed, and now I've got the dollar signs for both of them. So basically this is called locking of cells, and once you look at that video, you will be very clear about what I'm referring to. Now in the next video, we look at some of the math functions. Thank you. Hi, in this particular video, we look at some of the math functions. The first one is sum, and as the name suggests, it is used to return the sum of cells or the range selected. And the syntax is pretty simple. So is equal to, you call the sum function, and then in the parentheses, you pass on the cell locations which you want to add. Now over here, I've got three columns which I want to add. So my sum function looks like is equal to sum, and then I just select the entire range. Let's see. So I'm deleting this is equal to sum, and now I'm just selecting all the three cells together. So this gives me 34. Now, if I want to add this, now I can very well do it in the similar fashion, but over here I've selected these cells one by one. So this way we can select cells which are not written together. So for example, if there was a value over here also, and I wanted to add this particular value also to this, so all I would do is comma, just press enter. And there is another way by which you can sum cells, and that is using the plus operator. So all you need to do is, let me just delete this, is equal to this plus this plus this. Let's move on to the next one. Sum if I'm not going to cover over here. I've got another video after the VBA module which covers sum if, sum ifs, but do go through this exercise. Sum product. Now this function returns the sum after multiplying numbers in an array. It can also be used to count cells based on criteria provided. So let's look at the syntax is equal to sum product array1, comma array2, comma array3 and so on. Array 1 is the range of cells which first need to be multiplied and then summed. In array 2, it is optional, the second array or range to multiply and then summed. So let's look at this example. I've got items over here, whether they are perishable or not. I've got cost and number of units. Now over here, I want to calculate the total cost faced by the superstore. So first what I'll need to do is I'll need to identify the total cost for each of these items and then sum them all together. Now there is one way by which I can calculate the total cost. That is by first finding the total cost for each item and then adding them together, which is $7,993.5. Or using sum product, what I've done is I've passed on the array first C18 to C23, which consists of all my costs, and then I've passed on the second array D18 to D23, which consists of the number of units. So what Excel then does is it multiplies each of the corresponding cells and it gives us 7994, which is equivalent to what we've got over here. So using some product, we were able to get the total cost within just one statement rather than calculating individual total costs and then summing them together. Now the rand function returns random numbers greater than 0 and less than 1, and the numbers can change on recalculation. The syntax is pretty straightforward, is equal to rand and parenthesis. There are no parameters which need to be passed. And over here, I've already used the rand function, but if I press F2 and then enter, as you can see, all the numbers changed. Let's do it again. Now, rand function can be used while we are doing statistical analysis in Excel. Rand between. Now, this particular function returns random numbers between specified numbers. Now, with the rand function, we were able to generate random numbers between 0 and 1. But with rand between, we can have random numbers greater than 1 as well. Now, the syntax is straightforward, is equal to rand between. Then in the parenthesis, we are passing on the lowest value and the highest value between which we want the numbers to be. So over here, I've calculated my rand between 0 and 100,000. If I click on F2 and then if I click on enter, all of these numbers change. Now the next function we'll look at is math round. Now this function rounds the numbers to a specified number of digits, and the syntax is equal to round the cell location and the number of digits to which we want it to be rounded to. Now over here, if I want to round 45.3976106 to 45.40, that is basically to two significant digits, I'm using is equal to round cell location comma 2. Similarly, if you look at 85.4139 and I want to round it off to three significant digits, it gives me 85.414, 33.589, and if I want to round it off to 34, it is giving me round A21, 0. Even this function rounds a positive number up and negative number down to the nearest even integer. So 45.3976, the nearest even round digit would be 46. For minus 50, it would be minus 52. For 85, it would be 86. And for 33.58, it would be 34. Let's see if this was 32. Then also it is 34. And if this was 31, then it is 32. Math odd, similar to even, it rounds up the positive number and negative number down to the nearest odd integer. Mod function, this function returns the remainder after a number is divided by a divisor. The syntax is equal to mod number and the divisor. So let's say I've got a number 3 and divisor as 5. The remainder would be 3 as 3 cannot be divided by 5. 19 divided by 3, remainder would be 1. 8 divided by 2, remainder would be 0. And minus 8.5 divided by 3, remainder would be zero point 0.5. In the next video, we will look at some of the statistical functions. Thank you. Hi, welcome back. Now in this video, we will look at some of the statistical functions. Now the first one is min. This function returns the smallest number in a given set of values and it ignores logical values and text. The syntax is straightforward, is equal to min, then in parentheses the numbers which we want to check for, or the numbers from which we want to identify the minimum value. Now over here I've got three values, 3, 5, 3, and if I want to identify the minimum number, I will just call up the function minimum and then pass on this range, and it gives me the result as 3. Now 19a1, this gives me 1. It has ignored a text value. 8bc, it gives me the minimum value as 8. Minus 8.53 and zero point 0.5, it gives me the minimum value as minus 8.5. Moving on to the next one, which is max. It's opposite of minimum. It gives the largest value in a given set of values and ignores logical values and text. I will not be going through this particular formula over here. Average. This function returns the average value of the given numbers. It ignores text values and blank cells. The syntax is pretty straightforward, is equal to average, and then in the parentheses the range of cells for which you want to calculate the average value. Now over here I've got number 1, number 2, number 3, and the first row has 3 blank and 5. This is giving me as 4 because it is ignoring the blank cell. 19a1, again it will just consider these two. 8bc, it will ignore these two, and it's just giving 8 divided by 1, which is 8. And over here it is going to first sum all of them and then divide by 3, which is minus 1.6667. Moving on to the next one, which is small. This function returns the nth smallest number from the given set of values. Now the minimum function gives us the lowest value, but what if I don't want the lowest value? I want the second lowest value or the third lowest value. In that case, small or large functions can be used. Now small, my array or the range of cells, and the nth small number from the list. Now this is my array or list of numbers. Let's say I want the smallest number. So the smallest number over here is minus 8.5. So as you can see, I've just done small. I've passed on the entire array from A18 to C21, and then D18 basically consists of the value 1, basically the smallest number which I'm trying to identify. So it is minus 8.5. Let's say I want to identify the fourth lowest value. So for that, it gives me the result as 1. So again, I'm passing on the entire array, and then I'm passing on the value 4 as the fourth smallest number from the entire table. I've given you one exercise over here, so just go through it. It will help in better understanding this function. Large is exactly opposite of small, so I'm not going over here. Count. Now this function returns the count of number of cells which consist of numbers. The syntax is equal to count, and then we are passing on the different cell locations. So for example, in this particular row, I want to count the number of numbers. I'm just using is equal to count, and then I'm passing on this range. It gives me a result of 3. Over here, it gives me a result of 2 as a is not a numeric digit. Then 8 blank 20, again it gives me 2 because this is blank. Minus 8.5 blank b, it gives me 1 because this is the numeric digit over here. Countif. Now sum if, sum ifs, average, average if, average ifs, count if, count ifs, they're almost identical. And once you go through the sum if, and sum ifs video after the VBA module, you'll be in a better position to understand COUNTIF. But I'll quickly give a brief description of this function over here. Now this function returns the count of number of cells which conserve numbers and meet a specific condition. So I've got my COUNTIF, range, and my criteria, and this is that criteria which, if it is met, then only we want the function to count that particular cell. Now over here I've got 4 columns which consist of numbers. The fifth column, column E, it consists of the criteria which I want to check. So for the first example in row 18, I want to check, or basically I want to count all the numbers which are greater than 1. So by just eyeballing them, I can identify that there are 3 numbers which are greater than 1 and the fourth one is equal to 1. So if I look at the function, it is equal to COUNTIF. I'm passing on this entire range A18 to D18, and then I'm passing on my criteria, which is that it should be greater than 1. The second one looks at value equal to 0. If you just do an eyeball, there is only one value which is equal to 0. It is ignoring the blank cell. And as you can see with the formula, we are passing on the entire range A19 to D19, where value is 0, it gives us 1. Let's move on to standard deviation. Now this particular function gives us a standard deviation of a given set of values. In terms of statistics, the lower the standard deviation, the better, as it implies that there is not much variance in the data and the population is more identical. Blank cells, text, and error values are ignored. So standard deviation, and over here in the parentheses, we are passing on the numbers. Now this is my range of numbers over here. If I want to calculate the standard deviation of them, I'm just doing is equal to stdev.s, because this is just a sample, and then A16 to D16 is the range of cells. So it's giving me a value of 13.07. If I look at 42, 40, 47, 47, the standard deviation is just 3.559. And if you compare all of these standard deviations, this is the lowest. And as you can see, if you compare these 4 numbers also, they are more or less uh, near to each other. So that is why standard deviation is less. Variance is the square of standard deviation. So again, as with standard deviation, the lower the variance, the better. But it also depends upon what sort of analysis you are doing. Because if you're doing clustering, you would want the variance within a cluster to be less and variance between 2 clusters to be more. The syntax is equal to var.s, and then you're just passing on the numbers over here. And if you look at the last row over here, this has the least variance as compared to the upper numbers. Basically, the numbers are exactly the same as what we had for standard deviation. It's just squaring them. Let's look at the next function, which is correlation. Now, this particular function returns the correlation coefficient between 2 datasets or 2 arrays. Now, correlation usually lies between -1 and 1. If the correlation is negative, then it is termed as negative correlation. Otherwise, it is termed as positive correlation. If it is 0, then it is termed as that there is no correlation. Let's take an example of a positive correlation. Now, as a baby grows older, the baby's height or weight increases. So this tells us that there's a positive correlation because they both are increasing together. And if I look at a negative correlation example, let's say you've got your salary account. Now, as your expenses increase, the balance in your account reduces, which tells us basically when one is increasing, the other is reducing. So that is negative correlation. Let's look at the syntax is equal to correl, and array 1 and array 2, basically we're passing on the arrays between which we want to calculate the correlation. So this is my age and this is my weight. So as you can see, with the increase in age, the weight is also increasing. And if I use the correlation function on this particular array, it is giving me a correlation of 0.993, which is positive correlation. Let's look at median. This function returns number which is in the middle of all numbers in a data set. So is equal to median and then the list of numbers. So I've got this list of 20 odd numbers over here, and I want to calculate the median. And the syntax is pretty simple, is equal to median, and then I'm just passing on the cell locations. So it gives me 84. Now let's see if we can calculate it manually. Just copy them over here, put a filter, and then sort them. Now, as the definition states, it returns the number which is in the middle of all numbers in a data set. So I've got 21 observations over here. So the middle observation would be 11. The 11th observation should be my median: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, which is 84. Now, lastly, we'll cover normal curve over here. And basically, we can calculate it using average and standard deviation functions. And now I've got this list of data over here, which is somewhere around uh, 4,700 observations, and these are all random numbers. Now, the first thing for me to calculate a normal curve would be to calculate z, which is x minus mu by sigma. So x is my observation, mu is the mean of all of these observations, and sigma is the standard deviation of all of these observations. So I've calculated the z value for all of them. For calculating mu, which is mean, and sigma, I've used the average function, and I've used the standard deviation function, which we have just gone through. Now, once we have calculated z, we have calculated rounded z, which is using the round function. So we have used a round function for all of these values, and we've rounded them off to 0. And then using a pivot table, the maximum value for round z is 4 and the minimum is -4. These are the number of data points across all of these. So this is how our normal curve looks like. So that is all we have on the function side. Now, if you have any queries around a specific function which you use in your day-to-day work, or which you want to know more about, then just drop us a note. Thank you. Hi. In this session, we'll discuss about data protection. Now, as the name suggests, data protection is related to protecting data. In Excel, there are mainly two types of data protection. One is protecting the cells and thus protecting the data in the cell. And the second one is protecting the entire workbook itself so that the workbook can only be accessed by authorized users. The second part is sort of similar to having a password for your email address, having a passcode for your phone. But we'll come to the second part later. But let's just focus on the first part, which is protecting the cells and thus the data in a cell. Now, the question which you may be asking over here is that why do we need to protect the cells or protect the values within the cells? When we have multiple users of an Excel file, there might be a chance when someone may delete a formula or they might change the location of a particular column or they might change some of the values. So in order to ensure that this does not happen, data protection comes in handy. I'm not sure if you've noticed this, but when you select one cell or a bunch of cells and do a right click, go to format cells and go on protection, the locked option is ticked by default. And over here it states that locking cells or hiding formulas has no effect until you protect the worksheet. Now, by default, all the cells in an Excel file, they are locked. But as it states over here also, till the time we do not protect a worksheet, this will have no outcome or this will have no impact on anything. So what I'll do, I'll select a bunch of cells over here and I'll just do a format. And now I will unlock them. Now what happens is when you do data protection, your data protection passes on to each cell which has been logged. So the data protection will not be valid or will not result in anything to the cells which are unlocked. Now let's see how we will go about protecting a worksheet or protecting the cells. So go to review and then click on protect sheet. You can put in a password over here. So let's just put in a simple one right now, ABC. Okay, so right now by default, two options are selected over here. One is select locked cells and one is select unlocked cells. So what this is basically telling me is when I'm protecting my worksheet, the only thing which I will be able to do is I will be able to select my locked cells, I will be able to select my unlocked cells, but I will not be able to format my cells, I will not be able to format columns, rows, insert columns, insert rows. I will not be able to do any of these things. So let's see how it works. When I click on OK, it will prompt me again to re-enter the password. Now, right now I can select the cells, I can select these cells also, but when I double click on this cell, Excel says the cell or chart you're trying to change is on a protected sheet. To make a change, unprotect the sheet. You might be requested to enter a password. What if I go from formula bar? Again, the same error. What if I want to do anything to the column? Again, I have very limited options. And if I click on clear contents, it will give me the same message. But can I make changes to the unlocked cells? Yes, I can. I can write anything in the unlocked cells. Now let's unprotect the sheet again. And when we'll unprotect the sheet, Excel will again ask me for the password. Okay. Now what we'll do, we'll go through some of these options by checking them one by one and seeing the impact, what it will have. So let's click on format cells. I'm not putting any password over here because again and again I have to put the password, and then for unprotecting it again and I'll have to put the password. Sort of time consuming. Let's click on OK. Okay, so now I can format the cells also. Let's see if it works. Yes, now I can format the cells. Let's choose some other colors. But can I write anything? No, I cannot write anything in these cells. So let's go back again, review, unprotect sheet. Again, click on protect sheet. Now let's select format columns and format rows. So now I can at least format columns. I can change the column width. Similarly, I can do the same thing for the rows as well. Can I delete anything? Let's see. No, I still cannot do that. Let's see. Border, fill. So I can color the entire column or row also. Now let's just do a control Z. Just too many colors. Now let's see if I can, I'll protect my sheet again. We've seen that we can do formatting changes, but I also want to check if we can insert columns and rows right now. So I'm not taking them right now. So let's just click on OK. Now the worksheet is protected. No, I cannot because I don't have these options of insert and delete highlighted. Okay, now let's unprotect the sheet. Protect sheet again. Insert column, insert rows. Clicking on OK. Let's insert a column over here. Now I've got that option. Yes, I can insert a column now. Let's do the same thing for rows. Yeah, I can insert rows also now. Let's again unprotect the sheet, protect the sheet. Let's look at delete columns and delete rows. Okay, let's see if I can delete columns now. So as you can see, Excel's given me an error that I'm trying to delete a column that contains a locked cell. So it cannot be deleted right now. So let's just unprotect the sheet. Do a right click, format cells, protection, unlock. Okay. And now when I protect my sheet, I've got delete columns and delete rows selected. Now I can delete. Again, unprotect the sheet. Protect. Now for sort and use auto filter, I'll have to take an example. So let me just, right now the sheet is in unprotected mode. So let me just write some data over here. Name, salary, A, B, C, D, 100, 1200, 1300, 1400. Now for sort, let me just place a filter because once I protect the worksheet, I will not be able to place a filter also. And another thing is I can also calculate sum of salaries. So that would be sum, and let me calculate the average also. Okay, so now let's protect the sheet again. Let's click on sort. Let's see what happens without the sort option being there. So when I'm even trying to click on the filter, it's not working. So I will not be able to sort. And now as you can see, I cannot even change anything. So let's unprotect, protect, sort, use auto filter, click on OK. So let's see if I can sort now. I can see the options. Let's see. No. So the cell or chart you are trying to change is on a protected sheet. So for this to work, what you'll have to do is you'll have to unprotect the sheet. You will have to select all of them, go to format cells, protection, OK. And now let's protect the sheet again. Click on OK. Now I can sort. Let's unprotect the sheet. Let's protect the sheet again. I've got all of these options. Uh, if I click on use pivot table and pivot chart, for that, let me just draw a pivot first, because once I protect the worksheet, I will not be able to even create a pivot table. So I've created a new sheet. Now, irrespective if this particular sheet is protected or not, that does not matter to me right now. So using protect sheet, let's click on use pivot table and pivot chart. Name, salary. But if I do additional value settings, I can change count, average, max, min over here, but I cannot do any formatting over here. So the number of things which you can do with a pivot table when the sheet is protected sort of reduces. But let's go back to the original sheet. Now the main purpose of protecting a sheet is that no one deletes your existing data, or no one deletes your formulas which are there in the file. So I've got a formula over here. Let's just protect the sheet again. So now the sheet is protected. Can I alter this formula? No, I cannot. But because these cells, these are unlocked, I can alter these cells, which will then change the values in these particular formula driven cells. So this is one of the most important use of data protection, that you can keep your formula cells logged and thus protected. So the user or the multiple users who are entering data in an Excel file, they can change the input cells, but they will not be able to change the formulas. So thus you're protecting your formulas over here. Similarly, as I mentioned earlier, if the cells are anyways locked, then you will not be able to delete anything. You will even not be able to edit anything. So with the data protection done, let's move to the second part of it, which is protecting the workbook itself. So when you go to file and when you click on info over here, you can protect your workbook by encrypting it with password. So let's just keep a simple password over here, ABC, ABC, okay, and then go back. So now, and then do a save. Now, whenever you will open the file, Excel will prompt you for that password. So it's always important for you to remember that password, because without that, you will not be able to open the Excel file. Now, the last type of data protection which I'll cover over here is protecting your workbook. So what this does is it protects the structure of the workbook. So let's keep a password over here. So now I will not be able to add any new sheet. I will not be able to delete any existing sheet. So with the data protection now done, following this video, we have some exercises for you to do. And if you have any queries or any questions at all, please drop an email to us. Thank you. Hi. So in this session, we'll discuss data validation. Now, the first question which may have come in your mind is, what is data validation, or why do we use data validation in an Excel file? Now, when you create an Excel file, it's not always necessarily that you will be the only one who will be using that Excel file, or you will be the only one who will be entering data in that Excel file. There can be other users also who will be entering or using that particular Excel file. And when we talk about multiple users entering data in an Excel file, it's not always in the most consistent way that they would enter data. So for example, over here, I've got 9 people who entered their name, their age, their gender, their marital status. Now, look at the gender column. I've got options for male. I've got someone has mentioned as male, someone has mentioned as M. For female, I've got female, I've got F. If I look at the marital status column, I've got single, someone wrote unmarried, someone wrote married, then someone made a spelling mistake while writing married. So I've got these different options over here. And over here, I've got a table on which I had applied data validation. And if you look at the column entries for gender, and if you look at column entries for marital status, they are much more consistent. For gender, I just have either an M or an F. For marital status, I've got either a single or married. Similarly, if you look at the age column over here, now age is usually a number, but someone wrote 22.5, suggesting that that person is 22 years and 6 months, but I just need a number. So over here on applying data validation, if the person would have entered 22.5, Excel would have given an error that the value doesn't match the data validation restrictions defined for this cell. So in simple terms, what data validation does is it restricts the values which can be entered in a cell. So for example, over here in the gender column, I can either have an M or an F. If I try to write male, again Excel will give me an error. In the marital status column, I can only have either a single or a married option. If someone wants to write, then also Excel will give an error. So now what we'll do, we'll look at the different options in data validation and how you can apply them. So let's go to the first tab. Go to the data toolbar. I've got the data validation command over here. So I'll just select a bunch of cells over here, and then we'll just apply data validation or this restriction to these cells, and then we'll see how we can enter values or how or what impact it will have on those values. When I select data validation, by default, this would be any value, because as of now, there is no restriction which has been applied to these cells. When I click on this drop down, these are the different type of restrictions which can be applied. So a whole number restriction, that is, we'll just be able to enter only whole numbers, no decimal points. Decimals, they'll allow you to enter decimals along with whole numbers as well. List is something similar to what we saw in the previous example, male or female, married, unmarried. Date if you want the users to enter the date between two dates or after a particular date, time again similar to date, just that now we are dealing with time over here. Text length, this is with respect to the number of characters which I'm entering in a cell. So for example, if I'm entering A, B, C, D, E, F, G, H, so this is 8 characters or this is 8 text length. Custom is if you want to enter a custom function. So we'll study whole number, decimal list, date, time, and text length over here. And then I'll also walk you through what is input message and error alert as well. So now let's first apply the whole number restriction to these bunch of cells. When I click on whole number, I get an option in data over here. So I can select whatever I want to, between, not between, equal to. So let's just go with between. And let's say I want only numbers between 18 and 24. When I click on OK, so the restriction has been applied. Let's just color these cells so that we know which cells we have applied data validation to. Now, when I click on 18, 18 is fine. When I click on 17, Excel gives me an error that the value doesn't match the data validation restrictions. So I'll retry. Let's put 19, 21, 24 is fine. Let's try and put a decimal point. Again, Excel gives me an error. So let's enter 20. Now let's look at the second type of restriction. Let's color these cells again. Data, data validation. Right now, any value can be entered in these cells. Let's put decimal. Again, let's just choose between 18 and 24 over here. So I can enter 18. I can enter 18.1. Whereas in the preceding example, you saw when we were just dealing with whole numbers that it does not allow you to put decimal points. 23.9, 23.99. But if I just slightly go over 24.1, it will give me an error. 24, it's fine. The third data validation type is list. So let's just create a list. Let's cancel it. Let's first highlight the cells on which I want to apply this type of data validation. And let's say I want grades over here, B, C, D, data validation. I want a list, and the source of this list should be these particular cells. And now just click on OK. So for each and every cell, you will have this drop down, which will have these 5 options. And what if you want to write something else? Then Excel will give you an error. Let's look at dates now. So let me just highlight these cells. Go to data, data validation, date. Let's say I want to enter dates in 2017 itself. So this is fine. But what if I enter any particular date in 2016? So Excel gives me an error again. Let's look at the time one. Again, I'll just color these cells. And it's not important for you to highlight or color these cells on which data validation is applied. I'm just doing it for helping you have a better understanding on which cells we've applied data validation to. So data validation, time, let's look at midnight and 1 a.m. When I click on OK, so this is fine. This is also fine. But what if I do? So Excel gives me an error again. The last one is the text length. Data validation, text length. Let's assume that we want the number of characters to be less than 10. So let's enter 1, 2, 3, 4, 5, 6, 7, 8, 9. This is fine. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. Excel gives an error. Similarly, A, B, C, D, E, F, G, H, I. This is fine. Similarly, A, B, C, D, E, F, G, H, I, J. This will give an error. Now let's look at some of the other options, input message and error alert over here. So let's just select all these cells first. Data validation, input message, data validation applied. Please enter only whole numbers, no decimal points. So what the input message does is it acts as an insert command option over here. So whenever I will be on cells where data validation has been applied and this input message has been applied, whenever my cursor is on those cells, it will give me this particular message. It will display this message. So it makes it easier for the end user also to understand, okay, what sort of data can be filled in these particular cells. Now let's look at, again, I'll select these cells and let's look at error alert. So I've got stop warning information, and just to show you how this works, let's say I enter 25 over here. So you can see right now I'm getting a cross sign. I've got Microsoft Excel over here and I've got a default message. Data validation. Okay, let me again select all these cells. Data validation error alert. So I can select warning or information, warning, but I'll go with stop. I can write anything what I want. So when I enter say 25, it gives me a message wrong. Please enter only whole numbers. So these are some of the options for data validation, and this is how data validation becomes really useful when there are multiple users who are entering data in an Excel file. Now, following this video, we have another video which would be discussing about data protection. And following that, we'll have some exercises also. If you've got any questions or any queries, just drop me an email. Thanks, column chart. So over here, I've got 12-month data for company A. It's showing the company A sales and profit over 2016. So I've got the total sales over here. I've got the profit. Now company A has two products, product AB and product BC, and this is the profit from both of these products. If you sum up this is 5984, which is equal to the total profit over here. I've got this 12-month data over here and I want to plot a column chart which will have total sales and profits across months. So I'll go to insert and I'll click on the column chart over here. But just to call it out, in different Excel versions, in the older versions at least, it will be shown, this area would be shown differently, but the underlying structure remains the same. So you'll have the column charts over there, you'll have line charts, you'll have pie, static charts, scatter plots, etc. So let's go to insert column or bar chart. So right now I want to insert a clustered column chart. As you can see in the description, it's mentioned that use this chart type to compare values across a few categories, or use it when the order of categories is not important. So let's click on it. And as you can see that when you selected this data and went to insert a chart, Excel automatically plotted those data points over here. So let's just zoom in a bit so that it's more clearer to you. So I've got the legend over here. Using these buttons over here, this says that I can add or remove or change chart elements such as the title, legend, grid lines, and data labels. So let's click on it. And for legends, I'll click on it. I want the legend and I'll click on this black arrow and I'll click on top. So now the legend has shifted to top. For the chart title, I'll have company A sales and profit 2016. Uh, so over here you can see that total sales are represented by the blue bar, whereas my profit is represented by the orange bar. I can now add the access titles also. So I'll click on the chart, I'll click on plus access title, primary horizontal and primary vertical. So it has added both of them. If I untick this, then this will remove the primary vertical access title. Let's click on it and now we can edit. So this is months and this is sales slash profit in dollars. Now, how to read this chart? What you can see is that the sales over here, they are plotted over here. So if I go to January 16, it shows me that the sales of January 16 were $17,952, which is somewhere between 15,000 and 20,000 over here. Similarly, the profit for January 2016 is just over 5,000. Take a moment over here, and if you want to pause the video for a minute, please do, and try to see a pattern over here. Note it down, and then once you unpause it and play the video again, then we can discuss this. So as you may have noticed that the sales are going up every quarter, and as soon as a new quarter begins, the sales drop down again and then they sort of start picking up again, then they drop down again. So that has been the trend throughout the year. Similarly, if you look at the profit also, the profit is also following the same pattern. So every quarter end, it's the highest. And overall, if you look at the entire year, the sales have been increasing at the end of the year. If we compare it from the start of the year, or if we compare the quarter ends also, in the last month, December 16, the sales were the highest and so was the profit. So this graph clearly shows that there's a really close correlation or relationship between the sales and profit, which in real life is the case. Let's zoom out a bit. Now, one important thing which I would want to point out over here is that right now when you selected this entire data which you wanted to plot, and when you went to insert chart, this got populated automatically. But there is another way by which you can plot data in a chart. So let's say I just select a blank chart and now I'll do a right click. I'll click on select data. So my chart data range would be, and I click on OK. Now Excel has automatically put the months in the horizontal axis, as you can see over here, and it has put sales and profit in the vertical axis. I can automatically switch all the values from here to there, but this won't make sense. Similarly, right now it is fetching the correct data, so I don't need to make any edits or anything. So for series name, it is selecting this, and for series value, it is selecting the correct cells. So let's click on OK. If I want to remove total sales, I can just select total sales and click on remove, or similarly, I can add more series to it also. So let's just click on OK. So this is another way by which you can insert charts, or you can insert data in a chart. Now let's come to formatting of this. So whenever you click on the chart, this conceptual tab of design or format appears over here. So in the design toolbar, you've got these different ways by which you can make changes to your chart. So if I use style 8 over here, this is how my chart will appear. But let's just do a control Z, click on the chart again, design. Similarly, I can change colors over here. And as you can see, as you're scrolling through the different colors, the colors and the bars, they are changing. Similarly, you can select more data, or you can switch row or column, something which you can also do by right clicking on the chart and selecting data. And then you get these options from here also. From here, you can change the chart type quickly. And from here, you can move the chart also. But moving the chart can be by just clicking on it and then just dragging it somewhere else. Or you can also do a cut and then paste it somewhere else. Then you can again drag it wherever you want. So now let's talk about the other format. So one thing is around chart styles. So this just tells me the different charts, something which we had in the design option also. Similarly, colors, what we had just seen. And if I want to remove total sales, and if I click on apply, total sales is removed. Now I just got the profit, but let's undo it and click on apply again. Okay, now we'll discuss about the formatting of these horizontal or vertical axis. I've selected the horizontal axis by clicking on it. Now I'll click on format axis. This gives me different options. So Excel has right now automatically taken the minimum date, start date as 1st January 2016 and the maximum as 1st December 2016. I've got these fill and line options. So if I do a solid fill, then I can color my horizontal axis also. If I do a gradient fill, then also I can color it. But let's just do a no fill. That is usually the case. Let's see what happens when we do a solid line. So a solid line appears over here, which is good. Usually the line is there. It's shown with the black color. Now let's format the vertical axis. So over here right now Excel has taken automatically the minimum value as 0 and the maximum as 40,000. The major units, the difference is 5,000. So you can change these also. If you do a 10,000, and right now you can see that now you've got scale from 0 to 10,000, 10 to 20, then 20 to 30, and then 30 to 40. But let's just do a control Z. So if you click on number right now, Excel has automatically taken it as currency. These are different options which you can explore, but as such, they're just there to beautify your chart. Let's move on to the main chart. Now, this area is called the format plot area, and this entire area is called the format chart area. So if you click on the chart itself, it shows format chart area over here. And if you just click on the inner one, it shows the format plot area. So when you click on the entire format chart area, you've got these different options which you can explore. So most of them are related to fill. If I do a solid fill, you can color the entire chart. Gradient fill, this is all there to beautify the chart. Right now let's select a no fill. If I want a solid line, usually it's automatic, so automatically there is a line outside, this is gray. But if I select a solid line which is black, so as you can see the border of the chart is now black. Let's just do it automatic. Similarly, if you select rounded corners, as you can see that now the corners are rounded. If I do a control Z, you will be able to see the difference. Effects, again all related to how you want to beautify your chart. Let me select top right, and yeah, as you can see this line sort of starts appearing over here, this sort of shaded part which gives it a good feel. Let's look at format plot area. Again, you've got the same options over there. If I do a solid fill, this will get colored. You can change the colors from here. If I do a gradient fill, then it will get changed. Let's select a no fill right now. This is for solid fill, and this is for the border. So as you can see, there's a blue colored border now. Shadows again very similar to what we just saw. Side. Let's just do a color. So you can see a blue shaded line appearing now. Let's look at the bars itself. So when I click on any of these data series bars, it says format data series. So right now it's a automatic fill of this color. We saw that using the design bar also over here, we can change the types of colors, but you can do it from here also. So let's say if I want to select a light blue one, let me just do an automatic right now. Similarly, this will again create a shadow. In the first example where we discussed the components, we had discussed about the secondary axis. So over here, I won't be discussing it right now. We'll discuss some other charts and then we'll come back to secondary axis. Another way to format these is by clicking on the bars and then doing a right click, and then you can do format data series. Similarly, you can add labels also. If I do a format data series, I'll have this window again open. So yeah, it's one and the same thing. So let's look at the other charts in column bar. So this one which we discussed was a clustered column, and it's basically used when we got two or more variables which need to be plotted on a graph. Now I'll delete this and then we look at the second type of column chart, which is the stacked column chart. So when I click on stacked column chart, it shows me use this chart type to compare parts of a whole or show how parts of a whole change over time. So over here, this is not used for comparisons. As you can see, the cluster chart was for comparing values across a few categories or months. This is not usually used for comparing, but it is used mostly for showing the composition or the contribution. So let's select this and then do a right click, select data. Now I've got months over here and I want to show my profit from AB. So I will select my months first, then I'll select control and then I'll select the rest of it. Now I'll click on OK. So as you can see that my months will be plotted in the x-axis and profit from product A, B and product BC will be plotted on the vertical axis. Let me add a legend first. Legend on top. Let me just maximize it a bit. Okay, so over here, I've plotted company A, product A, B, and BC profit. So what this is right now telling me is that the total profit for company A was in the month of January 16 was around 5,000. But what it also tells me is the contribution of these two products in a particular month. As you can see in the first month, product AB was contributing more to the profit as compared to product BC, which is evident from the numbers also over here. So what I would want you to now again do is take a couple of moments, pause this video and think about what sort of trend or information you are getting from this graph. There are some observations over here. One is something which we had discussed in the previous chart also, that the profit increases at the quarter end and then it reduces at the beginning of the next quarter. Then it again increases. Then profit has been increasing ever since. If we look at the quarter ends also, December had the maximum profit. And there is another one that most of the times product AB is contributing more to the profit as compared to product BC. But there is one month, August 16, where product BC is contributing more as compared to product AB, which is the case over here if you look at August 16 numbers. Uh, Now, this particular composition or how much contribution which is coming from uh, each of these products will be more clearer when we look at the third type of chart, which is the 100% stacked column. Because in this particular chart, we will be calculating percentages. Over here, it's the actual value. So out of 5,984, we have 3,740 from 1 and 2,244 from 1. But when we look at them in percentages, the maximum percentage can be 100%. Over here, we've got the profit, which is varying from one month to another. So comparing them across months is slightly tricky. Now, let's just change this to a 100% stacked column. So all I need to do is I'll click on this chart. I'll go to insert. I'll click on 100% stacked. This says compare the percentages that each value contributes to a total, or show how the percentage that each value contributes changes over time. So as you can see that product AB is contributing almost 60% every month. But for some reason in the month of August 16, it just contributed around 40%. If you scroll over the charts or the bars also, you can see the actual values. But when you look at the percentage basis, when you've got the entire scale as 100%, this sort of chart comes in real handy. So this is what we have on column charts. Now there are some sort of 3D charts also, but let's just take an example of a 3D chart also. Let's say this is a 3D 100% stacked. So let's say I just click on this chart again and I'll change it to a 3D column, 100% stacked column. So as you can see, it's just the appearance which changes. Otherwise, there is no additional information which you are getting from this particular chart. So it's all about beautifying your charts. If I look at the 3D stacked column, again, the appearance is definitely better as compared to a normal 2D stacked column chart. Now with the column charts discussed, we'll move on to the bar charts. Bar charts, again, I've got the same example over here because bar charts are exactly the same as compared to a column chart. Just that for the bar chart, the horizontal axis is my y axis, my vertical axis. So let's just see how this works. Again, I'll select this. Over here, if I select 2D bar, as you can see now, my salary is getting plotted over here on the horizontal axis and my months are on the vertical axis. So as such, there is not much difference. And because the data remains the same, we'll see the same behavior over here also. Now, which chart to use totally depends upon you. Usually people use column charts, but when there's an increase in the number of categories, people usually go with bar charts. Similar to column charts, you've got clustered bar chart, you've got a stacked bar chart, you've got a 100% stacked bar chart. Then you've got the same in the 3D format also. So again, for the line charts, I've got the numbers over here. Expenditure of a household. So I've got for 12 months, I've got the water bill, electricity bill, I've got gas, petrol, and groceries. Now, where is line chart used? Line charts are used to identify trends in our data. Usually we can have data like if you've got bills over here, we can have data like height of students, speed of a car, changes to sales. So these all can be plotted over time, and then line charts can be used to look at the trends. So let's start with creating a simple chart. So I'll select all this data. Now this is my simplest line chart. As you can see, it shows over here, use the chart type to show trends over time, or use it when the order of categories is important. There are many data points. I'll just put the legend on the top. So click on plus top and I'll change the title. So this is my line chart over 12 months. I've got these 5 lines plotted for these 5 types of expenditures or bills. I've got the water with the blue line, electricity with the amber, gas with gray, petrol with yellow, and then groceries with again light blue. So again, take a couple of moments over here and think of all the trends which you can see. The first one we'll discuss is the water bill. So the water bill remains consistent throughout the year. As you can see from the data also, it's $29 throughout the year. So that's we've got a straight line. Moving on to the electricity, which is being represented by the amber line over here, this particular line. So as you can see in the initial months of the year, Jan, Feb, when it's relatively cold, the electricity bill is higher. But as we keep on moving towards the summer months, there's a dip in the electricity bill. And then from August, September onwards, it again starts picking up. Then it reaches its peak in December again. The next one is the gas bill, which is being shown by the gray line over here. There's a slight peak for the first 2 months. Again, after that, it sort of dips, and it's fairly consistent. So no particular trend, just that it's sort of higher towards December, Jan, and Feb, and it might be higher towards December, January because of the holiday season. Petrol, which is being highlighted by the yellow line over here. It's relatively consistent in the first quarter, and then it sort of starts picking up during the summer holidays, hinting towards that people start going out more often in summers. So reaches its peak in August, which is the holiday season. Then again drops down till October when winter starts coming in, and then again picks up in December 16, maybe because of the holiday season again. Groceries is being highlighted by the blue color over here, fairly consistent. I would say there's a slight rise in the holiday seasons in August, September around over here. Then it again dips, and in again December, it again picks up because of the holiday season. So these are all the trends which you can look at for a household. Then it becomes really important, and then they can also manage their expenditure accordingly. If they see that okay, they are spending more in these months on petrol, then they can try to reduce their expenditure on petrol over here. So this is how a simple line chart can also help in organizing your funds or organizing your expenditure or reducing your expenditure. Now, as we had looked at the bar or the column chart, for the line chart also we've got different types of charts. So this is a stacked line chart. As mentioned over here, use this chart type to show how parts of a whole change over time, or consider using a stacked area chart instead, as stacked line charts can be hard to read. So again, what this is basically showing me is the sum of all of these five expenditures over a month and the contribution for each of these. If I just look at for January 16, this line is around $400. If I sum the January 16 bill, it comes to around $395. So what this chart does is it keeps on adding values for each of these categories, and the sum comes at the top. So 29 is being represented between the x-axis over here and this particular blue line over here. Then from 29 we jump on to 159, which is representing the 130 dollars for the electricity bill and so on. But this chart is a bit difficult to read, so let's use the stack chart. Again, what does the stack chart say? Use this chart type to show the percentage contribution to a whole over time or categories. Show the change to the percentage that each value contributes over time. Consider using a 100% stacked area chart because stacked line charts can be hard to read. So again, now we've got this 200% similar to what we had for 100% stacked column or 100% stacked bar. And now we can see the contribution for each of these to the total bill. So now take a couple of moments over here. Think about any of the things which this particular chart is highlighting, which I haven't spoken of as yet. So I'm not sure if you may have noticed this, but the contribution of the groceries bill to the entire bill is at its peak in December 16. Uh, then again for electricity over here, the contribution which it is leading to towards the entire bill is sort of higher towards January and 16, then it sort of reduces over here because the other bills start off contributing more. Now let's look at another line chart. So again, I'll click on this chart. I'll go to insert. Now this is line with markers, shows trends over time. So this is similar to the normal line chart, just that over here we've got markers also representing the data points. I can add the data labels also. So I'll just do a right click, add data labels. If I do an add call out, let's see. So what the add call out does is for each and every value, it will also show me which month that value is belonging to. But that is just too much of data and it just populates my plotting area and just makes a mess of my chart. So I'll just do a control Z. So now with the line chart done, we'll close this session over here, and in the next session we'll discuss the remaining type of charts. Pie chart is used to display the contribution of each value to a total value. So over here I've got the expenditure of a household which I'd used for showing the line chart, and I've just totaled the expenditure for the 12 months. So the entire 1 year expenditure for the household is around $4,592. Using a pie chart, all I need to do is I just need to select them together. I go to insert. Now pie chart. When I click on this, it says use a chart type to show proportions of a whole. Use it when the total of your numbers is 100%. So using this particular chart, I can very easily see that this blue over here, which is the groceries bill, is the largest expenditure or the highest expenditure over here as compared to the rest. Then the second close is the electricity, which is 1240, and then I've got petrol over there, which is around 1075. I can also add these data labels by just doing a right click and adding data labels over here. There is another version of pie chart which is called pie of pie or bar of pie. Over here, you've got five components which are sort of equal in nature. But let's say I've got these two components which are like really small. So right now over here, I am not able to see these two components at all. So what I can do is I'll select this chart. I'll go to insert. I'll click on pie. So what it does is it combines two different series over here and makes a separate chart of it. So over here, I want to make a separate chart of 2 and 5. So what I can do is I'll do a right click, format data series. Values in second plot need to be 2, and which values by values less than 10. So when I do that, now what Excel does is it combines the two smallest values and then prepares a separate pie chart for both of them so that they are also visible. So this is when a pie of pie or bar of pie comes in handy. So just changing the chart type, this is how the bar of pie will look like. Let's move on to the XY scatter plot. Now this is used to observe or show the relationship between two variables. One variable has a scale on x-axis and the other on y-axis, that is the vertical axis. So I've got over here the name of 10 employees, I've got their age and salary, and I want to see if there is any particular relationship between age and salary. I'll select age and salary, I'll go to scatter plots and I'll click on scatter. This is used as chart type to compare at least two sets of values or show relationships between sets of values. So as you can see over here, what this is showing me is an increasing trend over here. Move on to the next, which is the area. Now, these charts are very similar to a line chart, and they are also used to look at the trend of a value over time. And just that the difference between a line and an area chart is that in an area chart, all the area below the line will be colored. Now, I've got different types of area charts also. Let's go to insert, recommended charts, all charts, area. Now, this is the simplest area chart. This is something which is not used, and I'll show you why. When I click on OK, it has automatically taken this data. But over here, because the chart is supposed to color all the area below a particular line, over here the groceries is being shown by blue color, and because the groceries are having the highest bill, so that is why we are not able to see other charts at all. There were 2 months where electricity was higher than groceries. That is why we can just see them. So that's why the normal area chart is not used that much. Let's look at the other area charts. So this is a stacked area chart, which is used more often, similar to a stacked line chart again. So this shows the contribution of all these expenditures, different types of expenditures over months. Let's move on to the other chart, which is stacked, 100% stacked. Again, very much similar to 100% line. And the inferences are also the same as what we had discussed in the line chart because the numbers are the same. So we'll have the scale to 100% and the expenditure from each of these different types of bills will be plotted as a percent. So for example, for the first month, Jan 16, the total sum of expenditure or the total bill is $395. Let's select the percentage. I'll just change the format in a while. So what this is showing me is that in the first month of January 16, 7% of the bill came from water, 33 from electricity, 10% from gas, 18 from petrol, and 32 from groceries. So electricity was the main culprit over here. So these percentages are what have been plotted over here. So this is like bit less than 10%, so 7%. Then this is 33%. So if I add 7 and 33, I'll get 40. So that is why the second line is right at 40. Then I add another 10% to it, it makes it to 50%. Then I add 18%, it takes it to 68%, just below 70. And then I add another 32% to make it to 100%. So this is how a 100% stacked area chart works, and it's the same for 100% stacked line as well. Now let's move on to the other chart categories. We've got the donut first. So this particular chart is used to display the contribution of a value to the total, and it's just like a pie chart. The difference being it has a hole in the middle and it can have multiple series of data in the same graph. So over here I've got 5 companies, and all of these companies have 2 products, product A, B, and product B, C. I've got their corresponding profits also. I just want to plot the profits for each of them in a donut chart. So let's start with that. I'll go to insert, recommended charts, all charts. I'll go to pie, and in pie I've got donut. I'll select on donut. It will give me 2 options over here, profit from AB, profit from BC, but this one is more suitable to what I want right now. So I'll click on it and I'll click on OK. So how to read this chart? First of all, let me put the legend on the top. Legend on top, and I'll add data labels also. Okay. So let me just zoom in a bit. So over here, what it is showing me is that for company S1, profit from BC was $5,000, whereas profit from AB was $12,540. If you look at it, $5,000 as a contribution to the outer pie is small. Whereas if you look at it, the contribution of $12,540 from the inner pie is quite significant. And as you can see from the data also, uh, company S1 has more profit from AB, company S2 has more profit from AB, company S3 also has the same thing. It's just that the company S5 is one which has less profit from AB, whereas it has more profit from BC, which can be seen over here. Also, S5 is represented by light blue. So from BC, it has got a large pie over here, and from AB, it has got just this small section over here, 2000 pounds. So this is just a donut chart. It's not used that often. When you've got multiple series, you can use them, but it just gets a bit messier. Let's look at the next graph, which is the radar. Again, this chart displays values relative to a center point. It has a separate axis for each category, which extends from the center of the chart to the border. Again, I'm taking the same example over here. Insert. Let's just do a radar chart. Let's just zoom in a bit. So this is the scale which is being shown over here. So this is the profit from AB and this is a profit from BC. The scale is from 0 onward. As we keep on coming outside or away from the center, the numbers will keep on increasing. So for S1, it is showing over here $12,540, whereas from BC for S5, it is showing around $10,000, which is somewhere around here. There are different options within this also. So I've got this radar with markers, just adds markers similar to line with markers, and got fill radar. It just colors the area. So that's about it. Let's move on to the surface graph. I'll again select this surface. Now this shows trends in values across two dimensions and in a sort of a continuous curve. For using surface charts, we need at least two data series. So what this is showing me is profit from AB and profit from BC. So the different colors over here are implying the different ranges of profits. So if it is blue, it is $0 to $2,000. If it's amber, it's between $2,000 and $4,000. Then gray, $4,000 to $6,000, and so on. Then we have the bubbles. Now this is again similar to a scatter plot, but a scatter plot looks at two variables only, whereas a bubble chart looks at three. And the third variable defines the size of the variable. So over here I've got age, salary, and sales. And if we want to see a correlation between the three variables, we can clearly see with this particular graph. Let's see how it works. So I'll go to XY scatter plot. Over here I've got this bubble chart. Within the bubble chart also I've got two options. If I look at this one, this won't give me much idea, but the second one is more interesting to me over here. If I click on OK, let me just delete these lines. Now this is the age, this is the salary, and the size of the bubbles is the sales. So now what I want you to do is take a couple of moments, think about what we can interpret from here, and then if there is something which I'm missing, let me know. So over here, one thing is very clear, that is with the increase in age, the salary is also increasing. But the other thing which is also sort of clear is that as we keep on increasing the age, and the salary definitely keeps on increasing, but the circle size, which is representing the sales over here, that is also increasing. So, which sort of tells me that with age, a person is able to make more sales, probably because of his experience, and that then leads to a higher salary. Now, moving on to the stocks, I've got stock information for 5 stocks. I've got the volume which was sold, what was the share price when it was opened on the day, how high it went, what was the low price, and at what price it closed. In the stocks graphs, also, there are like 4 types of different graphs we have. So let's look at the first one. Recommended charts, all charts. Got the stock. The first one is the high low close. Now for this particular graph, we'll need 3 types of data. One is the high, then the second is the low, and then the third is the close, which I've already got over here. So let me just select this, go to recommended charts, all charts, and then we'll go to stock, and I'll click on OK. I'll zoom in a bit. So what it shows is that, okay, I've got these stocks. For stock B, let's say the closing point was 235.26. The lowest point for this stock was 161.06. Now, what I want you to do is take a couple of minutes and think about what is being shown or what can be interpreted from this chart. Right. So one of the things is that though chart B has a really high stock price, but it has a lot of variability also, which can be seen from the data also. The high was at 237, and within the same day it went to a low of 161 also. So that is quite higher difference. Whereas the difference is slightly on the lower side when we talk about stock E over here. Right, now let's move on to the second type of stock. This will be looking at the open, close, high and low price. Let me just select the data first. So over here again, this sort of gives me a block. So just on the top of this bar, we've got the high point. Then we've got the bar which sort of represents the open. Then the lower end sort of suggests the low of that day. The third type looks at the volume which was also traded on. So let's select this. So what this is doing is it is plotting the volume on vertical axis, and it is plotting the stock prices of high, low or close on the secondary vertical axis. Just remove these lines. So again, as I said, for stock A, 500 sold on day 1. For stock B, 100 sold, but maybe because the stock prices are quite high and there was a lot of variability. The last of these is volume, open, high, low, close. So it looks at all of them. Let me just change select data. So yeah, again, volume on vertical axis, and we've got prices on the y-axis. Now, sparkling charts are nothing but cell-sized graphs. They are of 3 types. So one is the line, which is similar to a line chart. Then the second one is column, which is similar to a column chart. And then the third one is a win or loss. Basically, it displays each point as a high block or a low block, and it comes in handy when we are trying to track changes as we move from one month to another. We'll take examples of each of them. I've got the line charts over here, I've got the column ones over here, and I've got the win loss over here. So we'll plot them one by one and we'll discuss them. So I'll just copy this data. Now I've got the household expenditure over here across months, and I've got these different types of expenditures. So I go to insert, I've got these different sparkling options. I click on line. It will ask me for a data range. I select this, I click on OK. And then I can copy it to the rest of the cells also. Sorry about that. What this is showing me over here is the variation of these values over months. So for water, this was consistent, so that's why it had a straight line. For electricity, it was high in the first 3 months, and then it dipped. So you can see that it was high and then it has started dipping over and then it started again rising. Similarly, groceries again, it sort of is stable throughout, but then peaks in August and December. So that's why we see two peaks over here, one in the August month and then the other one in December. Similarly, we have the column charts also. So again, select the data range. So line chart plotted a line whereas the column chart plots bars. So for water, because it was consistent, so the bars are of equal height. Now for electricity, because the bill varies as we move from one month to another, so that's why you can see large bars or you can see really small ones also. Now the last one is the win or loss one. Basically what I've plotted over here is the difference as we move from one month to another. So for water, because the bill remains consistent, it is zero. So that is why the win or loss graph does not show anything over here. Wherever it is zero, it will not show anything. For electricity, as we move from Jan 16 to Feb 16, the bill increases by 5. But as we move from Feb 16 to March 16, the bill reduces by 25. So that's why minus 25. Similarly, for April 16 also it was negative. For May 16 also it was negative. Then for June 16 it was 0. So that is why no bar over here. Now, when you click on a sparkling chart, let's click on this one because we've sort of copied them. They are a group now. When I go to design, I can select the high point. So for all of them, the high point will appear. Low point can also appear. Similarly, I can change the marker colors. For say low point, let me have it with some other color. Let me have it with gold. So that's why now you can see the low point is being shown by gold. There is no negative point. I can show first point, last points, or I can have markers for all of them, which just makes it a bit messy. Similarly, you've got these different line styles over here. If you say use this, then the line color will change and the marker color will automatically change basis what you consider over here. Now, another thing which you want to keep in mind over here is that most of the times Excel automatically takes these values and selects automatic for each sparkling chart. These are the vertical axis minimum value options or maximum value options. So you can play around with them to see how it impacts your chart. But the one which I will highlight over here is the date axis type. So what happens is usually when we plot time-based data, it is assumed by Excel that the data points are at equal intervals. But this may not be the case always, and in order to avoid wrong conclusion, we can use this date axis option. This usually works with column sparkling chart. So let's just copy this and let's remove the June data. So what I'll do, I'll copy paste the rest of the data on June's data. I'll insert a sparkling column over here. So as you can see now that earlier, if I do a control Z and I'll just zoom on this cell, I've got values for all these months. But when I applied date access type option by just selecting these months, now there's a space in between. So now Excel also knows that, okay, there is 1 month of data which is missing. So that is why it is showing up blank for that month. So just try and explore various options in the design tab. Sparkling charts are pretty neat and come in handy whenever you don't have enough space to plot a normal chart. Now, before we jump on to the discussion of which chart to use or when to use, I'll just show you how to add a secondary axis to your graph. So let's say I've got this particular series over here, and let's say it was on the primary axis. So I've got both the series on the primary axis. I'll remove the data labels first. I'll select the series. I'll do a right click, format data series. This opens. I'll click on secondary axis and automatically Excel will give me a secondary axis with the age over there. I can change the chart type also by clicking on change series chart type. Now let's move on to the question of which chart to use. To be honest, there is no best answer to this, but use that chart which will most aptly describe your data, or you think it shows your message clearly to the target audience. There are, however, some points which you can always keep in mind. One is, what are you trying to achieve from plotting a particular chart? Uh, are you trying to plot a comparison or a composition? So, for example, over here, if I wanted to compare profit from product A, B, and profit from product B, C, that is a comparison. So, for this, I can use column charts, I can use bar charts. When it comes to composition, so over here we looked at an example of the contribution of product AB to the entire profit and the contribution of product BC to the entire profit. So that is a composition. For the composition side, your 100% stacked charts come in handy. So your 100% stacked column chart, your 100% stacked bar chart, 100% stacked line or 100% stacked area chart will also come in handy then. Then the next question which you can ask yourself is, are you trying to identify a particular trend or a pattern? For that, you can use a line chart. When it comes to understanding relationships, so we had looked at in our example over here the XY scatter plot. So the XY scatter plot shows me the relationship between age and salary. But then the bubbles chart also shows me the relationship between age, salary, and sales. So for understanding relationships, you can use such charts. For compositions, as I said earlier, that you can have 100% stack charts. You can have pie charts also for compositions, because over here we are just looking at what is the composition or the contribution of these individual items to the overall item. Now this brings us to the end of charts, and following this video we have a document for you to go through. It captures most of these things what we have discussed so far, and then we've got some exercises for you also. Thank you. Hi, in this module we'll discuss about pivot tables. Now I've broken down this module into different sessions, and in the first one we'll discuss what are pivot tables. Then we'll also discuss a couple of ways by which you can create a pivot table, and then we'll also discuss about its structure. In the second session, we'll then discuss about formatting a pivot table, and then we'll move on to options like summarize by value and show values by. And in the last session, we'll discuss about the pivot graphs and the various pivot table options. Now coming back to the first question, what is a pivot? A pivot table is a very powerful tool in Excel, as it can be used to create summary reports and also to analyze data in an Excel file. So for example, in a banking industry, there are like hundreds of thousands of transactions which happen daily via debit cards. Now, Most of these transactions would be from genuine customers and a handful of them would be through fraudsters. But using pivot tables, we can play around with the customer attributes, the transaction attributes, and identify a risky segment, thus identifying fraudsters. So pivot table can be created for thousands of rows of information, hundreds of thousands, or even 20 observations. Over here, I've got 25 employees from a company. I've got their marital status, country, gender, age, salary, number of portfolios they've worked on, the number of cases which they've worked on, and successful cases. So what I'll do, I'll use this particular data set to create a pivot table and then we can discuss about its structure. So one of the ways is I want to create a pivot table for this particular data set. So I've clicked on this particular data set. I'll go to insert. I'll click on pivot table. So Excel will automatically select this entire range as the underlying data for my pivot table. Now pivot table will give me options to create a pivot on the new worksheet or on an existing worksheet. So I can click on existing worksheet and then I can go to any of these existing worksheets and click on a particular cell where I want my pivot table to start with. But usually I prefer the new worksheet and click on OK. So now this is one way by which you can create a pivot table. Let's just delete this and let's look at the second option also. So I'll select this data. I'll click on Alt D P. Now this gives me a pivot table and pivot chart wizard. I'll click on next. Now because I had already selected this data, Excel has already put this in my range. I'll click on next. And now again, I'll get the same option of having a pivot table on the new worksheet or an existing worksheet. Let's click on new worksheet. So pivot table has got created now. Let's name it as pivot. Now let me just minimize it a bit. Okay, now this particular area, this will have all your column names. So I've got name, marital status, country, gender, age, salary, portfolios worked on, cases worked on, successful cases. So I've got all these variables over here. In filters, we can drag and drop any of these variables. Now, usually we put those variables for which we want to apply a filter or a condition on, and we'll see how this works out. In columns, we will drag and drop that variable for which we want its different values to appear in different columns. In rows, we will drag and drop that variable for which we want its different values to appear in different rows. And over here in values, we will drag and drop those variables for which we want to summarize the data or say count the data or say sum the data. So let's see how this works. So for my marital status, I can see that there are two options, married or single. For my country, I've got UK or USA. Similarly for names, I've got these different options over here. So using these drop down arrows, I can see the different values in a particular variable. Let's say we want to calculate the number of employees by the region they reside in and the number of portfolios they've worked in. So let me put the region over here. So I've got UK and USA over two different rows. And for columns, I'll have the number of portfolios they worked on. So portfolios worked on has four distinct values, 1, 2, 3, 4, which have been listed over here. So using this pivot table now, I've got 8 different options. So for UK, I've got 4, 1, 2, 3, 4. Similarly for USA, I've got 4, 1, 2, 3, 4. Let's calculate the number of employees across these combinations. So I'll drag and drop name over here in values. Now because name is a character variable, so Excel will automatically count it. So as you can see, for employees residing in UK, there are 4 employees who worked on one portfolio. There is only one employee who's worked on 2 portfolios. There are 4 employees who worked on 3 and 4 portfolios. Similarly, for USA, you've got 4 employees who worked on one portfolio. For USA, you've got 4 employees who worked on 2 portfolios, then 1 employee on 3 portfolios, and 3 employees on 4 portfolios. Now, one thing is that you can look at these distinct combinations also. But then another thing which you can summarize quickly from here is that there are 8 employees who worked on one portfolio. There are 5 employees who worked on 2 portfolios, 5 on 3 portfolios, and 7 on 4 portfolios. Similarly, you can see that there are 13 employees who are residing in UK and 12 who are residing in USA. Now let's look at some of these different terms, row labels, grand total, or column labels which we've come across. So row labels basically it's sort of representing the variable which has been put in row. Column labels similar to row labels, just that this is based on variable which has been put in column field in the pivot table. Grand total, it's appearing twice, so it just basically sums up all the values of the field which are being summarized. Then count of name over here. Now because we are trying to count the number of employees across regions and portfolios they worked on, we drag the name field in the value section. So count of name over here suggests that we are counting the number of names. Now let's say I don't want to look at the number of employees, but I want to look at the salaries across these 8 different combinations. So I'll remove name from here, and as I drag it to the filter section, the count of gets removed now because we are no longer counting names now. Let's put salary over here. So whenever you put a numeric value over in value section, Excel will sum it. So over here it is showing that it is summing the salary. Now let's try and apply some filters also. So let's put gender in the filter section. Now I've got gender appearing over here. Now let's say I just want to look at the male population over here. So I'll click on this drop down arrow and this window will pop up. It shows the different values which are there for this particular variable. So for example, for name, we've got these different names. So again, click on gender. Now for selecting only male, I'll click on M and now I'll click on OK. Now whatever numbers which we are left with over here, they all belong to the male population. Let's apply another filter. Let's put age over here. Now for age, I've got these different options. Let's say I want to select more than one option. By default, all are selected. So I'll click on select multiple items. I'll untick this and now I can select whatever I want to. Let's say I select all less than 26. Click on OK. So now I'm just left with all the male population with their age less than 26. Now what I want you to do is, using this sales data, I want you to create a pivot table similar to this and then just play around with these different options of filter, rows, columns, or different values. In the next session, we'll look at formatting a pivot table and we'll also look at value field settings. So summarize values by and show values as options. Thank you. Hi, welcome back. Now in the previous session, we had discussed what a pivot table is, how to create a pivot table, and then we had discussed the basic structure of a pivot table, namely filters, columns, rows, values. So now in this particular session, we'll start from where we had stopped. Now we'll look at formatting of a pivot table, and then we'll look at options of summarize values field by and show values as. So now let's look at the formatting of the values. So over here, I've got these salaries, but I want a currency sign in front of them. So because I want to format the values, which is salary over here, so I'll click on this drop down and I'll get this pop up. I'll click on value field settings. This particular prompt will appear. I'll click on number format, and we've already gone through this particular type of format cells dialog box. So I'll click on currency and then I'll click on OK. Now I can also change the name. So over here it's appearing as sum of salary, and over here also it's appearing as sum of salary. Let's remove off, but you can name it anything what you want. 1, 2, 3, 4. Let's click on OK. So now it's showing us some salary 1, 2, 3, 4. And over here also the name has changed. Now when we click on value field settings, we've got these two options over here: summarize values by and show values as. So now let's look at these options. So over here you've got different options by which you can summarize your value field. So over here in the value field we've got salary. So right now Excel is automatically summing it, but we can also count it. As soon as I clicked on count, you may have noticed that the value over here in custom name changed to count of salary. If I click on OK, now the format, I need to change the format of it. So I'll go to value field settings. Because I'm counting, let it be a number and click on OK. So now I've got 6 in total. So we were looking at male population which had an age of less than equal to 25. So for UK, US, I've got 6 employees in total, 3 of them in UK and 3 of them in US. Let's look at what average does. So this will give me average of salary. And let me just change the format also. Back to currency. So now one of the questions you may be asking is, how is this count or sum or average useful in terms of analyzing the data? So if you just look at this data set also, there are some observations which you can make out of it. If you want, you can pause the video for a couple of minutes and just think about it. Now, the first obvious thing is that the average salary for the entire population of males with less than equal to 25 age is $54,000. But what is more interesting is if you look at UK average salary and USA average salary. So the average salary in UK is slightly higher as compared to USA. And another thing to note over here is that people who have worked on less portfolios, they've got more salaries. Now, this might be something to do with the specialization which they have had in that particular field only, that they are getting good salaries. Now, let's drag and drop other variables also. Let's select age over here. I'll remove country. I'll click on remove field and I'll just drag age over here. And let's just clear filter from age. So now this is for all the male population. I can see that the average salary is around $55,000. And again, similar to what we had observed earlier, people who worked on less portfolios, they tend to earn a higher salary as compared to people who worked on multiple portfolios. And that might be because these people are again and again changing their jobs. So they are not able to build an experience and then they are not able to count on that. So this is how pivot can be used. You can drag and drop various variables and try and see if a particular trend is standing out. Over here, something what can be very easily noticed is that people working on less portfolios are earning more. Let's see if that particular observation is true for the female population also. So for the female population, it's more stable. So they are earning almost the same. It's just that there is one individual who worked on 2 portfolios and is earning less, but otherwise it's more or less consistent. So this is how pivot can be used to create different segments. Now let's just do a control Z. I'll go back to my original table. Now before we jump onto Max, uh, let me just copy and paste some data first. Count. Value field settings, Max, number format, it needs to be in currency. Okay. So when we are going to use Max, so as you can see over here, I've got 2 employees within this segment where the country is UK and the number of portfolios worked is 1. So what max operator will do is it will give the maximum salary of these two employees. So let's click on OK. 90,000. And the way you can check this is, so let's go to our data and search for males UK with one portfolio worked. So let's apply a filter and then we'll click on males, portfolios worked on 1, and age less than equal to 25 and UK. So I've got these two employees. As you can see, the maximum salary of these two employees is $90,219, which is what our pivot table is now showing. Similarly, we can use the minimum option also, that will give the minimum salary of these two. Now the next option is product. But before jumping onto it, let me just first copy this first. So now as you can see over here, I've just got one employee. Over here, I've just got one employee. It's just that over here, I've got two employees, right? And we've already seen that the salary of these two employees is this. So let's just copy this to here. Let's see how the product works. So what product option does over here is it just multiplies 57,000 with 90,000. Because if you look at the other combinations, because it was just one customer over here, so that's why it's still the same. 26,000 is still 26,000 over here. 19 is still 19 over here. 87 is still 87. 46, 46. It's just that over here, this is the product of these two. So let's see. Yes, as you can see. So the product option just multiplies all the values within that particular segment. Let's just clear this. Now the next is count numbers. Let's see, for it to work, let me just remove salary again and let me put name. So right now I've got 6 employees, right? Now let's use count numbers. So as you can see, this is all 0, and that is because in name you have all character values. You don't have any numeric value. So that is why this will be equal to 0. Let's just do a control Z again. Similarly, you've got other options like standard deviation or variance, which are just used to calculate standard deviation or variance within those particular segments. Now let's move on to show values as. Now by default, this will show as no calculation. Over here, we've got country selected. So we'll just calculate the values on the basis of this. So the first option is percent of grand total. Uh, Now this will display the percentage of the value across these different combinations out of the grand total. So let's just click on OK. If you sum this up, this is 100%. If you sum this up, this is 100%. So how it will work is, let me just copy the data first. Let's just use no calculation over here and let me just count. So I'm just copying this data so that when we do those calculations, it will make sense to us. Let me just change the format. Currency, dollars. Okay. Now we'll again go back to value field settings, show value as percent of grand total. Okay. So for 147K dollars, I've got 45 percentage over it. But what is this being calculated from? Let's see. If I click on percentage. So as you can see, using percent of grand total, for each and every value, it will take a percentage out of the total value. So for this particular value over here, it's taking a percentage out of this entire chunk. Similarly for this, it will divide it by this and calculate a percentage basically. Wherever the values are not there, it will give a 0%. Let's look at other options. Percent of column total. Now each and every column will sum up to 100%. So 147K out of 194K is 75%. Similarly, where values are 0, this will be 100%. So for example, in this case, column 2, we've got the total value as $87,000. For UK, this value is 0. And for USA, the entire $87,000 is coming from USA. So that is why for USA, this is 100%, whereas for UK, this is 0. So basically it displays the value as a percentage of the total value of that column. Now let's look at another option. Value field settings, values, percent of row total. Now this is similar to the column total, just that now the row total will be 100%. So 147K out of 174K is 84%. Wherever the value is 0, it will be 0%. Now let's look at the next option. Percent of, let's consider the base item as UK and click on OK. I'll just do some formatting to make it more readable. Right. So it displays value across different combinations as a percentage of the value of the base item in the base field. Now in our example over here, we've considered the base field as country and the base item as UK. So because we've considered UK as a base item, so what Excel will do is it will divide all the values in say column label 1 with 147K. So 46K out of 147K is 31%. Let's see. As you can see, it's 31%. Similarly, because there is no value present for UK over here, we don't have any value coming out here. Now for column label 3, when we divide 26K with itself, it will be 100%. But because there is no value over here, we are getting a hash null error. Similarly, for column label 4, because we do not have any value over here, so we cannot divide $19,000 by anything. So that is why we are not getting any value over here also. Let's see if we change this to USA. So value field settings, show values. So let's consider USA as our base item now. So basically what is happening is now we are calculating the percentage of the value based on USA. So is equal to this divided by this 314%. Because USA is a base item, this is 100%, this is 100%, and this is also 100% over here. For USA, for column label 3, we do not have any value. So that is why this is null over here. Now let's look at the next one. difference from. Okay. Now over here again, because we've considered UK as a base item, so when we'll subtract 147k with itself, it will be 0. When we'll subtract 26k with itself, it will be 0. But when we'll subtract 147k from 46k, we'll get minus 100k. Similarly, wherever UK is 0, this value remains the same for US. Over here, since for USA we had this value as 0, when we'll subtract $26,000 from 0, we'll get minus $26,000. Now let's look at one more option. So it displays values as a percentage difference from the value of the base item in the base field. So first Excel will calculate the difference as we had shown earlier using difference from, and then divides the difference with the UK value in the column. So let's see how this works. When we'll subtract 147k from 46k, we get minus 100k, something what we were getting earlier also. And then we calculate this divided by this. So we are getting 68.24%. So basically, because UK is the base item over here, it is subtracting base item from this, and then it is dividing the difference with the base item. Now let's play with the pivot. I'll delete this and I'll go back to no calculation. Now over here, I've just got the salary, right? Now let's say if I also want to look at the number of employees. So I can drag one more variable over here, and now I've got the number of employees also across these different combinations. So I've got the sum of salary and I've also got the number of employees. Let me just change the name. Let's remove country. Let's put age in here and let's clear filters. Now I can take the maximum salary also. So let's see value field settings, maximum. So now I've got the max salary also. So this is one way by which you can explore more options in the pivot table. Now let's just remove the number of portfolios worked in, and let's remove the filter from here. So now I've got 25 employees. The maximum salary is $98,000. I can again add the salary variable over here. Let's say I just want the sum of salary also now. So I can summarize as many variables over here as I want to. Now, apart from using these sum, count, average, max, min options, or the different options like percent of or percent of column total, percent of grand total, we can also use calculated fields in a pivot table. So let's just see how this works. So you click on the pivot table, go to the analyze toolbar. Now click on field items and sets and click on calculated field. Now let's say I want the average amount of salary being given to an age group based on successful cases completed by the employees in that age group. So I will click on calculated field. In the name section, let me mention the name as average commission per case, And in the field section, because I want to find the average salary per successful case, I will first click on salary, insert field, and then I'll use a divide operator and click on successful cases, again insert field, and then click on OK. So now Excel has automatically created a calculated field. Now, just like you can add more fields to your pivot table, you can also add more data to your existing data, which is acting as the input or the source data for your pivot table. So all you need to do is go to your data set, and let's say you want a variable called t. Let me just put some random values in it right now. Now, if I go back to my pivot, this will not at the moment show me the variable t. And that is because I've not told pivot that the data source has got updated. And for that, what I need to do is I need to go to analyze. I need to go to change data source, click on change data source. And now I need to consider the updated data range and click on OK. So now as you can see, t is appearing over here now. I can also click on refresh. Now with this done, what I would suggest you to do is use the sample data and try and identify trends in that data using a pivot table. Use the different options in a pivot table and get used to them. In the next session, we'll discuss graphs and then we'll discuss some basic pivot table options. Thank you. Hi. In this session, we'll discuss pivot graphs and then we'll discuss some of the basic pivot table options. Now the pivot table graphs are no different to what we have looked at so far, but when we'll go through them, you'll see the advantage of a pivot table graph over a normal graph. So I've got the sum of salary over here and I've got the number of employees across age groups. Let's insert a chart. Let's say I want to insert a column chart. Just now the scale of employees and the salaries, it's completely different. Employees are just in single digits, whereas salaries are in thousands. So let me just put the salaries on a secondary axis on my data series, secondary axis. And for the primary one, let's just change series chart type. Employees can be a line. And now I'll click on OK. And I can have my legend on top. I'll just zoom in a bit. Now, what is different in this particular chart as compared to a normal chart is that you've got filters over here. And this is similar to the filters what we have in the pivot. So you can apply filters over here and you can immediately see the change in trend. Whereas for a normal chart, if you want to again and again change the source data, you'll have to either create a number of charts with different combinations of data, say one for female, one for male, and one for both male and female. But over here in a pivot chart, we can just use these filters and see the impact they have on the trend. Similarly, you can apply filters over here also. Let's look at another graph. So now for UK, I've got the sum of salaries for male and female, and for USA again I've got sum of salaries female male. Let's plot this on a graph. Over here on the primary vertical axis you've got the salaries, Now, this particular graph shows that the female population in both UK and US, they are outperforming the male population in terms of salaries. But the female population in US earns more than their counterparts in UK as well. So similarly, you can try and insert other charts on the basis of data you are trying to summarize over here. Now let's look at some of the pivot table options. Whenever you click on pivot table, a design conceptual tab starts to appear. Let me just change the data accordingly. I put age also over here. So now I've got for UK, I've got these different ages which are appearing. Similarly for, let me just zoom out a bit. Similarly for US, you've got these different ages appearing. Now if I go to design, right now, as you can see, you've got subtotals appearing for the UK population. You've got subtotals appearing for the US population as well. So you can remove the subtotals. You can add the subtotals. Let's just keep them at the bottom. Then you can remove the grand totals, report layout. This is just about changing the layout, not going into it. Insert blank line after each item. So just so as soon as we are done with the UK, it inserts a blank total. Similarly, after US, it inserts a blank total. But there's no need of it. So let's just remove it. Again, go to design. If I untick row headers, see the difference. Column headers, banded rows, banded columns. And from here, you can change the color of a pivot table. Got these different options. Let's just go with this. Analyze tab. We had seen filters over here using name or gender. Let's put marital status also over here. Insert slicer. Slicer is another way by which you can apply filters in a pivot, and all you need to do is suppose you want to add in a filter, say on the basis of age. So you'll click on OK. Now you can add in more slicers. So just click on it, analyze, insert slicer. Let's say on marital status. Okay. So if I want to place a filter over here, so as you can see immediately it changes. Now I can apply multiple items also. So this is a very neat technique rather than going over here again and again and selecting items from the drop down. If you want to remove slicers, you can just go over them and click on delete, or you can clear the filter first and then delete. Now because for the first slicer which we had deleted, the filter was still there, so now we'll have to remove that filter. So we'll go to row labels. So now because in rows we've got two variables, country and age, so we need to select age, and then we need to untick clear value from age, and that is the way you can remove filters. Speaking of filters, you can apply filters from here also. Label filters will apply labels on country or age, the two variables which we have over here. So as you can see, the US one gets removed. Now you can clear the filter. There is another option which I will discuss over here, is the group ungroup options. Let's go to another data set I have over here. I've got daily expenditure data. Click on insert. Okay. As soon as I drag and drop date from here, All my dates have been grouped in quarters and then in quarters also in months. This is something which does not happen by default in the older versions of Excel but does happen in 2016. So you can ungroup them by selecting this. Now I've got all the dates over here. You've got almost 547 dates, but it does become difficult to look at all these dates separately. So it's always better to group them. So let's go to analyze, group selection, and you can choose your own selection over here. So let's select months and years. Let's zoom out a bit. So now I've got data for 18 months over starting from 2015 onwards. And then I can just look at the cost. And then I can just insert to just look at any change in trend. So these were some of the options in pivot tables, and as in when you start using pivot tables more, you'll get more comfortable with them, and then you will be able to use these options more efficiently. Now following this video, we definitely have this data also available for you to just try out these things what we've just gone through. And I have also given you a case study. The case study has data for genuine and fraud customers. All you need to do is you need to analyze the data using a pivot table and try and identify a segment where the fraud customers are present. And once you are through the case study, if you have any questions or any queries, just drop me a note. Thank you. Hi, in this session, we'll go through what if analysis. Now, what if analysis is a type of sensitivity analysis wherein we are looking at changes to a dependent variable when an independent variable is changed. Now, by dependent variables over here in Excel, I mean variables or cells which consist of a formula. And by independent or input variables, I mean cells which are being used in those formulas. So let's take an example over here. Now there's this person ABC who's planning to buy a car. The purchase price of the car is $80,000. The down payment which he is right now thinking of is somewhere around 20%. Now the loan term would be 48 months. That's 4 years. So basically the installments will be monthly. And the interest rate which he's being charged is around 5%. Now loan amount, monthly payments, and total interest. These are all four variables whose values will be dependent on these variables. So let's just look at the formulas first. So in case of loan amount, we have the formula of B2 into 1 minus B3. So basically, if the person decides to pay 20% as down payment, the rest of it would be the loan amount. Now, monthly payments would be dependent on total payments divided by the loan term or the number of months over here. Now total payments will be the sum of loan amount which the person will definitely have to return. With that, the person will also have to return the interest rate. The total interest is calculated by interest rate over here and the loan amount. So basically if we multiply the interest rate with the loan amount, we will get the total interest. So these are the four dependent variables and these are the four independent or input variables. Now we'll first look at goal seek. Goal seeking is used when we have one value in mind for a particular dependent variable and we want to change the value of an input variable to achieve that value. So let's see how this works. For using what if analysis, you need to go to the data toolbar and you've got what if analysis over here. So let me just copy and paste this entire table over here so that when we make changes to this table, you can actually compare it over here. Okay. Now at the moment, if this individual goes ahead and buys this car worth $80,000 and pays a down payment of 20% with loan term of 48 months and interest rate of 5%, the loan amount would be of $64,000. Monthly payments which he'll have to bear for 48 months is around $1,400. The total payments which at the end of 4 years or 48 months, he'll end up paying around $67,200, and the interest rate would be around $3,200. So now let's say this person is not comfortable with a $1,400 a month payment and wants to reduce it to $1,200, and he's comfortable with the purchase price, he's comfortable with the loan term and interest rate, just that he's willing to change the down payment to get this payment down to $1,200 from $1,400. So for that, we'll go to what if analysis, we'll click on goal seek. Now we need to set the value monthly payments to $1,200, and by changing cell down payment, as you click on OK, so Excel gives you a status that okay, goal seeking has found a solution. So target value was $1,200, so they've found a solution for $1,200. When you click on OK, so now you can see that the down payment has changed to 31%. Now in order to have a monthly payment of $1,200 instead of $1,400, the person will end up paying a down payment of 31% as compared to a 20% which he was initially paying. Now the obvious disadvantage of goal seek is that we can just change one input variable. So for getting a monthly installment of $1,200, we might as well have wanted to change the loan term also, or maybe the interest rate as well, so that person can go out and try for a better deal. So now let's move on to other type of what if analysis. So let's discuss the scenario manager. Now, as the name suggests, Scenario Manager allows you to create different scenarios so that you can see the change or the impact of changing input variables over the dependent variables, or the cells which consist of the formulas basically. So I'm taking the same example over here. Let me just zoom in a bit. Now what we'll do, we'll create different scenarios based on down payment. So we'll change the percentage of down payment to say 20%, 30%, 40%, and then we'll see the impact of this change over these cells. So let's go to what if analysis, click on scenario manager. So right now there is no scenario defined. To add a scenario, click on add. Always keep a name so that whenever you look at it, you know what it is going to do. DP 30% by changing cell down payment. Click on OK. 0.3. Okay. Let's add another one. DP 40%. Again, the changing cell is B3. Okay. 0.4. Let's add another one. DP 10%. Changing cells B3. 0.1. Okay. Now you can select any of them by just clicking on them. So let's see if we select DP 30% and click on show, how these values will change. So originally at 20%, the loan amount was $64,000, but now it's just left to $56,000 because the person is paying more right at the start. Similarly, comparing the monthly payments, earlier it was $1,400, now it's just left to $1,225, and so on. Let's see on DP10. Now, when we keep it at 10%, the loan amount will increase because the person is contributing less at the start, and that just increases everything. So the loan amount increases, the monthly payments increase, and so do the total payments and total interest. Now let's close this. Now over here, what we have done is we've just changed the values of one variable, but using a scenario manager, we can change values of all these independent or input variables at the same time and then see the impact on the dependent values. So let me just copy the original ones first. Control C, Control V. Right. So now let's again go to what if analysis, scenario manager. Let's delete these scenarios. Let's add new SC1 by changing cells, all of them. So you can select all of them together. Click on OK. Now Excel will prompt you to enter values for each of them. So let's say I'm comfortable with the purchase price. I want to change the down payment. I want to reduce the loan term, and I'm comfortable with my interest rate. So this is scenario one. Looking at scenario two, SC2. Again, I'm changing all these variables. Click on OK. Let's say I want to change all the numbers now. Click on OK. So now I've got two scenarios, and again you can select either of them by just clicking on them. And when you click on show, so over here in the first scenario, the purchase price was the same. You've changed the down payment and you've changed the loan term. The interest rate also remains the same. So you can then compare the values with the original table. So the loan amount is just $56,000 as compared to $64,000 earlier. But there's an increase in the number of monthly payments, and that is because you've reduced the loan term. Now let's click on scenario 2. Click on show. Now for scenario 2, you've changed all these variables. So you've got the purchase price as $70,000. You've got down payments as 10%. Loan term has been increased from 48 months to 60 months. Then the interest rate has also increased from 5 to 10%. Basically, these two are not comparable, but I just wanted to give you an idea of how you can go about changing the variables. Now, one of the obvious disadvantages of scenario manager is that you cannot compare these values together. So if I want to have, let's just delete them. So let's just say if I want to have different values over here of my input variables, and then I want to compare the impact of these changes over the dependent variables. So that is what a scenario manager sort of lacks. But now we'll discuss data tables within which we'll discuss one variable and two variable, and they help in this comparison of changes to an input variable to an extent. So let's just see how this also works. So I'll again copy the original data. So for this we'll use data tables. Now a data table is basically a range of cells which will give us values of formula driven cells or the dependent variables when values in input cells are changed. Now within data tables also there are two options. One is one variable data table and the other one is two variable data table. A one variable data table will give different values of dependent cells corresponding to different values of one input variable only. So you can change one input variable only, just that you can have the different combinations so that you can compare the changes easily. So let's see how this works. Let's say we want to change the interest rate. So I've got these different interest rates now. Now, one of the prerequisites of uh, using a data table is that you need to put these values from the original table as a formula. So now let's just create a table. And let me just change the format to dollars. Okay. So now all I need to do is I need to select this data set. I need to go to data, what if analysis, data table. Now you've got these two different values, row input cell and column input cell. Now because I'm passing the values of these different interest rates in a column, I will select this and I will go to the original table where the interest rate was present, and I can leave this as blank. Now click on OK. So as you can see now, there is no change to the loan amount, and that is because you do not change the down payment at all. There is a change in monthly payments, total payments, and total interest though, and that is all because of the changes in interest rate. So the changes in interest rate are then passed on to the monthly payments and total payments. So using these different values of interest rates, I can compare where my monthly payments are less or my total payments are less, and then make a decision which would suit me. Now let's look at one more where we'll use the row input cell. So let me have these values here. I can then have this. Let's say I want to change the down payment. Let's just create a table. Now I'll select this. I'll go to data, what if analysis, data table. Now I'm passing the different down payment percentages in rows. So and I can leave my column input cells as empty. So now you can see by changing your down payment from 20 to 10%, 30, 40 or 50, how the loan payment, monthly payment, total payments or total interest will change. Now let's move on to the scenario manager where we use two variable data table. So over here also I'm using the same example. I'll just zoom in a bit. Now the obvious advantage of a two variable data table over a one variable data table is that we can see the impact or the changes of two independent variables. But the disadvantage is that we can just see the impact of those changes or those combinations on just one dependent variable. So let's see how this works. Let's just copy these values. So let's have got these different interest rates, and I've got these different down payments. And let's say I want to study the impact of changes in interest rates and down payments on monthly payments. So this is a prerequisite now. You need to make this value formula driven. Okay. So now we select this. We go to data, what if analysis, data table. Now in the row input cell, we are passing on down payment. In the column input cell, we are passing on interest rates. So now you can compare these different combinations. So for 10% down payment and 5% interest rate, the monthly installment will increase to $1,575, whereas it was $1,400 earlier. Even if we keep the down payment at 20%, now we can see the impact of changes in interest rates on these monthly installments. Now that we've discussed the different options in what if analysis, we have some exercises at the end of this video. So please do that. And in the next session, we'll be discussing solver. Thank you. Hi, in this session, we'll discuss about solver. Now, solver is used when you have a value in mind for your dependent variable, or you want to maximize the dependent value or minimize it. and you want to change the values of the input variables to achieve that value. So basically it's exactly opposite of what if analysis. In the what if analysis, we had seen the change or the impact of changes to the input variable on the dependent variable. So this is exactly the opposite. So over here, you've got some input variables and you've got a dependent variable or an objective in mind, and then you go about changing the values. It's a sort of an optimization tool, but before jumping onto it and how it works, there's a prerequisite. So go to File, go to Options. Now click on Add-ins. Now in the add-ins, Analysis Toolpack should be added in. If not, then just click on it and click on OK. So then you'll have this Analyze toolbar appearing in the data group. Now click on Solver. So this is how it looks like. So set objective, whether you want to maximize a particular dependent variable, you want to minimize it, or you want to keep it at a particular value. Then by changing which variables. So over here you will specify the input variables or the location of the input variables. Then over here you will add the different constraints, and we'll take this example over here so that this all is easily understandable. So let's look at it. So over here I've got a company and the company produces three products, A, B and C. So right now the company is producing 50 products of each A, B and C. So the total units it is producing is around 150. Over here we've got price per unit. So for A, one unit will fetch 250, for B 150 and for C 350. And we've got the cost per unit also, 90 pence, 20 pence and $1.70. Now just looking at it, you've got the total profit. Again, let me just show the formulas over here. So the total profit is basically based on the number of units sold, and then you just subtract the price and the cost and then just multiply it with the number of units. So basically the profit into the number of units. This formula over here, this is just the sum or the total number of units being produced right now, and this is the overall profit. So profit from product A, product B and product C. Now let's just remove this. Okay, so now our objective over here is to maximize this profit. Now there are some limitations over here. So one of the limitations is that the overall units which can be produced in a given month cannot be more than 450. Now for these individual products also we've got certain limitations. So we cannot produce more than 250 units of product A, more than 400 units of product B and more than 100 units of product C. So let's see how solver will work. Set objective. We want to maximize overall profit. We want to maximize it by changing variables. Now the variables which will change over here is these units which are being produced, because this is the only thing which we can change. The price and the cost, they will remain the same. So it is this production of these units which we want to optimize. Now we'll add the constraints. So add. Now the first constraint will be this, that is the number of units for product A should be less than equal to this. Add. For product B, this should be less than equal to 400. Add. For product C, this should be less than equal to 100. Add. The overall units should be less than equal to 450. So we've got these four constraints over here, and let this remain as GRG nonlinear. We'll click on solve. So we've got a prompt that solver has found a solution. Now one thing to note over here is that there might be times when solver may not be able to find the solution. So then you'll just have to change around some constraints or probably your objective to get to a desirable result. Let's click on OK. So as you can see, now your number of units has changed and your profit has also increased to $710 from $235. So now what Excel is saying is that we can produce 250 units of product A, but only 100 units of product B and 100 units of product C. And when we optimize all of them, we'll end up with 450 units in total because that was the limitation, and we'll have a profit of $710. Let's look at another example of solver. Now, this is something which the operations teams in banks usually use. In the fraud or anti-money laundering environment, there are always some strategies to identify frauds. Now, these strategies then throw up alerts, and each of these alerts has some scores. Over here, what we can see in this table is that there are in total 325 alerts being generated by strategy 1, 398 by strategy 2, and just 98 by strategy 3. So this is for score greater than equal to 1. So this will also include the count of people having scored 2, 3, 4, 5, and so on. Similarly, 398 is for all the people having a score greater than equal to 1. So it will also include alerts where the scores were greater than 2, 3, 4, 5, 6. As we keep on moving to the left side, the number of alerts keep on reducing. So for a score of greater than equal to 9, we just have 125 people. For a score of greater than 10, we just have 100 people. So now there is always a limitation around the number of cases which can be worked by an operations team because they've got their own deadlines also, and then they've got their own resources also. They cannot investigate each and every alert which gets generated. So currently these strategies have a set score. So for strategy 1, we are right now having 125 alerts. So basically any alert with a score of greater than equal to 9, we are considering for strategy 1. For strategy 2, we've got 128. So any alert with a score of greater than equal to 8, we are considering that. And for strategy 3, we've got 51. So any alert with a score of greater than equal to 6, which is being triggered by strategy 3, we are considering it. So in total, we've got 304 alerts right now, but we want to optimize this to 400. So we want to increase the number of alerts from 304 to 400. So by 96. There are some more restrictions. One is that the alerts which are being triggered by strategy 1 should be more than by strategy 2, and alerts being triggered by strategy 1 should be twice that being triggered by strategy 3. Now this may be because the bank feels that strategy 1 is more important or it identifies more risky cases. Then there are some more constraints that for strategy 1 the number of alerts should not exceed 170. For strategy 2 the number of alerts should not exceed 180, and for strategy 3 the number of alerts should not be more than 90. So let's just copy this first so that we can compare it. So let's go to solver. So our objective is that this particular sum should be less than or equal to 400 by changing values, these values. Now we'll add the constraints now. So the first constraint is this should be less than equal to 170, add this should be less than equal to 180, add this should be less than 90, add then this should be greater than or equal to this, add, and this should be greater than equal to 2 times this. Click on OK. So now I've got these constraints added. Now let's click on solve. So as you can see now that Excel has given you a solution. So what it is saying is that we can maximize strategy 1 to 170. For strategy 2, we can again maximize it to 170, and for strategy 3, we can keep it at 60 only. So in terms of scores, if you look at it now, So for 170, it would lie somewhere between 7 and 8. For 170 for strategy 2, it would lie somewhere between 6 and 7. And for strategy 3, 60, it would lie somewhere between 4 and 5. So this is how the operations teams in the banks optimize their resources and choose the score thresholds accordingly. After this video, we've got some exercises for you to work upon. Thank you. Hi. In the previous session, we had looked at what if analysis and we had also looked at solver. Now in this particular session, we look at some more analytics options which are inbuilt in Excel. Before we jump onto these options, one of the prerequisites is that we need to have the analysis tool pack installed. So I'll just show you again how to install the analysis tool pack. So go to File, click on Options, click on Add-ins, and then click on Analysis tool pack and then click on OK. Now when you go to the data group, you will have this Analyze section over here where you've got Solver and Data Analysis. Now when you click on Data Analysis, you've got all these different options which are there. So you've got ANOVA tests, you've got correlation, covariance, descriptive statistics, then F test, moving average, and so on. Now before we jump onto these options, I've got some random data over here. So I've got 10 students, I've got their height, I've got their weight, and I've got their grades. Now the first option which we'll start with is descriptive statistics. Now descriptive statistics are basically numbers or metrics which are used to summarize a given data set, and then using those numbers we either infer about the entire population or just that particular sample. So for example, if we have millions of data, we might not want to run descriptive statistics over the entire data set because it would be huge. So we might take a sample of it and then calculate these metrics. And then in order to ensure that those metrics hold over the entire population, we might take 3 or 4 or maybe more samples and then calculate the same descriptive statistics and see if the numbers are holding throughout those samples. Now there are two types of descriptive statistics and they're known as either measures of central tendency or measures of variability or spread. Now measures of central tendency include metrics like mean, median, mode, and measures of spread or variability include variables like standard deviation or variance. Variance is just the square of standard deviation. Then we've got variables like minimum and maximum, which help us in identifying the range of the data set. And then we've got kurtosis and skewness. Now, as the name suggests, measures of central tendency, they give us information about which value do the other values revolve around, or in other terms, the center position of that particular data set. So for example, over here, I've got these 10 students and I've got their heights. So the height starts from 171 to 180. Now let's say if I calculate an average or mean for this particular variable height, um, it will give me one particular number and I can say that on an average, the height of the students in this class is this much. And coming on to measures of variability, now they help us in analyzing the spread of the data. So over here, if say the average height was 175, but the average height does not tell me how spread out the data is. For example, if the standard deviation is very close to zero, then we can say that most of the data revolves around the mean of the data set. Now let's see how this works. So we'll click on descriptive statistics, we'll click on OK. Now because I want to calculate descriptive statistics for these three variables, height, weight, and grade, for my input range, I will select all of them together. Now my first row consists of column headers, basically labels. So I'll click on this. My data is in columns, so that's why this is fine. If it would have been in rows, I would have selected this. Now let's calculate all of them. For the kth largest, basically this would give me the second largest observation because I've selected 2. kth smallest. This will give me the fourth smallest observation. Let's have the results on a new worksheet. Let's click on OK. Let me just zoom in a bit. Now, on using descriptive statistics, I've got these different metrics calculated for each of these height, weight, and grade variables. So, for example, mean for height tells me that the average or the mean height in the class is 175.2, whereas for the weight it's around 151.4. Then if I look at standard deviation over here, standard deviation is slightly high. So we've got skewness over here. Skewness usually describes a measure of dataset symmetry or lack of symmetry. A perfectly symmetrical dataset will have a skewness of 0. Similarly, kurtosis tells the degree of peakedness of a distribution. If the kurtosis is close to 0, then it is assumed that the data is following a normal distribution. Then we've got measures of spread over here, range, minimum, maximum. So if you look at maximum and minimum, and if you subtract this, you'll get the range over here. Similarly for weight, 161 minus 141 is 20. Uh, then looking at some just sums all the heights together, this sums all the weights together, this sums all the grades together. Count gives me the number of observations over here, so it's 10 for each of them. Now we wanted to look at the second largest. So if I just go back to my data, the second largest observation is 179, the largest is 180. Now for smallest over here, I've got 174. We wanted to look at um, the fourth smallest observation basically. So if you go to data, you've got three observations on 171, and then the fourth one is 174. Now, one thing to note over here is if we change anything in our underlying data, we'll have to calculate these statistics again, as this option is not formula driven. Now, I'll just delete this and then we'll look at the second option. Now, the second option which we'll go through is correlation. Correlation gives us the degree to which two variables are related to each other. For example, with the increase in age, the height of a child also increases, thus making age and height positively correlated. If the variables are inversely proportional to each other, then they are said to be negatively correlated. One of the very simple examples for a negative correlation is your account balance. So, as your expenses increase, your account balance decreases. So, they are moving in different directions. So, that's a negative correlation over there. Now the correlation values lie between -1 and 1, and a correlation of 0 indicates that the variables are not correlated, but it does not mean that they have no relationship. Now to use this tool, again we need to fill in the information in almost similar fashion to what we did for descriptive statistics. So let's just see how this works. Data analysis. I'll go to correlation, click on OK. For the input range, because I want to have the correlation between height and weight, height and grade, weight and grade. So I'll just select all of them together. Labels in first row. Let's give the output in a new worksheet. Click on OK. So this gives me a sort of a 3x3 metric over here. What it is showing me is that definitely relation between height and height is 1, weight and weight is 1, grade and grade is 1. So you can ignore these three values. But if I want to look at the relationship between weight and height over here, it is 0.95. So there's a positive correlation between height and weight. And if you look at in the underlying data also, as our height also increases, the weight also increases. So for example, at a height of 180, the weight is 161. At a height of 179, the weight is 159. and at a height of 171 the weight is at its lowest at 141. So there's a positive correlation over there. Now another correlation over here is between height and grade, which is sort of negative correlation. So what we are seeing is that with an increase in height, the grade is decreasing. Looking at weight and grade, we see a negative correlation again, but it's not that strong as compared to what we had for height and grade over here. Now let me delete this, and then we'll move on to the next option. Now covariance measures the change in one variable when the other variable changes. Covariance can be negative or positive, and its value can range from minus infinity to plus infinity. Now let's go to data analysis. Covariance. Okay. Again, you need to select the data in the same fashion as what we've done so far. New worksheet. Labels in first row. So now we've got covariance between these variables. One thing to note over here is that when you change your data, you will again have to calculate these statistics as they are not formula driven. Let me delete this. Next, we'll move to rank and percentile. Now, as the name suggests, this option can be used to get rank or percentile for each of the observations in the data set. Now, I've got some random data over here, 20 observations, and let's say I want to rank them, starting with the highest one getting the first rank. So all I need to do is I need to go on data analysis, rank and percentile, click on OK. For input range, we select this. Okay, labels in first row. Let's get output over here only. So over here in this column, I've got the data points sorted in a descending order. Uh, this particular column gives me the position of these data sets in the original data set. So for example, if I apply filters and then sort them, so now you can see that they are in the same order as what they were appearing in the original data set. Let me just sort them back, remove the filters. Over here, I've got the ranks 1, 2. For observations which are of same value, it will give the same rank and then it will skip the rank after that. So that's why we don't have any observation having a fourth rank. Then we've got 2 on 5, then nothing on 6, 7, 2 values having 8 rank and so on. This particular column over here has the percentile which basically returns the nth percentile from the set of values. So how to read this is that over here it says that 100% of my values are less than equal to 70. This over here tells me that 94.7% of the values are less than equal to 69. 84.2% of the values are less than equal to 68 and so on. Now let's move on to the next, which is sampling. I've got some random data over here, some 100 observations. And sampling basically helps me in generating a random sample. Now let's see how this works. Now let's just select this entire range first. Now there are two sampling methods. One is periodic, in which we'll have to mention a number which is less than the number of observations, and then Excel will pick each observation after that interval. So let's say we specify 5 and let's click on output range, this worksheet itself. Select the output range as this and click on OK. So now you can see the first observation is 53, 1, 2, 3, 4, 5. Then 63 is the second observation which has been picked up over here. 1, 2, 3, 4, 5, 87 third and so on. Let's look at the other way, which is random. Now over here we'll have to specify the number of observations we want in our sample. So let's just say 10 observations. And again, I'm keeping the output range same as E1. Click on OK. So now I've got 10 random observations picked up from this data set. Now the next option which we'll discuss is the moving average. So basically a moving average is used when we've got time series data, that is data which has been taken over time, like electricity expenditure over days, or say stock price of company ABC, or units sold of a particular item over time. Now moving average is used to smooth out the short term fluctuations or maybe seasonal fluctuations and highlight longer term trends. Now I've got this monthly data over here for 24 months for a company which sells a product, and over here in column B we've got the sales being done in each month. Now let's see how moving average works. Click on OK. Our input range is this. Because we want to smoothen out this particular series of units sold, or we want to see the trend of this. Now let's for interval take 3. So how this works is for 1, 2, 3, Excel will calculate 56 plus 58 plus 78 and then divide it by 3 and put it in front of the third time period. For the time period 4, Excel will then calculate 58 plus 78 plus 87, then divide it by 3 and then put it in front of 4. So it will calculate a 3-month moving average for consecutive months. So the output range, let me just select over here. Let's see, it comes over here. And yes, I'll have the standard errors also. Click on OK. So this is how my data set will look like. This is my moving average and this is my standard error. Let me just format them. Right. So now in front of time period 1 and time period 2, there is no moving average, and that is because we've supplied an interval of 3 months. So for Excel to give a moving average, it will need at least 3 months of data. Now because 1 and 2, we do not have any months preceding them, so that is why Excel gives an error #NA. Then for the time period 3, it gives a moving average of 64, which if you can look over here, it's a formula driven one and it is based on the average of these 3. If you move on to the next cell, then it is based on the values or the units sold in second month, third month, fourth month. For 5, it is on the base of third, fourth and fifth month and so on. The standard error over here basically shows the variation between actual values and moving average values. Now let's plot them on a chart. Let's plot a line chart. Markers. Just remove the grid lines. Now if you look at the graphs closely, the blue line is the actual units sold, whereas the amber line is based on moving average. So moving average does remove some of the fluctuation over here. So instead of going up and down almost every second month, we see that the units sold peak somewhere between 4 to 6 months and then start decreasing and then again increasing. We'll conclude this particular session over here. And in the next session, we'll discuss some of the statistical tests which are present in data analysis, and we'll also cover regression. Thank you. Hi, welcome back. Now, in the previous session, we had explored some options like correlation, covariance, sampling, rank, and percentile. In this session, we'll discuss some of the tests which are available in Excel, and then we'll also discuss regression. Now, the first test which we'll discuss is ANOVA, and it stands for Analysis of Variance. Now, let's say I've got a class which has 30 students, and they've been divided in three groups of 10 each. Each of the groups is assigned a different math teacher, and then the exam results are assessed to see if the students get the same marks irrespective which teacher taught them. So this is my group A marks, this is my group B marks, and this is my group C marks. And the null hypothesis is that the means across these groups is same. Now the odd thing is that this is ANOVA, which stands for analysis of variance, and our null hypothesis is based on means. But why it is called ANOVA is because we are analyzing variance over here, and thus we will be inferring about the mean or the population. So let's see how this works. I'll go to data, data analysis. I'll click on ANOVA single factor. So this is our data over here, labels in first row, and let's have the level of significance at 5%, which is 0.05, and I'll have the output in a new worksheet. Click on OK. So this is how my output will look like. Let me just format it a bit. Now for each group, I've got the number of observations, I've got the total number of marks, basically the sum, I've got the average number of marks, and I've got the variance also. Now the second table is the ANOVA table. Uh, this is the source of variation between groups. So this is the sum of squares for between groups. This is the sum of squares for within groups. This is my degrees of freedom. So in total, I had 30 observations, and now I'm left with 29 degrees of freedom. So in very layman terms, just to think of how degrees of freedom works is, let's say you've got 10 numbers and you want that the sum of these 10 numbers needs to be equal to 100. Now for the first 9 numbers, you can select any number you want. You can select 10 or say 11 or 15 or whatever. But for the last 10th number, you would have to ensure that the number needs to be such that the sum for all these 10 numbers is equal to 100. So that is why for 9 numbers, you've got freedom. So this is a very layman explanation of degrees of freedom. Then you've got mean sum of squares over here. So basically this is calculated by sum of squares divided by the degrees of freedom. Then you've got the calculated f over here, which is this divided by this. And this is the p-value, and this is the f critical or f tabulated value at 5% level of significance. Now in order to test the hypothesis whether this is significant or not, we will compare these two values. So since f calculated, that is 2.422, is less than f tabulated or f critical 3.54, we cannot reject the null hypothesis that all the marks are equal. We can also compare the p-value with the level of significance. Since this is greater than 0.05, which is our level of significance, we cannot reject the null hypothesis. F-test. Now an F-test is used to compare two population variances. The null hypothesis is that the variances of the two populations is same, and the alternative hypothesis that the variants are not same. Let's assume we've got 20 students in a class who are divided in two groups based on their gender, and we need to see if the study hours are different for both the groups or not. So over here I've got the study hours for both the groups. Let's go to data, data analysis, F-test. Variable 1 would be this, variable 2 labels. Let's have this at 5% level significance. Click on OK. So mean is a descriptive statistic, same as variance. So these are my descriptive statistics over here. Then I've got 10 observations. Degrees of freedom is 9. Now my F calculated over here is 0.7948, whereas my F critical is 0.31457. Now this F is calculated by dividing 6.888 by 8.667. Since this F calculated is more than F tabulated or F critical, we reject the null hypothesis that there is no difference between the study hours of the male and the female population. Let's move on to the third test, which is the Z test. Now, this test is used to compare means of two sets of data to see if there's a difference. So, our null hypothesis is that the means are same, whereas our alternate hypothesis that the means are not same. And now we've got marks of 24 students before and after taking maths coaching classes. Now let's see if there's a difference between the mean of the two populations. So what we'll do, we'll go to data analysis, and we'll use a Z test. Now, one of the prerequisites for this particular test is that you need to calculate the variance also. So let me just cancel this. So I've calculated the variance for both these samples using the formula var.S. So this will give the variance of the two populations. Let's go back. Variable one range, variable two range. Let's say that the mean difference is 0. Let's calculate at 5% level of significance and the output at new worksheet. Click on OK. Now over here I've got the mean, I've got the variance, I've got the number of observations. We were testing for the difference between the mean of the two populations as 0, or basically saying that the mean of the two populations is same. Now using the p-value over here, we can compare it with the level of significance alpha, which is 0.05. Since this value is greater than 0.05, we cannot reject null hypothesis, and we accept that the mean of the two populations is same. Now t-test is used to test the null hypothesis that the means of the two populations are same. This test is used when the number of observations in our samples is usually less than 30. For greater than 30, we usually prefer the z-test, which we've just discussed. Now there are three types of t-tests in Excel. The first one is paired to sample for means. That is when the population or sample on which the test is being done is same. For example, marks obtained by a group of 10 students before maths coaching class and after taking maths coaching class. That is, the sample population is the same 10 students, just that their performance is being compared before and after an event. Then we've got two sample assuming equal variance. That is when the samples are different, independent of each other. Let's say, for example, two groups of 10 students being compared with Excel, assuming equal variance. The third one is two samples assuming unequal variances, just similar to two sample assuming equal variance, just that over here the variance is either unknown or different. Now the null hypothesis can be that the mean of the two samples is same, in which case it is a two-tailed test. For a one-tailed test, null hypothesis can be mean of population A is greater than mean of population B or vice versa, with the alternate hypothesis being that the means are different. So we'll over here test that the means are same, and the alternate hypothesis that the means are not same. So for a paired two sample test, We'll go to data, click on data analysis, click on OK. Let's put this to 0. Now comparing T statistics this with T critical, T statistics is greater and hence we reject null hypothesis and conclude that the difference between weight before and after is not due to chance. Let's look at the second t test with unequal variances or where the variances are not known. So we've got 24 students over here, their marks with tuition and marks without tuition. And these students are independent of each other, so they are not the same students. Let's put this to 0 again. Click on OK. Since T stat is less than T critical, we do not reject the null hypothesis and conclude that the means of the two populations is same. Now let's move on to the last part of the video, which is regression. Now regression is used when we want to estimate the relationship between two or more variables, a dependent variable and independent variables. In simple terms, the independent variables will form an equation which helps in estimating the value of the dependent variable. Over here, the salaries are dependent variable and we've got two independent variables. One is successful projects and age. So let's say we want to estimate salary on the basis of these two variables. So we'll go to data, we'll go to data analysis, regression, click on OK. Input Y range is this, input X range is this, labels, confidence level is 95%, which is fine. And then we'll click on OK. Now in the first table, regression statistics, we've got R square as 0.925, which implies that the model or the equation which we have created over here using the two variables, successful projects and age, that particular equation can explain 92.5% of variation in the dependent variable. The maximum value of R square is 1. So the closer our R square to 1, the better our equation. Now, how to identify the equation over here? So we've got this as our constant plus into successful projects plus into age. So this is our equation. So this is an intercept term over here. This is always going to be constant, then for each and every successful project, we'll multiply it by 903.04738822. Basically, this is a coefficient for successful projects, and for age, we've got the coefficient as 891.88. Now, to see if both these independent variables are statistically significant or not, we look at their p-values, and these p-values should be less than 0.05. Over here, if you look at the p-values, they are very less as compared to 0.05. Hence, all three of these variables are statistically significant. If one of these variables is not statistically significant, then we need to delete that variable and start with the entire model building or equation building again. Now, having discussed regression, we are now through most of the options in data analysis. If got any questions, let us know. Thank you. Hi, welcome to the first session of VBA. We have two main objectives from this session. One is learning how to record a macro, and the second is writing basic programs so that you start understanding the structure of VBA programs. For someone who is new to VBA, recording a macro is the best place to start understanding VBA programs and also to see how your actions in an Excel file are converted into programming statements by VBA. Now, while covering these topics, we will also discuss objects, their properties, their methods, and then we'll also touch upon declaring a variable and the different data types which are present, the advantages of declaring a variable, and some rules around declaring them. I will keep moving between PowerPoint slides and the Excel file, and I'll be sharing these slides at the end of each video so that you can then play with the VBA programs at your end and also have some reference documents. But before moving on to how to record a macro or how to write a macro, the first question which may have come in your mind is where to write a VBA code. So let's get started with it. I'll now move on to the Excel file. So I've got this file, VBA file open. Now, if you go to the developer tab and click on Visual Basic, now this has a shortcut as well, Alt plus F11. So whenever you click on it, this new window opens up. This second window, which sort of has opened up now when you clicked on Visual Basic, is called the Visual Basic Editor. It has got different components. So if you look at these bars, the file and these buttons over here, these are called the menu bars and the toolbar. And they've got a lot of commands which we can use while we are programming in VBA. So for example, if I look at file over here, it has options like save the file, import file, export file, print, or close and return to the Microsoft Excel file. Similarly, if you look over here at debug, it has got options which help you in debugging a program. So apart from this toolbar, I've got this project window over here, and I've got this notepad sort of, if I may call it, over here. So if I look at project window itself, so what this tells me is that right now there is one Excel file which is open, and this particular Excel file has just got one sheet in it, which is named sheet 1. So sheet 1 has its own code module, so I can write codes for sheet 1 itself over here. If I want to write some codes related to the entire workbook, then I can write in this workbook as well. But usually we do not write in either of them. So for writing a code, what we do is we go to insert and we insert a module. So this is where we write most of our codes. Now you may be asking a question that sheet 1 program editor over here looks exactly the same as this workbook program editor, and that is also same as module 1. But why do we write our VBA programs in module 1 and not in sheet 1 or this workbook? Now it's considered a good programming technique or standard if you write programs in modules rather than writing over here in sheets or workbook. And there are definitely benefits of writing codes in modules. So for example, if you write a code in sheet 1 code module and you accidentally delete sheet 1, then all of your code which is there in sheet 1 code module will get deleted. One of the other advantages of writing codes in module is that you can import or export modules to other Excel files also. But there are times when we write codes in sheets modules or this workbook module, when we have VBA programs which are just dealing with specific sheets. So for example, if I had more than one sheet over here and I just wanted to write a VBA program for sheet 1, then I will write it in sheet 1 code module. Whereas if I have a VBA program which is dealing with the entire workbook, then I will write it over here. There are some programs which are called event handler programs, and this is something which we will discuss in the later sessions. So think of an event as an action. Whenever you do anything in an Excel file, it is considered as an action. So if I want to write a VBA program which is based on some action happening in sheet 1, then I will write those event handler codes in sheet 1 code module. Similarly, if I want to have event handler codes which are dealing with the entire workbook, say opening a workbook or closing a workbook, then I will write those programs in this workbook code module. So now that we have discussed where we write a VBA program, we'll now move on to the main topic, which is how to record a macro. So I'll go back to the PowerPoint now. So as you can see over here, when you go to the developer tab and your cursor is on record macro, so this states each of the commands you perform will be saved into the macro so that you can play them back again. So as I said, for someone who's relatively new to VBA, record a macro is the starting point, as then you can see whatever actions you do in an Excel file, how they translate into VBA programming statements. So let's get back to the Excel file now. So before actually recording a macro, I'll just click on this and we'll see what sort of pop-up we get. So it gives you options like what sort of name do you want for your macro. So let's keep it first macro. So for this particular option, shortcut key, we can give a letter over here to call the macro. So similar to the shortcuts which we have, say for copy or cut. So for copy, we've got Control plus C, or for cutting something, we've got Control plus X. Similarly, you can write anything over here, say P. So when you press Control plus P, it will run first macro. But let's just keep this blank for now. Description over here, it can be left blank, but if you want to add some description to your VBA macro, then yeah, you can do it over here. When you click on OK, and before stopping the recording of the macro, whatever actions you perform in an Excel file, they will be recorded in the VBA program. So let's click on OK. So now whatever actions I will do, they will keep on getting recorded in the VBA program, and you can stop recording from here. Let's say I want to take my cursor to D4. I select D4 and now I'll click on stop recording. So let's see how this transforms into a VBA code. So I'll go to the program editor now. I'll click on Visual Basic. So as you can see, we had named our macro as first macro, and we just did one action, that is we selected cell D4. So over here, all VB has done is it has referred to cell D4 by using range, and then all it has done is select this particular cell. So now let's go back to our pack. So as we had seen in our first recorded program, that how VBA translates selecting a particular cell is using the range keyword over here. So for example, if I want to select all the cells between A1 to B6, so this will be my command. So if I write range A1 to B6, let's see how this will translate over there. So let me just escape this and copy this. Now I'll go back to my Visual Basic editor and I'll replace this with it. So when I'll run this, you can run the program from here. This is run sub or user form. When you click on run, so as you can see now all the cells between range A1 to B6 have got selected. Now let's go back to our PowerPoint. Similarly, you can select two ranges also, so it's not always necessary that all the cells need to be together. Then you can also select the entire columns. So if you look at range A to column E, so we'll select these 5 columns A, B, C, D, E, and we'll select all the cells of these columns. If I look at range 1 to 3, that is used for selecting the first 3 rows, 1, 2, 3. So we'll end up selecting all the cells in these rows. Now, just like we've got range over here, we can also use cells also. So for cells, the syntax would be cells followed by row number and then column number. Over here, it was just the name of the cell. So for example, cells 2 comma 4, which is basically my second row and my fourth column. So my fourth column is D. So this will translate into my range as D2. Similarly, we can use range and cells together. So for example, this will translate cells 1 1 will be A1 and cells 4 4 will be D4. So this will translate as range A1 colon D4. Now let's talk about selecting cells. So in the first example, we saw that for selecting a cell or when we move the cursor to cell D4, VBA used a keyword dot select. So over here, we are just selecting one cell name, say A1 or D4. Over here, we can select multiple cells just like what we have seen previously. So over here, we are referring to multiple cells. If I just put a dot select after them, then I'll end up selecting all of them. Now in the first two examples where we are selecting one cell and multiple cells, we are passing cell addresses which we need to select. But one of the advantages or why VBA is used across industry is for its automation. And when we are doing automation, we may not always be sure of which cell we are referring to or which row we are referring to or which column number we are referring to. So in the third example, I've got my row number as dynamic. So my column name, I'm aware of my column name and my row number is my macro name. Ampersand tells VBA that we are dynamically sending some value. Similarly, if the column number is dynamic, column name over here is the macro name or the variable name which I'm going to pass on dynamically, and row number is what I'm aware of. So we will look at one example where we will be dynamically sending row numbers later in the session. Now let's go back to Excel and let's record another macro. We'll open two files and then we'll see how the code is. Let it be called macro2. Click on OK. Go to File, Open. So I'll open this module 10 VBA events and user form. So this is one of the files which I've opened. Now I'll go back to the original file, which is VBA file. Now I'll open another file. Open. Let's open module 10 VBA.xlsm. And now again, I'll go back to my original file. Now I'll click on stop recording. And now we'll see what the VBA code translates to. So just before we jump on to the VBA code, now that we've got three files opened over here, in this particular window, we can see that there is one file, module 10 VBA events and user form, which is open. Then there is another file, module 10 VBA.xlsm. So this particular second file has 4 sheets in it. This one particular file has got 5 sheets in it. But let's just go to our workbook, which is VBA file.xlsm, and see what the VBA code was recorded. So the first action was that we have opened a workbook, module 10 VBA events and user form.xlsm. So how this has worked is workbooks.open, and then this is followed by a keyword file name, and then this is the entire path of this particular file. Then what we did, we returned to our original file, which was active window, activate next. So this automatically activated our VBA file.xlsm as we went back to it. Then when we went back to VBA file.xlsm, we opened another file, which was module 10 VBA.xlsm. And then we went back to our original file, VBA file.xlsm again. So now what I'll do, I'll just close the other two files. So let me go back. So this is one of the files which I'm closing. I'm closing module 10 VBA also. Now I'll go back to my program. Now if I'll run this, both the files which were earlier opened, they will open now again. When I'll click on run, So as you can see from here now that I've got the events and user form which is open, and I've got module 10 VBA.xlsm. So both the files have now opened, which you can see VBA file. And if I go to switch windows, I've got module 10 VBA which is open and module 10 VBA events and user form. So all the files have opened. So this is how VBA can be used. By recording your steps once, you can run those steps again and again, and Excel will perform the same operations, and then you do not need or require any manual intervention. Now over here we've just opened two files, but what if we want to copy some data also from these two files to our file VBA file.xlsm. So let's see when we record a macro how this will look like. So let me just close the other two files now because I want to record that particular action also. Now I'll click on record macro again. Let it be called macro 3. Okay. I'll go to open. I'll open events and user form file. Now in the events and user form file, I'm copying this data from sheet Excel underscore table. And now I'll go back to my original file, VBA file, and I'll click on paste. Now I'll again go back to my file events and user form and I'll close it. Now I'll again go to open. I'll open the second file, which is module 10 VBA. Now in module 10 VBA, I've got data on sheet 3. I've already copied the headers from the first file, so I don't need to copy them again. So I'll just copy the data and I'll go back to my original file and I'll paste it here. Now again, I'll go back to module 10 VBA. I'll close this file and now I'll stop recording. So let's see how this VBA code looks like. Visual Basic. So this is my macro 3. So over here we are opening the first file, module 10 events and user form. Then if you may remember, we initially put our cursor on cell A1 and then we started copying by moving our cursor to the right side, and then we selected the rows by clicking on the down arrow. So all these actions are being recorded over here. Then my selection was copied. Then over here I went back to my original file, VBA file.xlsm, and I pasted because my cursor was already on cell A1. So whatever I had selected from my initial file, it got pasted, and I then selected the next cell, which was cell A5. Then I went back to events and user form, and over here I closed this file. I then opened the second file, which was module 10 VBA.xlsm. I selected the range from A2 onwards because if you may remember, we did not copy the header, which was in the first row. So we selected everything from row 2 onwards, and then we copied that. We again went back to our original file, we pasted it. Then we sort of removed our cut copy mode by pressing an escape key. We then went back to our module 10 VBA.xlsm, we closed it, and then in our original file VBA file.xlsm, we just selected the first cell A1. So now I've got this macro. Let's see if I run this macro, will those same steps or will the data get copied automatically? So for that, I'll first delete this data. Now I'll just run this. So as you can see, all the data has got copied properly. Now I'll go to sheet 1 where I've written this VBA code. This is the first VBA code. So in module 2, we had a command like this. I'll just copy this. If you look at it, this particular command is same as this command. It is just that this particular command is using a keyword file name. But if you omit file name and you use brackets, then you are good to go. So this was the first macro where we opened the two files, events and user form and module 10 VBA.xlsm. Now, this is the macro where we are copying data from the two files. So all we are doing is we are opening the first file, events and user form. We are going to sheet Excel table. We are copying the data from the range A1 to E4. Once we've copied, we go back to our original file, VBA file.xlsm. We go to sheet 1 of this particular file. As there is just one sheet over here, we select cell A1 and we click on paste. Then we go to our second file, module 10 VBA.xlsm. We go to sheet 3 of this file. We select data from A2 to E4. As the first row consisted of headers, column headers, which we had already copied, so we did not copy them. We copied this data. We went back to our original file and we pasted the data over there. The last thing what I've done over here is I've just closed the two files, events and user form and module 10 VBA.xlsm. So this code is exactly the same as what we had recorded over here. Just that over here I'm specifying the worksheet names and the file names properly. So that's about it. But otherwise the two codes are exactly the same. In the initial example where we were copying the data, we were sure that our data is between A1 and E4 or A2 and E4 only. But say if I've got 100 files and all these files have varying data. So one has say 100 rows of data, the other one has 20 rows of data. And I've got a task to copy and paste the data on a daily basis. So every day it will not be possible for me to open each of these files and select the range or pass the range over here in my VBA program. So this is where the need arises of dynamically passing the range. So all I'm pretty clear about is that, okay, my data will start from second row or first row, but in order to calculate till which row my data is present, I use a function called count_a. So this particular way of dynamically passing ranges is something which is used across industries, as automation saves a lot of time, thus increasing productivity of both the company and the employee as well. So now let's assume that I'm pretty clear that my data will start from column A. And what count_a function does is it will count the number of rows in column A which are populated. And on the basis of that, it will return me a value. So let's just run this and let's see how this works. So let me just clear this first. And I'll run this one step at a time so that you know what I'm trying to say over here. So I'll click on step into. So step into is one of the options which is used while debugging a program, but we'll discuss that later. But let's just see how this works. So now this opens the file, and right now in my file module 10 events and user form, this particular sheet Excel underscore table gets activated, or basically my cursor goes to this particular sheet. Now, right now, my last filled row is 0. So as soon as I run this particular command, you will see the value of last filled row changing. So now if I hover my cursor over last filled row, it shows 4. So basically what this tells me is that in column A, I've got data till row 4. Now I'll just reset it. So now this particular value last filled row will be passed on dynamically to this particular range. Now my range will be A1 to E4. What if my data was till say 6? So it will dynamically pass it to A1 colon E6. So this is how you can pass on values dynamically. I will be providing this particular code along with the deck so that you can play around with it. And if you have any questions, then do let me know. Basically, a VBA macro or a VBA program is the same term for a subroutine or a procedure. So sub keyword is used to start the macro program, and this keyword is then followed by the name of the macro. In the parenthesis, which you can see over here, just after the macro name. So usually these are kept blank, but a list of parameters can be supplied. And if there are no parameters, then anyways they are left blank. This particular parenthesis, then we've got the statements over here, whatever we want to write. So initially in the first recorded macro, we just selected one cell. So it was range d4.select. That's about it. When we were opening the two files, so we had more syntaxes where we were using workbook.open and etc. Then once you've written your program, you end your program with end sub. So let's look at the first program which we had recorded. So as I had said, starts with sub, macro name followed by parenthesis, my statements over here, and ends up to end the program. You can comment any statement by just using an apostrophe. So once it shows this green color, it means that it has been commented out. It will not be executed by VBA. Now let's go back to the Excel file. I'll close this events and user form, and let me see if the third file is also open. No. Okay, so this is the only file which is open now. So I'll go to the developer tab. Now we discussed the Visual Basic, that it opens a Visual Basic editor, and we've also discussed record macro. But if I want to have a look at all the macros which are there in the workbook, I'll click on macros, and this gives me a list of all the macros which are there. So it is telling me that I've got first macro, macro 2, macro 3. Then I've got these different macros which are there in sheet 1 code module. You can run a macro from here. You can even edit or delete them. Let's click on cancel. Macro security. When you click on macro security, this trust center will pop up. So usually it is disable all macros with notification. Most of the times this is the case, and whenever you open an Excel file, Excel will always prompt you that do you want to enable macros or not. If you think that the file is from a trusted source, then please enable it, else do not enable it. It may have virus. Now let me go back to the deck. Now VBA is an object-oriented language. If you think of it, everything is considered as an object. So a workbook, a worksheet, cells, ranges, charts, pivots, they all are considered objects. And all of these objects have properties and methods. Now, whenever you use these objects, you need to do so in an orderly manner. So if there is no workbook, then a worksheet cannot exist. Similarly, if there is no worksheet, a pivot table or a graph cannot exist. Initially, you'll have a workbook, then you'll have a worksheet, and this worksheet will consist of ranges or pivots or charts. And this particular hierarchy is called an object model. Let's go to Visual Basic. Comment this, comment this, comment this, but copy this. So over here, we've got application, which is the Excel file itself, then the workbook, which is this particular workbook VBA file.xlsm. This is then followed by worksheets. This is followed by the sheet name over here. This is then followed by range or the cell location A4, and this is giving the value. So all we are saying is that in workbook VBA file.xlsm, we've got a sheet 1, and on sheet 1 for cell A4, we want to assign it a value of 5. So this is an object model where we are following a particular hierarchy. If I have a worksheet before workbook, that will not work and that will just give an error. Let's go back to the deck. Now, all objects have properties, and a property can be thought of as a setting or an attribute. For example, for chart, which is itself an object, it has properties like chart title, chart type, legend. Similarly, range has properties like value, count. So over here, value property, using this property, we can set a value of a particular cell, which we did in the previous example, or we can read the value from a particular cell to a new variable. So for example, over here, what I'm doing is I'm assigning a value to variable new one, and that value will be the one which is in cell A1. Similarly, count property is there, so you can count the number of cells which are in the range A1 to A10, or you can count the number of rows over here, or the number of columns over here. Now, just like all objects have properties, they have methods as well. A method is an action that is performed using an object. If I take a weird example, so think of a car wiper. One of the actions is that it wipes the water off the windscreen. So that is a method. So for range, we've got methods like clear contents, delete. For charts, we've got methods like activate, select, before double click, etc. Now let me go back to the Excel file. So this is one of the examples where we are assigning a value of 5 to cell A4. So not only values, we can also assign formulas also. So let's take an example. Suppose I've got 1 and 2 over here. And for cell A4, I want the sum which is there in A1 and A2. If I run this, I've got value 3. And as you can see, now cell A4 consists of formula also. Let's go back to our deck. Now let's discuss declaring a variable. In one of the examples where I was dynamically passing the values of rows, I'd used a statement dim. Let's just look at it. So what I'm doing is I'm declaring my variables over here, last filled row as long, last filled row 1 as long, and then new row as an integer. Now the rules around declaring a variable name is that the length should not exceed 40 characters, there shouldn't be any space between them, and there shouldn't be any special character used as well. Now the question you may be asking is, why is it important to declare a variable? It's considered good programming technique. It removes chances of unexpected results as we are letting VBA know what a variable type is, and it makes code more readable for other users as well. These are some of the different types of data types we have. So we've got integer for small numbers, we've got long for big numbers. So for population, I might have long, or I might even have a double. So with this done now, I'll close this session, and in the next one, we'll discuss conditional constructs and looping constructs. Thank you. Hi, welcome to the second session of VBA. Now in this session, we'll look at conditional constructs and we look at looping constructs. Now, just like any other programming language, VBA gives us these constructs which we can use in our code and then achieve a particular objective. So first we'll go through the conditional constructs. Now there are two statements over here, if then statement and if then else statement. Now the first one, if then statement. Now you can check one condition, and on the basis of that then run one or multiple statements if the condition holds. So what we'll do, we'll run this particular code in our program editor and we'll see how it works. So now what this condition is saying is, if in worksheet sheet 1, so we've just got one sheet over here in this particular Excel file, which is sheet 1, cells 2 comma 1, that is row 2 and column A. So basically cell A2, if that is UK, then cell 2 comma 2, which is my B2 will be London. So how the if condition works is if condition then statements followed by end if. So this is how the if condition works like. So now let's run this and let's see if we get any output in cell B2. Nothing. But let's write in cell A2 UK. So as you can see now London is coming. If then else is also very similar to if then. This also allows just one condition to be checked, but then it has two blocks of statements or two statements, out of which one will run depending whether the condition is true or not. So for example, in our case over here, if cell A2 has value of US, then in cell B2 we'll have Washington DC, else in cell B2 we'll have not US city. So if the condition is true, then whatever statement follows then that is performed. If the condition is false, then whatever statement is followed after else that will be performed. Let's run this and see how this works. So I'll just copy this and paste it. So right now in A2 we have blank. So when I'll run this, I'll get not US city. Let's say now I put US, and now when I run this, I'll get Washington DC. So now we'll move on to the looping constructs. Just like VBA allows for conditional constructs, it also allows for looping constructs. So these constructs allow Excel to repeat the same task for a specified number of times. The first one which we look at is for next. This loop is used for a fixed number of times. In the below code, row num is a variable which has been declared as integer, and it will run 50 times till value 50 is reached, increasing by 1 each time. So let's see how this works. I'll just copy this and paste it here. Let me just clear my Excel file first. So over here, I've got row num declared as an integer. So this is where my for loop starts. So I've got for row num is equal to 1 to 50. That is, it will keep on looping and will loop 50 times, incrementing by 1 every time. Let's just run this. So now as you can see that it has run 50 times and I've got value still row 50, because our condition was cells row num comma 1 is equal to row num. So when row num is 1, this will be 1. So first row, this is my column. My column is always going to remain as column A or column 1. Then when the loop goes again back to row num, now the value has incremented to 2. This will change to 2 and so will this. Similarly, then again the loop will go 3, 3, 3 and all the way till 50. So this is how for next works. Let's look at the next one. The next one is do while loop. This is like for statement, just that it will keep on looping till the condition is true. So till the time I is less than equal to 10, it will keep on looping again and again. It is incrementing I by 2 every time. As soon as I goes over 10, it will stop looping. So let's copy this program and see how this works. Pasted it now. And let me clear my Excel file. So now over here, we've declared I as an integer. The initial value of I is 1. Do while till the time value of I is less than equal to 10. This will keep on looping again and again. So let's see how this will work. Okay, so this has given an error because we don't have any sheet 2. So let me just change it to sheet 1. So it has given me this output 1, 3, 5, 7, 9. And that is because you started with 1. So first time when it passes through do while, the value of I will be 1. So this is 1, 1. So A1 is equal to 1. Then the value of I is incremented by 2. I now takes the value of 3. It again go backs over here. 3 is less than equal to 10. Now the value of I over here is 3 and this is 3. So that's why we do not have any value for second row, but we have value for the third row. Next time when we reach this statement, the value of I is then incremented to 5, then again to 7, then to 9. So that is why we don't have any values for 2, for 4, 6, 8. Let's go back to our deck. Do until loop. Now this is like do while statement, just that it will keep on looping till the condition is not met. So if you remember in do while we had do while I is less than equal to 10. Over here it will keep on looping till I does not attain the value of 11. So in this particular example itself, if we change this condition from 11 to 10, because I will never take an even value. In the previous example, we saw that when we start with I is equal to 1, initially the value will be 1, but then it is incremented by 2. So now the value becomes 3, then it becomes 5, then 7, then 9, then 11. So I will never attain the value of 10. So this will keep on looping till the time the value of I reaches to 32767, and that is because we have declared I as an integer. Moving on. Now do loop while and do loop until. Now these test the condition is true or not after the statements have been executed. So the loops will run at least once, even if the condition was not true. And this is how they are different from do while loop and do until loop. Now if you remember in the do while loop and the do until loop, we had these condition checks at the very beginning before the looping also. Whereas over here we've got this condition check once the program has already executed. So I will be giving these codes, just play around with them, make changes to the values and see how they change your output. The last one which we'll discuss over here is the case construct. Now, as I had mentioned earlier, this is similar to an if statement, but the if statement just allows one condition to be checked. Over here, if you look at this particular example, it says select case. So this is just the syntax select case, which you'll have to write. Select case worksheets sheet 1 cell 2 comma 1 dot value. So basically value for cell A2 is being checked. If this value is UK, then for B2 it will be London. If this value of A2 is US, then it will be Washington DC. If it is India, then it will be New Delhi. So you can check numerous conditions rather than just checking one condition, as was the case with if then or if then else. We can see how this works. Let's paste it. So let's say my value is UK. So it gives London. What if I change it to US? It gives Washington DC. What if I change it to India? It changes to New Delhi. Let's go back to the deck. So these were the conditional constructs which you can use in VBA programming. I would recommend you to copy these codes itself and start running at your end to see what sort of output you are getting. Make some changes to these codes itself and see how they are impacting, and then slowly and steadily start using them in your basic programming. Thank you. Hi. So in this session, we'll discuss custom functions. One of the advantages of VBA is that you can create your own functions using macros and then call those functions in Excel and use them just like you use normal functions in an Excel file. So let's say I want to calculate the area of a circle, and Excel does not have any function which will give me an area of a circle. Now, area of a circle is pi r square, where pi has a value of 3.14 and r is the radius of the circle. So now all we need to do is we need to go to our program editor and we need to click on a module. Now in the program editor then we need to write a function. Now how a function is declared is it starts with function and it ends with end function. Followed by function we give the function name. Now the functions will have some arguments which will be declared in the brackets. So over here we just got one argument which is radius, and double is one of the data types which, if you may recall, we've gone through earlier. So now in this particular line, all you're doing is you are showing how to perform the calculation. So you will be passing for this particular function or formula area, you will be passing radius. But how will Excel use this particular radius to calculate area? So over here you're passing that formula. So radius, as you know, is pi r square. So pi has the value of 3.14 and then r squared. So basically radius into radius. So this is 3.14 into radius, and then we are ending the function. So we've written the function syntax over here. So now let's go back to our Excel. Go to formulas. In formulas, let's look at user defined formulas. So in the user defined, you can see you've got your formula area written over here. I'll click on cancel. Now I will call this particular formula just like I call other formulas using an equal to, then the formula name, bracket open, and the only argument which I'm going to pass is radius. So I've got the radius, I'll close the bracket. I've got value of 78.5. Similarly, I can copy this and then I can use it to calculate area for a circle having radius 10, 20, and then 50. Now we'll take another example. So we'll go back to our developer, Visual Basic. So I've created this particular function over here, new SP. So what I'm doing is I've got an old selling price. I've got some percent and I want to calculate the new selling price when there's been a discount given on the old selling price. So for example, if the old selling price was 100 and the discount which has been offered is 25%, so now the new selling price will be 75. So over here, I've got two parameters or two arguments. One is the old selling price and the other one is the percent discount which I'm getting. So I've created this particular function. I'll go back to my Excel. I'll click on formulas, recently used, insert function. Let's see if I've got my new SP over here. So yes, my new SP is appearing over here, and over here also it's showing that it has two particular arguments, old selling price and percentage. So all I need to do is I need to call this function and then I need to pass on these two parameters. I can then copy and paste. So over here, as you can see, if a particular item is of say $50 and you are offering a discount of 20%, then that item will cost now $40. Similarly, if an item has a cost of $100, you are offering a 30% discount, the new selling price would be $70. So this is how you can create your own custom functions or formulas in Excel. Now, before we move on to the next session, I'll have some exercises for you to do on this. If you have any queries, then do let me know. Thanks. Hi, welcome back. Now in this session, we'll discuss three things. First, we'll discuss the different types of errors. Following this, we'll then discuss the different error handling techniques. And lastly, we'll then discuss how to debug a program for identifying errors. So let's get started with the first topic, which is different types of errors. Now in VBA, errors can mainly be classified into three different categories. So the first one is called the runtime error. The second one is compile error, and the third one is logical error. Now a runtime error occurs when the code is executed and there's a type mismatch. As such, there is no issue or no problem with the syntax. The syntax is all fine. So if you look at in the example below, this particular program was run on an Excel sheet which just had two sheets, sheet 1 and sheet 2. But over here we are referring to sheet 5. So that is why we get a runtime error. Let's move on to the second type of error, which is compile error. Now, a compile error occurs when one of the statements has not been typed correctly. So if you look in this particular example, we've got worksheet. So we are missing a T and a S basically to complete worksheets. So that's why Excel gives a compile error. And you know when Excel is giving a compile error or a runtime error. So for a compile error, it will have the message compile error, whereas for a runtime error, it will show the message runtime error. So let's run these programs in a VBA editor and then we'll see what sort of error we get. So I'll go back to my Visual Basic editor. I've already written these codes. So right now this particular Excel file just has one sheet, sheet 1. And over here I'm referring sheet 5 in here. I'll select this entire code and I'll go over here and just click on run. It gives me a runtime error. If I click on debug, it points me to the line which has error in it. So now I can just reset this code. Similarly, for my compile error, I've got this particular example where I'm missing T and S from worksheets. So VBA gives me a compile error and it highlights the keyword which it thinks has error in it and it says sub or function not defined. I'll again reset it. Now let me go back to the deck. Now the third kind of error is called a logical error. So basically this is nothing to do with missing a T or S or referencing to a particular sheet which is not there in an Excel file. It is all to do with the logic of your VBA program. So for example, if you want to create a VBA code for summing two numbers and instead of summing you are using a minus operator, then this is called a logical error in layman terms. So this may result in the code giving unexpected outputs. So in VBA, all the errors are classified into these three categories. Now let's move on to error handling techniques. Now the obvious question which you may be asking is what is error handling or why is it important? Now in layman terms, error handling is handling of a VBA error. That is when you have executed a VBA program and if a error is encountered by VBA, so how do you handle that situation? Using error handling, you can either suppress that error so that the code runs or executes normally after the line where the code had error in it, or using error handling, you can also have functionalities built in which will skip the rest of the code and come to a set of predefined lines and execute those lines. So now we look at a couple of ways by which error handling can be done. So let's go back to the VB editor. Now over here I've written this program. If you ignore this particular line, let's just comment it out for now. All this program is doing is we've got a macro named T2. It has a variable y which has a value of 2. Then we have a variable x which is y divided by 0. And then we have a variable z which is y divided by 1. And then we are just ending this program. Now if I just run this program, Excel will give me an error that division by 0 is there. So now as you can see, there is no error in the syntax. If I debug it, it will take me to the line where this error is. Let me just reset it. Now if I uncomment this particular statement, so what this tells me is that if there is an error, resume the next statement. So right now I know that this particular statement will have an error or will give me an error. Using this particular statement on error resume next, the error will be suppressed and I will not get any error. Let's see how this works. So now I executed this particular code and I did not get any error. Now let's see if I place this statement after the line which had error in it. So now till here, I don't have any error suppression going on. My error suppression will happen from this line onwards because my statement on error resume next has started from here. So let me just run this. So now you can see, because there was no error handling or error suppressing technique before this erroneous statement, now I'm getting an error. Now let me write another program. So now let's see if I run this program, will I get any error? Yes. Now the error which I will get over here in this program will be on the basis of this particular line, not this particular statement. Because for this particular statement, I had a error handling statement which was suppressing the error. But whereas over here using on error go to 0, it removes the suppression of errors. So now I'm getting an error. If I click on debug, it will highlight the second line. Now using resume next or go to 0, this is still fine. So one suppresses the error and other removes any suppression of error if there was done in the program. But the most efficient way of handling an error is using go to label. So I've got this program over here. Now if you just concentrate on the program first, it has if worksheets sheet 5 again. It's the same program which I had over here. Sheet 5 is equal to UK. Then worksheets sheet 1 cells 2 comma 2 dot values equal to London. So if cell A2 in sheet 5 is UK, then cell B2 in sheet 1 will be London. Let me just comment this part out. So if I run this, I'm getting a subscript out of range error, which I know, which is because I don't have any sheet 5. Now if I uncomment this, I'm getting a prompt now that error has occurred. So what is happening is, let's just look at this code. So we have declared over here that whenever an error occurs, go to error jump. And I've got my error jump code over here, which is, it will give me a message box which has error has occurred written on it. So once the execution starts and we come to this particular line over here, VBA realizes that there is no sheet 5, so it immediately gives an error. And because we had said that on error go to error jump, so it skips this particular line, this particular line, this particular line, and immediately goes to this line, and then it displays this particular statement, which gives me a message box. Now if you look at a normal VBA program, it starts with sub and it ends with end sub, and VBA will run any statements which are between sub and end sub. But when we use this sort of error handling technique, the code is executed till exit sub. And if an error occurs, then only Excel will jump all the statements and go straight to our error handler, which is declared after exit sub. So these are a couple of ways by which you can handle errors. Now let's look at how to debug an error or how to identify which line is giving me an error. So let's get back to the deck. Now debugging an error, there are different ways by which you can identify the errors in the code and resolve it. So with breakpoint, what happens is, suppose we've got this code over here. If we've selected this particular line, so when I start running my program, this line will get executed, this line will get executed, and my execution will then stop at this line. Now, if these first two lines, or say 3 lines or 4 lines for other programs, they run error free, then I know that the error will be from this line onwards to the end of the program. So let's look at an example. I'll just put some value in A3. So let me just put a random string. So let me just walk you through this program first. So the name of the macro is debug1. I am declaring two variables, d1 as date and d2 as string, that is it can consist of text. Now for d2, I'm giving the value in A3, which is www, and in d1 also I'm giving the value of A3 only. Now d1 over here I've put in as date, but the value of A3 is www, which is a string. So technically this program should give me an error. So let's see, when I run it, I'm getting a type mismatch error. So now if I click on debug, it will automatically take me to the line which has error in it. But let's use first breakpoint. So let's say I put a breakpoint over here in front of D1. So what I'll do now, I'll run the program and the program will get executed. If my error does not come over here, then I know that my error will be in the lines after this particular block of statements. So let's run the program. So now my code has come back over here, and now I know that so far for these 3 lines I did not have any error. So my error would be in this line. So this is how, using breakpoint, you can break your code into different parts and then run each of those blocks and see where or which line the error is. Now let's just reset it. Now stepping in technique is the second method which is used for debugging an error, and this is one of the most easiest way, and I really find it useful also. So let's go back to the Excel file and then I'll explain how this works. So again, we've got the same program over here. Now for using step in, we just click on this program, and to step in you go to debug and you can click on step into, or you can also use the shortcut key which is F8. So when I do it the first time, it will take me to the first statement of the program. Then when I do it again, because dim d1 and dim d2, we are just declaring the variables as such. There is no particular operation we are doing over here. So the control shifts to d2. Right now the value of d2 is null. Now the control shifts to d1, but as you can see, the value of d2 is now www, which was the value in cell A3. Now if I do a step into again, I get an error. And this is because D1 was declared as a date, whereas cell A3 consists of a string. So using step into, you can go to each and every statement and see how the values are being passed throughout the entire program, whether the values are being passed correctly or not. And then as you keep on going through the statements, you will come across the statement which had error in it, or because of which you got the error prompt, and then you can fix that statement. So this is all what we have for this particular session. If you've got any queries or any questions, please drop me a note. Thank you. Hi, welcome back. So now in this session, we look at form controls. Now, if you look at this particular screenshot, to go to form controls, you need to go to the developer tab. Then you need to click on insert. Now you've got form controls and ActiveX controls. So in Excel, you've got two types of controls, form and ActiveX. Over here, we'll just be discussing form controls as they are the ones which are used more often as compared to ActiveX controls. Most of the controls in them though are common, but form controls are easier to use, whereas ActiveX controls provide more flexibility as they are new. They've got more formatting options, but they've got certain downsides as well, like they may not be recognized straight away by Excel when you open it, or they keep on getting updated themselves as the underlying data changes. One of the other disadvantages of ActiveX is that it is not recognized by Mac. Now let's go back to an Excel file, and then we'll just look at how to use these form controls and how they look. So developer tab, insert. These are my form controls. So I've got a button over here, combo box, check box, spin button, list box, option button. This is a group box. This is label. Then I've got scroll bar. So let's start with button. So you just click on it and then you can just create it on the Excel file. Whenever you plan to use the form control button, you always need to have a macro in place already so that you can assign that macro to this button. So let's say I'll assign capital city. I'll click on OK. So whenever I'll click on this button, my capital city macro will get executed. Let me just change the text, edit text. So if I run this, I've got UK over here in A2. So I'll have London in B2. As you can see now, we've got London in B2. Let's look at label. Now label is similar to button, but it is more often used to put in front of another control to explain what that control stands for. So I can do a right click, edit text. So this is just a very lame example. So we've got this box in front of button. So the user knows what this button will do. Let's look at checkbox. Let me create more checkbox. So you can have as many checkboxes as you want, and these checkboxes are independent of each other. So if one checkbox is checked in, then it will return true or false to a linked cell. So let's just do a right click, format control. So right now it is unchecked. Let's just link it to a particular cell. Let's say I link it to A5, and 3D shading just helps with the visual appearance, nothing more as such. Let's click on OK. So now when I'll click on this, so this is basically checked in, this is true. If I untick this, this will become false. Similarly, I can do a right click, format. I can link a cell to this also, and 3D shading. Okay. So this is how checkboxes can be used. Then you've got these options of checked or mixed. So right now by default, these are unchecked. So if I do a check, so by default, this will be ticked. If I do a mixed and click on OK, so this is how it will appear. If I assign a macro to it, let's say assign the same macro capital city. Okay. So whenever I'll click on it, it will execute the macro. So this can also be used to execute the macro. Let's move on to the next one, which is option buttons. So these are the option buttons over here. Just copy and paste it. Let me just do a right click, edit text, male, female, and then do a right click, format control. link it to a particular cell. Now the difference between checkboxes and option buttons is that option buttons are dependent on each other. So one of them will be ticked or checked at one time. So if I select female, I cannot select male. And when I had linked this to a particular cell A13, this automatically got linked to that same cell A13. So after you've linked this to a particular cell, that particular cell will give the number of the option which is currently selected. So right now we've selected the second option, so it is giving 2. If I select the first option, it will give me 1. Now let's look at list box. Let me have some items in place first. So I'll go to insert. Do a right click, input range, and cell link, and let's have selection type as single, 3D shading, click on OK. So now I can see the different options over here which were in my input range. So now if I click on any particular value, say F, so the link cell gives the serial number of this particular option in my input range. So it was at the 6th position over here. Now let's look at combo box. This is also very similar to list box, just that it has a drop down. So over here in a list box, we can see multiple options, but in a combo box, we'll just be able to see one option at a time. Let me have the same input range. Cell link, let's keep it this. 3D shading. Click on OK. So now I can see A, B, C, D, E, F, G, H till 8. Let me just do a format control. If I change this to 5, I'll just be able to see till E now. A, B, C, D, E, then definitely I can scroll. So at one time I can just see 5 options. So if I click on any, again this will just give me the number of that particular selection in the input range. Let's look at another one, spin button. So this will allow you to increase or decrease value of a linked cell by a predefined amount. So it can take values up to 30,000 and it should be positive. Let's say the current value is 0, the minimum value is 0, and let's change this to say 100. Link the cell, this one, and click on OK. So you can see on pressing this will get incremented. On pressing this will reduce. The last option is the scroll bar. This is also very similar to spin button, just that over here we can scroll this. Let's see how this works. Let's say maximum value 30,000, incremental changes by 500, and let's link this particular cell. Click on OK. So as you can see now, you can increase or decrease by just a scroll. So you can assign macros to all of them, but these are just some of their uses. Now, when we look at user forms, we'll use some of these controls and we'll use the knowledge of events also, which we'll discuss in the next session. So treat this particular session just as an introduction to these controls. When these controls or some of these controls are combined together, they create a user form. If you have any questions, then do let me know. Thank you. Hi, welcome back. Now in this particular session, we'll discuss about events. Now, There are two kinds of events in an Excel file. One is a workbook event and the other one is a worksheet event. But before jumping on to workbook and worksheet events, we'll just discuss what events are. So any action you do in an Excel file is considered as an event. So it may be like opening a workbook or going to a specific worksheet, editing a particular worksheet, entering data, saving or closing a file. All of these are considered as events. We can use these events or actions by adding VBA codes to make Excel perform in a certain way. These VBA codes are then known as event handlers. So, for example, uh, let's say I want a greeting message of good day whenever I open an Excel file. Or let's say I want to automatically capture the date and time and the name of a person whosoever opens a file to some other location so that I can make an audit trail of who all are opening a particular file or have access to a particular file. So I can do all of these things using events. Now, if you may recall in the first session where we were discussing the Visual Basic Editor, I had mentioned that normally the codes need to be written in modules, and just that whenever the codes are related to a specific sheet or the entire workbook, then they need to be written in either the sheet code module or the this workbook module. Similarly, when we are writing codes which are based on events, say event for a particular worksheet, that will go into that particular sheet code module. Similarly, if I want to use event for the entire workbook, then I will write that VBA program in the this workbook module. Now to look at the different types of workbook events we have, so we'll go to an Excel file. We'll go to the developer tab, Visual Basic, this workbook module, and I've got workbook over here. This particular drop down will give me a list of events which I can club together with my workbook. So for example, workbook activate. Over here, I've written a code of workbook open. So we'll discuss this later in the session. Similarly, workbook for sheet activate or workbook event combined with before deleting a particular sheet or before double clicking. So you've got this list of different events which you can add a VBA program to and then make it useful for yourself. Let's go back to the deck before discussing this. Now, some of the most used workbook actions that trigger the event. So, open. So, basically, whenever you open the workbook, activate. Whenever the workbook is activated, so you've got four different workbooks, and you move to a particular specific workbook which has this event in it, or which has a VBA program to handle this event, then this will get executed. Before close, that is when you are about to close the Excel file. Before save, when you are about to save an Excel file. New sheet, whenever a new sheet is created in the workbook. Sheet activate, whenever any sheet in the workbook is activated. Then sheet change, any worksheet in the workbook if it is edited or changed by a user. Then you've got window activate, any window of the workbook is activated. So you've got these different types of workbook actions, and you've got events corresponding to them. So now you can add some VBA programs to it and then use these events to achieve some objective. Now over here, I look at some of the event examples. So workbook open is one of the most widely used event. So for example, if I want a greeting message as soon as I open my Excel file, I can use a workbook event. So for example, if you look at this particular code, private sub workbook open. So I'm using the workbook open event over here. So let's see how this works. Just do an escape. I'll just copy this part and I'll just comment the existing code which I have. Now before pasting, I'll do workbook open. I'll now paste this. So now what I'll do, I'll save this My file is module 10 events.xlsm. So I'll close this. I'll close my Excel file. Now I'll go to my file explorer. I'll open this file. So now as you can see, I've got the message hello with today's date and current time. So this is how you can use these events for your own benefit. Now let's just remove this and let's uncomment this. This particular code, which I'll just walk you through, is used quite often in the industries where people want to keep a check or tab on who is opening a particular file. So over here, what we are using is we are using the workbook open event. So whenever someone opens this particular Excel file, so that particular username is passed and that is through the system. So if I'm opening this file, VBA will take the username, my username automatically from the system. It will take the current date and time. It will open another workbook which is kept at a particular path, and this workbook is module 10 VBA.xlsm. For adding more complexity, if this workbook is password protected, I can also pass the password through this particular statement. Then in this particular workbook itself, which Excel opens, I will activate this workbook, or basically VBA will activate this workbook, and it will look at the last entry in column A, so that when it now it pastes in the row after the last entry. So basically in a new row which does not consist of any information. So that value has been given as I. Now in this particular workbook VBA.xlsm, it goes to sheet audit. To the value I, it just adds 1. So basically moves my cursor or my cell to the new row. It gives the username, and to the corresponding column in the new row, it gives the current date and time. Then it saves that particular file and closes that file. So if someone does not know that there's a macro behind opening this particular workbook and tries to access this to take some data out, I can easily go back to that particular file module 10 VBA.xlsm to check who has opened this particular file. So this sort of technique or audit trail is usually used in industries where you've got one Excel file and there are multiple users who are opening that file, or you've got access to that file. So let's see how this works. So I've got this macro now. I'll save this. I'll close this. I'll close this Excel file also. So now I'll click this. Now on the face of it, I do not know anything. I've got this file open. I have no idea that another file also opened. But let's just go to module 10 VBA. As you can see, the entry has now popped up that someone opened this file at 8:43 on 14th of June. Let me just comment it out. You can also use conditional constraints like if then else statement also. So now I'll just walk you through this program. So right now we are using the if condition over here. So whenever this workbook will open, VBA will check this particular if condition. If today's date, we are considering over here Sunday as the first day of the week. Let's keep it to 4. Then message hello and now. Let's see if this works. I'll close this and now I'll open this. So as you can see, I've got this prompt now. Again, let's go back to developer, Visual Basic. Let's just delete this. Similarly, you can write programs to say select a specific cell whenever the Excel file gets opened, or take the user to a particular sheet. So using workbook open, you can do quite a lot of different things. Now let's go back to our deck. So now let's look at workbook new sheet and before save event examples. So for new sheet event, this particular procedure will execute whenever a new sheet is added to the workbook, and the sheet is passed to the procedure as an argument or a parameter. Now, because a new sheet can be either a worksheet or a chart sheet, this procedure determines the sheet type. So if it's a worksheet, it inserts a date and timestamp in cell A1. So over here, it is passing the sheet and it's checking the sheet over here using if condition and type name sh. If this is worksheet, then range A1 or cell A1, we'll have sheet added and now date. So let's see if I run this. Now let's get back to our Excel file and let's add a new sheet. So immediately you added a new sheet. It's now given you a prompt sheet added 14th June 2017 at 8:50 p.m. Before save event, this event triggers just before the workbook is saved. So as soon as you press Ctrl plus S or click on save button, the event will trigger. Now over here we've got an example where we are looking at if the file is being saved for the first time or not. Because if the file is being saved for the first time, then it will throw the prompt of save as. Otherwise it will do not throw any prompt, it will just save the file. The prompt of save as will also be thrown if the file is in read mode only. So what we are doing over here is if this save as appears, then we will get a message box that save the file in .xlsm, that is macro enabled format for enabling macros. So I'm not running this particular example. I'll be sharing this deck so you can run this at your end and just see how it works out. I've got another example for before save event. So I've got this code. Now I'll be providing this code with the deck so you can add more stuff to it and you can just play around with it. So before we run this, let me just add some dummy values to my data. So I'll go to Excel file sheet 1. So what my code is designed to do over here is that my column A and column B are equally populated or not. By equally populated, I mean that all the rows are populated or not for both column A and column B. So for example, in our case, I filled 4 rows of information for column A. For column B, I've just filled 3 rows of information. So this code will then give me an error before I save. So let's just see how this works. So I'm not running this. All I need to do is I need to click on save. So it gives me an error that workbook will not be saved unless column B is not filled. Please make sure all columns are filled with respect to the names. So what this code is doing is it is first of all defining a variable I, and this variable I is taking the value of how many rows have been populated in column A. This is one of the ways by which we can calculate how many rows are populated, and using count a function also we can determine the same thing. So in our case this value comes out to 5 because column A has been populated till the 5th row. So J will execute from 2 to 5 and Z will take the value of number of rows populated in column 2 and Y will take the number of rows populated in column A or column 1. If Z is not equal to Y, then I get this message box. If Z is equal to Y, then I will not get any message box. So let's see. Now if I click on save, it gets saved. So this is again one of the ways by which you can use before save event. So you can make sure that your data is properly filled or not. Now let's go back to our deck. Now worksheet events. These events are for individual worksheets and hence are stored in the code module of the worksheet for which we plan to use them. activate when a particular worksheet is activated for which this code has been written, before double click when the worksheet is double clicked, before right click when the worksheet is right clicked, calculate when the worksheet is calculated or recalculated, selection change, the selection on the worksheet is changed, and etc. To look at the different types of worksheet events, go to the VB editor. Let's go to sheet 2. So I've got my worksheet over here, and over here I've got these different events which I can use. Let's go back to my deck. So over here I look at a couple of examples. One is worksheet change. So whenever there is any change which happens to the worksheet, this event will trigger. And the other one is whenever a particular worksheet is activated, so this event will trigger. So now worksheet change event, as I mentioned over here, it will trigger whenever a specified range or cell in a worksheet is changed by the user and not by the formula. So let's see how this works. Let's just copy and paste this. So now I've got this particular code in sheet 2 code module. So let's go to sheet 2, and as per the code, if we change anything in B to G, then it will trigger. So let's say, so as you can see, I've got the current date and time. If I do any changes over here, then again, but if I do any changes in column H, then it will not trigger. Now let's go back to the code. So over here, target is the argument or parameter, and it has been defined as a range object and refers to the cells which will be changed, or in our case, which we had changed. So in our case, we had changed B4 or we had changed F6. So now that we made the changes to cell B4 over here, target variable will now hold the value of B4, and then using this particular intersect function, VBA is then checking if there is an intersect, that is common cell between the target and the range. So our range is BG whereas our target is B4. So definitely there's an intersect. And then using not and nothing, it's just basically like two negatives when multiplied together make a positive. So if there's an intersect, then in the target row, so over here our target was B4. So for B4 cell, the row is 4. So fourth row, cell 1, we'll have now, which will give me the current date and time. Worksheet activate. So this event will execute whenever we go back to a specific sheet. If you look at this example below, it just throws a message box that do not delete the formula. Now, knowledge of events and form controls is something what is used in user forms. When we'll be doing user forms, there would be a couple of more event handler codes which we'll use over there. If you've got any questions, then do let me know. And yes, I'll be giving some exercises around worksheet events. So yeah, please do go through them. Thank you. Hi, welcome back. In this particular session, we'll discuss user forms. Basically, a user form is a dialog box, or think of it as a form which is custom built and it's based upon the requirements or data which is required by the end user. Now, before I go ahead, I will show you a user form first so that you can easily relate to it. So for that, I'll go to an Excel file. Now in this particular Excel file, I've got two user forms and we'll go through both these user forms in this particular session. So let's say if I click on fill form, my user form appears. Now this user form has fields like name, age, gender, email, monthly bill, country, then some options of whether the customer or the person is contactable through email or not. So there's a yes or no checkbox. And then you've got some command buttons So when you click on OK, something will happen. When you click on cancel, the entire user form will disappear. When you click on clear, whatever data the user has filled in these fields will disappear. So I'm sure you may have come across forms similar to this in your personal life where you may have entered your name, your age, your email addresses, etc. In Excel, we can build these tools using VBA and we use some of the controls which we have already discussed. Now, the coding around building a user form is not that difficult. One just needs to have some basic understanding around events and using these different types of controls. So I've got over here, this is a label. Over here, this is a text box. This is again a label. This is a combo box and so on. So whenever someone decides to create a user form, the first step is to have a clear idea as to why it is required, so that the design of the user form can be built around that. Once the requirements have been finalized, then one can go ahead and design the user form and write the relevant VBA codes. So now, as I said, in this particular session, this is one of the user forms which we'll discuss. And there is one more user form, country and states. We'll discuss this as well. So let's go to the developer tab, Visual Basic. So over here in this particular Excel file, because we've got two user forms, so we've got two different forms. Inserting a form is similar to inserting a module. You go to insert and you click on user form. So as soon as you click on user form, a new form will start appearing over here. Right now, the name of this particular user form is user form 1, which can be seen in this properties window over here. So the name is user form. For every user form, you'll have a toolbox also. This toolbox has different controls which you can use. So it has labels, it has text box, it has combo box, list box, check box, option button. Then you've got frame over here, you've got command buttons over here. Then you've got a scroll bar, you've got a spin button. So these are the different controls which we have already discussed earlier. Now, what we'll do using these controls, we'll first of all design a user form. And then in the next part, we'll concentrate on writing VBA programs. So for example, if I call my first user form fill form, so right now this is empty. But if I click on this drop down, I've got these different options. So a user can select any of these ages. Similarly, for my country, I've got these different options in a list box. So once we have designed the user form, we'll see how to write VBA programs so that we can add values to the age combo box over here or to the country list box over here. So let's just cancel it for a while and let's go back to our user form one. So right now this is a blank user form. I'll just enlarge it a bit. This is used for basically selecting objects. So let's just select label first. Now the job of a label as such is nothing, but it acts as a header or a field name. So for example, in my first user form, name has been mentioned in a label. Similarly, age also has been mentioned in a label. So a user will know that over here in this field, we are required to fill name. Over here in this field, they are required to fill email address. Over here, they are required to fill monthly bill. Over here, they are required to select a country. So the job of label is sort of to act as a header or a field name rather than anything else. So that once you have inserted a label over here, you can go to the properties window. You can change the name, but this will not change because this is directly related to the caption field over here. So as soon as you change in caption, you bring it to name and you click on anywhere else. So now the name starts appearing over here. Let's select another one. Let's put it as age. So you can change it directly from here also. And as you can see now, the caption has also changed automatically. Similarly, you can change this also. Now let's put a text box in front of name so that a person can then enter values in that text box. Now I'll name this as name text box. A text box will not have any caption because this is going to be a field where a person is going to enter data. Let's for age have a combo box. Now my combo box will have a drop down of different ages as we saw in the first form. Let's just rename it to age. Now let's insert another label. Let's call it gender, and let's add option buttons to it. Now these names, say for male, or over here I've got this combo box and over here I've got this text box. So these names we'll call in the VBA programs because this is what the user is going to either tick or untick or fill data in. Using the properties window, so over here you can see that the height for this particular option button is 29.25 and over here it is 18.75. So you can make sure that there is consistency by changing it, say from directly here 18.75, and then you can drag and drop, and then you can also see from here where it is actually situated. So it's on the left side, and then you've got these different options over here. How far is it from the top? 120. Whereas how far, if we look at how far is this one from the top, it is 114. So if I change this also to 114, they will be in line. Let's change the name for this one also to female option button, and let's change the caption to female. Similarly, let's add a frame. The use of a frame is also as such similar to the use of labels. They are there to sort of act as headers or field descriptions. And we'll change the caption. So basically in a frame you can have controls which are similar to each other. Let's just add checkboxes over here. Again, you can make sure that they are aligned correctly using these options over here. You can also change the font, the way these are appearing. So right now it is this particular font. You can select. You've got these different options. Let's just put this yes checkbox. This to yes. This to no. And this to no again. Now the last thing which we'll add to this particular user form is a command button. Now I'll tell you the use of these command buttons over here. So let's say if a user enters data and he has entered all these different options. Now at the end of it, he would want to submit these details, or either he would want to clear these details, or he would want to cancel these details. He can do that by clicking on OK or cancel or say clear. So whenever someone will click on OK, an event will get triggered. So we will then use that particular event and we'll add some VBA program to it so that whenever someone clicks on OK, some statements will run which will either save the data somewhere or they will delete the data or something. Let's go to our first form, which was customer calling for complaint. Let's cancel this from here. And this is my particular user form. So this is how my user form looks like. I've got a name label over here, and corresponding to the name label, I've got a name text box so a user can enter details over here. Similarly, I've got a age label over here, and for the age label, I've got a age combo box. Then I've got a gender label. Corresponding to gender label, I've got two option buttons. One is male option button and the other one is female option button. Then I've got email label. Corresponding to email label, I've got email text box. Then I've got monthly bill. Now corresponding to monthly bill, I've got a bill text box and I've got a bill spin button as well. Now, if you may recall, in the sessions where we had discussed form controls, we had also discussed spin button. A spin button can be used to increment or decrement values in a particular cell. Over here, spin button will be used to increment decrement values in this text box. So let's just go to the original form and see how this works. So if I click on the above arrow, this will start increasing the numbers and this one will start reducing the numbers. So we'll write a code such that whenever someone changes this, there will be a change over here also. Then moving on, for country label, I've got a country list box. I'll show you in the original form. So this is a list box. I can see different options over here. Now I've got this frame over here, contactable through email, and this particular frame has two checkboxes. One is yes checkbox and the other one is no checkbox. And at the end, I've got three command buttons. I've got a OK command button, I've got a cancel command button, and I've got a clear command button. Now, as I said earlier, once a user has entered data in the entire user form, using OK, I would want that data gets saved in another sheet. When a user clicks on cancel, irrespective he or she has filled data here or not, I would want the user form to disappear. And clear, whenever a user has entered some data and they want to clear whatever data they have entered over here, they can click on clear. But by clicking on clear, the user form will not disappear. So let's just see how this user form actually works and then we'll look at the coding also. So we'll go to fill form. Let's add in some values over here. Let's say the name is ABC, age is 25, male, email address abc@abc.com, monthly bill 26. Let's select the country as Russia, contactable through email, yes. As soon as I'll click on OK, all my data will be stored in sheet 2 and my user form will disappear. So my sheet 2 has this entry now, ABC 25 male, abc@abc.com, and the rest of the details over here. Similarly, let's look at cancel and clear. Let's just fill ABC and I want to cancel it. So I'll just click on cancel. Now the user form disappears and there is no entry over here. When I'll click on fill form again, let's just say I filled an ABC and I want to clear this. I'll just click on clear. So my data is removed from here, but the user form does not disappear. Now let's look at the coding bit. Now go to your user form. I've named this user form as customer contact user form. So click on the name, do a right click and click on view code. Now the first part over here is user form underscore initialize. So over here you are going to declare or you are going to write codes such that whenever someone clicks on a button which will make the user form appear, what will be the state or the default state in which the user form will appear. So in our case, when I'll click on fill form, my text box corresponding to name is empty. My combo box corresponding to age is empty, though I can see all these different items over here. Similarly, for my gender, neither male nor female, none of them are pressed. Email address, my text box for email address is empty. Then for my monthly bill, I don't have any values over here. Again, this is empty. For country, I can just see all the items, but there is no one item which I have selected. Moving on to contactable through email, yes or no, both of them are unchecked. So this is the default state in which my user form is appearing. So by initialize over here, we mean that we are just initializing the user form, showing the user form in a default state so that someone can then fill values in it. So over here, I've got my name text box as empty. Let's say if I write AA and now if I go and call my fill form, so now AA is already there present. Even if I clear it, this AA will not go. Let's click on cancel. Again, let's go and view the code. I'll keep it empty. Moving on to age combo box. So by default, my age combo box is clear, basically empty. But my combo box will have these different values 25, 26, 27, 28, 29, 30 and all the way to 40. So this is the way by which you can add values to your combo box using add item. Do make sure that you follow the right syntax. So it starts with age combo box, then you are adding different items and then you're closing it with end with. Now the next we'll discuss is option buttons. So right now my male option button dot value is false. My female option button dot value is also false. Basically what they are saying is that none of them will be pressed. If this value was true, so let's just call the form again. As you can see that none of them are pressed. If I keep it to true, and now if I click on fill form, so now as you can see my male option button is pressed. Let's click on cancel. Again, do a right click, view code. I'll just change it to false again. Similarly, my email text box is empty. Now moving on to our two check boxes in the contactable through email. So I had two check boxes, yes and no. Again, I've kept their default values as false. If I want any of them to be checked, I will change this parameter to true. Then we've got the list box. Now this list box is filled with country names, and again you are adding items to it similar to adding items to a combo box using add item option. So over here you are giving different country names: UK, US, China, India, Russia, France and Germany. Again then you are ending this statement with end with. Finally we have build text box dot value, which is empty by default. So this is how my user form will appear in its default state whenever it is initialized or whenever it is called for. As I had mentioned earlier that once the user has entered data in it, using OK, cancel or clear, we will need to do something of that data. So clear is used to delete the data. So whenever someone will click on clear command button, so I've created a program or an event handler code over here. So whenever someone clicks on my clear command button, I will call user form initialize. So basically I will call this particular program. As soon as I call this particular program, all it is doing is it is putting the user form to its default state. So when you are using your clear button, all you are doing is you are putting your user form to its default state, basically removing any data. Then using cancel command button. So whenever someone clicks on cancel command button, so if you look at it, you've got the cancel command button over here and you've got the event click. Similarly for clear command button, you've got the clear command button over here, and over here you've got the event click. So whenever someone clicks on the cancel command button, I would want the user form to disappear, and that happens using the statement unload me. So whenever someone clicks on cancel, the user form will disappear. Now moving on, this is for bill spin button. Now in our user form, we've got bill spin button over here, which will change the value of bill text box. So whenever someone will increment or decrement, this value will change. Though users can directly enter value over here also, but if someone uses spin button, the values will then change over here. So over here again we've written an even handler code. That's whenever someone changes bill spin button. So I've got the bill spin button and I've got the change event over here. So whenever someone does that, my bill text box value will be equal to my bill spin button value. Last is whenever someone clicks on the OK command button. So as I said earlier also, that if someone enters data, I would want all the data to be stored in sheet 2. I have written a program over here. All this program is doing is, first of all, it is identifying a new empty row. So in our case, the new empty row would be third row because the first two rows are filled. And we are identifying the new empty row using count a function. So this is a function which we have come across earlier also. It counts the number of rows which are populated and then it returns that value. And to identify the new empty row, we are just adding 1. Column A, we are saving name. In column 2, we are saving age combo box value. For column 3, which is either male or female, I'm using an if condition. So if male option button dot value is true, so if someone has pressed my male option button, that value will change to true. Then my column 3 will consist of male, else it will consist of female. My column 4 will consist of email address. Column 5 will consist of my bill. Column 6 will consist of my country. And last but not the least, column 7, that will be again based on whether yes or no checkbox have been ticked. So if someone has checked the yes checkbox, that value will change to true. Then we'll have yes in column 7, else we'll have no. So now this is all to do with the coding for the various controls we have on a particular form. So now this is the coding which goes behind a user form and the different controls. The only thing which now is remaining is a button which would show the user form. So in this particular sheet, whenever I click on this button, my user form will appear. So this is a command button. If I enter into the design mode and I click on this, if I do a view code, the name of this command button is fill form. And again over here, I'm using an event handler. So whenever someone clicks on fill form, I will be making use of this particular statement. This is the name of the user form, customer contact user form, and all I'm doing is I'm showing the user form. Now let's look at the second example, which is country states user form. Now in this particular user form, let me go back to the Excel file. When I click on country states, this user form appears. Right now I've got these three different values, USA, UK, China in combo box. And over here I don't have any value. So this user form will show how we can have value of one particular combo box dependent on the value of other combo box. So right now my value in combo box 2 is dependent on my value in combo box 3. So say I select USA in combo box 1. Now I'll have cities corresponding to USA in combo 2. Similarly, if I select UK over here, my values over here will change to UK cities. Similarly, if I select China, my values over here will change to China. So let's see the coding behind this. In terms of the actual form designing as such, there isn't much. We've just added two combo boxes. And the main objective of this example is to show how you can make combo boxes dependent on each other in a user form also. So let's do a right click, view code. Again, the first step is to initialize the user form so that whenever a user form is called, how it will look in its default state. So over here, I've got country combo box and I've got three items in this country combo box added. So as such, I will not be able to see any value in the default state, but in the drop down, I'll have these three values: USA, UK, China. Now, once the user form has been initialized, I'm then using an event handler code basically, which is whenever my combo box for my country changes. So I've got this country combo box over here. Whenever this will change, so whenever it will change from its default state to say USA or UK or China, then my VBA program will go through the following conditions. So over here, we have declared a variable country name as string. And then for country name, we are giving the value of country combo box. So this value can be either USA, UK or China. My second combo box, or basically the dependent combo box, is called the state combo box. By default, it is set clear. Over here, I'm using the select case statement. So select case country name. If case is USA, then the with state combo box will have these different options in it. If the case is UK, then the state combo box will have these different values to it. And if the case is China, then the state combo box will have these different values to it. The last is the OK command button, which we have. I'm just saving the data in sheet 5, similar to what we had seen in the first example. So now my data has got pasted in sheet 4. I've got USA, Alabama over here. So one thing, so just one thing which I like to point out over here is using this particular command, application.screen updating. So by putting it to false, all I'm saying is that I do not want to see all these calculations happening or these sheets getting activated and then these values getting pasted. So all these will keep on happening at the back. I do not want my screen to be updated while these things are happening. And then at the end of it, I'm just changing the settings again to true, which is the default state. So these were two examples of user forms, and I will give you some exercises and I'll also be providing you with these codes so that you can play around with them. Now, user forms can be used in different ways. Mostly they are used to save data, and then this data then can be analyzed or used in whatever way the end user wants it to. That is all from this session. And if you have any questions, then do let me know. Thank you. Hi, in this video, we'll discuss about locking cells while writing formulas. Now, this is one problem which I'm sure all of us have faced once at least. So let's say I've got two costs over here, cost A, cost B, and I want to calculate the total cost. So that is sum, and it gives me $30. Right now, my formula is referencing these two cells. What if I want to copy this value over here? But now I'm getting $0. That is because now my formula is referencing these two cells. Earlier my formula was referencing these two cells. Now in order to ensure that this formula over here also gets updated, or this value over here also gets updated whenever these two change, I'll need to lock down the cells. So for that, I need to enter into the edit mode by clicking on F2, click on F4 and click on F4. So what we are doing over here is, by making this dollar sign appear for both column and row name, we are locking down these cells, and click on OK. So there is no change to this particular value over here. But if I copy this formula to this, now it's showing me $30 because now I've locked my cells and it is referencing the original cells which I wanted. Let's take another example. So I've got these 5 names over here and I want their corresponding salary from the salary table. So let's use a VLOOKUP. Comma 2, comma false, enter. Now I'll just copy this. Now I'm getting correct values for A and B, but why not for C, D and E? Let's look at the cells which the formula is referencing. So for A, it is referencing from row 3 to row 18, which is fine. For B, now because we've copied this formula from row 3 to row 4, my cell references have changed. Now they've moved from row 4 to row 19. For C, it has even moved one row below what it was referencing for B. So now it has moved to row 5 till row 20. And as you can see in this particular range, C is not present. C is present over here. So that is why we are getting an error. Similarly for D, the cells which are being referred, they do not contain D. D is over here. And the same is the case for E because E is again present above the range. So again, by locking the cells, we can get rid of this problem. So all you need to do is you need to enter into the edit mode, click on F4 so that you've locked the cells and then just copy this formula. Now you're getting the values for all of them. So just by locking the cells, we can easily get rid of this problem. Thank you. Hi. In this particular video, we'll cover 3 functions. The first one is sum, then we've got SUMIF, and the third one is SUMIFs. Now we'll start off with the sum function, and I've got the same example which I will be using across all the 3. So I've got a list of 10 employees. I've got their employee IDs, department, designation, date of joining, and salary. Now the sum function, as the name suggests, it's used to add numbers. The syntax is very simple. So all you need to do is you need to call the sum function and then you just need to pass on the cells which you want to add. Now let's say I want to add up all their salaries. So I will call the sum function and then I will pass all the cells which I want to add and I'll click on enter. This gives me a value of 443k. So this is the sum of their salaries. So sum function is pretty straightforward. Now let's move on to the SUMIF function. Again, the idea behind this function is exactly the same as of a normal sum function, just that with this particular function, we can also check for criteria. Before jumping onto the example, let's just look at the syntax for this particular function. So SUMIF, the range over here is for those cells on which you want to check the criteria. The criteria over here is basically the condition which you want to check. And then finally, you've got the sum range, basically the range of those cells which you want to add up. So let's look at this example over here. So let's say I want to calculate salary of all employees in analytics. Now I've got 3 employees over here who are in analytics, and using SUMIF, let's calculate their salaries. So I'm calling the SUMIF function. Now for the range, because this particular column consists of the analytics value, so this will be my criteria range. Now I want to check for analytics. And finally, I want to sum all these numbers. I'm getting 215,000. If I sum them manually, that is what I'm getting. Now over here, you've passed analytics basis a particular cell, right? So instead of this, you can also pass it in a way that it is hard coded. So the result still remains the same. Now let's move on to SUMIFs. Again, SUMIFs is very similar to SUMIF, just that with SUMIF you can just check one condition, but with SUMIFs you can check multiple conditions. If we look at the Syntax for SUMIFs, it is sum range, basically the range of cells which you want to sum. Then this is the range for criteria 1. This is basically my first condition. Then you can similarly follow it up with criteria range 2, then your second criteria, and so on. So let's look at this particular example again. Now over here, I want to calculate sum of salaries of all AVPs in analytics. Now in analytics, I've got 3 employees, but out of them, 2 are AVPs and 1 is an analyst. So I want to sum the salary of these 2 individuals. So let's use SUMIFs. Now first, I'll pass on the range which I want to sum. Then I will pass on the range for my criteria 1. My criteria 1 is analytics. Then I will pass on the range for my criteria 2. And my criteria 2 is AVP. Enter. So I'm getting 155,000. And let's see if I get the same result if I sum them manually. Yes, that is what I'm getting if I sum them manually as well. Now, just like you've got these 3 functions, sum, sumif, sumifs, similarly, you've got count, countif, countifs, and you've got average, average if, and average ifs. Thank you. Hi, there are different data sources from which you can import data in an Excel file. If you go to data and click on get data, now over here you can look at the different sources from which you can import data. So you can import it from a workbook or a text or a CSV file, from an XML file. Then you can also import it from database. Now in this particular video, we will cover 2 sources. One is an MS Access database and the other is a text file. So I've created a sample dataset in an MS Access database and I'll just show you how it looks like. So my sample has got 10 records. It has employee ID, the department, designation, date of joining, salary, and I've got the same data in my text file as well. Now let's go back to our Excel file and start importing the data. So I'll click on get data from database, from Microsoft Access database. Now this is on my desktop, so I'll click on it, importing data. Now a connection is being created. Now I've got this particular table which I want to import. It shows the data which I've got over here. I'll click on load. And now I've got my data over here. By default, it has been loaded as a table. Now I've got another Excel file open. Now in this particular Excel file, we'll import data from a text file. So I'll again go to data. I'll click on from text CSV and I've got my data over here. Click on import. Again, this is how my data looks like and I'll click on load. So this is how you can upload data from different data sources in an Excel file. Hi, I've got this data set over here. I've got a list of 10 students. I've got their gender, age, weight, score. Now, if I want to sort them, say on the basis of their name, usually we apply a filter and then we click on sort A to Z. If I want to sort them on the basis of their age, either I want to do a smallest to largest or a largest to smallest, I can do it easily. But what if I want to sort it by age and by gender both? Because the moment I sort it by gender, this age sorting that just goes out of sync. So for that, we can use custom sort. Go to custom sort. Now over here, I want to put age as my first level of sorting. Then I'll add another level, which is gender. Click on OK. So now over here, what I can see is that my data being sorted by age, but then it is also being sorted by the gender as well. So for age 11, I've got both as female. For age 12, I've got female and male. Now, because you've sorted from A to Z, so that's why female is appearing before male. Then again for 12, I've got a male over here, and so on. Now, using custom sort, you can add more levels. So let's say we add weight. So now the data is sorted by age first, then gender, and then weight. Now, what if instead of the values, I want to sort them by color as well? Now, I've highlighted these two rows as yellow. Custom sort. Now, for age, let me do it by cell color. Let's have this on top. I can put it on bottom as well. Click on OK. So it has put them on the top, and after that I've got my other cells which have been sorted. So using custom sort, you can play around with the data, you can sort the way you want and have a better understanding of the data. Thank you. Hi, in this particular video we'll discuss about hi in this particular video we'll see how conditional formatting can be used to identify duplicate values in a data set. So I've got these so I've got these 60 values. Now if I want to identify So I've got the so I've got these 60 values, and if someone asks me to identify duplicate values in this particular data set, so a normal eyeballing will be time consuming, and I may not I may still not end up getting the results. Now I've got these 60 observations over here, and if someone asks me to point out the duplicate values, it normal eyeballing will be time consuming. So conditional formatting can be used for this. So all you need to go is So all you need to do now I've got these 60 observations, and if someone asks me to identify or highlight all the duplicate values, it will be slightly time consuming for me. So all you need to do is go to conditional formatting, highlight cell rules, go to duplicate values. Now immediately now over here duplicate is the default value which is set up. Now now over here duplicate is the value which is default. And as you can see, it has already identified the duplicate value. So I've got two duplicate values, and as you can see, it has already identified the duplicate value. So $89 is $89 is repeating in 2012 2014. Similarly, $80.2 is again repeating in 2014. Using these particular Using this drop down, you can change the way you want your duplicate values to appear. So if I select green, the appearance changes. Similarly, you can select custom format and then go to fill, and you can select more colors. At the same point of time, you can also select all the unique values, but again over here most of them are unique, so yeah. And similarly, you can also select the unique values as well. Now this particular approach also works on character on characters. So as you can see, it has highlighted the duplicated values. So as you can see, it has highlighted the duplicate values over here as well. Thanks.